Is Cassandra Girdlestone in the hall right now? Okay, yeah, I'm still looking for Cassandra Girdlestone's presentation. Ladies and gentlemen, if you have a presentation you haven't yet given to me, if you wouldn't mind coming up to do so. I'm still looking for a number of you, including Wendy, Lisa, Joan, Brittany, Kate, Ruth, and Lance.
Andrew. Good. Good morning, everyone. Good morning, good morning, good morning. For those of you that are joining us online, it's either good morning, good afternoon, good evening, and maybe for a few of you, good night. Our symposium here started 26 years ago in a one-room hut. There's a couple of the original old-timers that are still here with us. They, like me, have attended every single one. But it's grown. And we've grown to the point where we now have an overflow room. In fact, we're set up to do 2 or 3 overflow rooms as interest has grown in this. So if there's not a seat in here for you, there's a seat in the classroom at the end. And hopefully there'll be time through the day to swap in and out. We've wanted to keep the meeting here in a space that is warm, keeps people together, gives a chance to connect. And yes, UBC has lecture halls that can hold 2,000 people. But it would take away, I think, from what we're trying to achieve here, which is to exchange information, stories, experiences, new data, new findings, and have a chance to network and talk to each other and reconnect. Some I know I haven't seen for a year, and this is the chance to catch up. Others we see more regularly, but this has become a meeting point for so many people in British Columbia to come together. And we appreciate everyone that's online joining and watching as well. For those of you that it may be the first time here on campus, UBC would like you to know and acknowledge that we're on the traditional ancestral territory of the Musqueam people. Our sponsors today, and you may have noticed that it doesn't cost anything for this symposium. Where else can you go to and get a free lunch? And it's really due to the generosity of our sponsors. And that includes our UBC Marine Mammal Research Unit that donates their time, everything from students to staff, the Porpoise Conservation Society that has brought us into this next century and onto the internet, and they deal with all of this sort of work here. We're very grateful also to the Pacific Wildlife Foundation for their contributions, as well as to the Pacific Whale Watching Association. And finally, I also want to acknowledge the Beatty Museum. And for those, you have to be here, unfortunately, but right next door, we have the world's biggest freely suspended skeleton. It's a blue whale. And all of you that are here, you're welcome to go into the museum at the breaks. Just show your name tag, and there's no charge, and you'll be very welcome to explore and look at Big Blue. The meeting today, we've got 37 talks, which is sort of unprecedented. We don't have breakout sessions, the small ones. We're all here to hear what everybody has to say. And we've got speakers that it's the very first time standing up front. And let me tell you, there are bright lights shining. And it can be quite a glare. So we've got undergraduate students here, all the way up to the silverbacks, the tired, and well-tested are up here as well. And so we have a real range. And what has made this symposium so successful is the respectful nature in which information is shared. The respectful nature of asking questions, and something that we hold up as being very important. A couple other notes here. For those that can stay through the entire day, at the end of the day there will be beer and pizza, and you can buy pizza. It's the only thing that's going to cost you anything, and also the beer, and we welcome that chance to speak more with you. For the speakers, we've grouped the talks into themes. I do want to draw attention that at the end of the day, because we want to give time for extra discussion, we're going to get into 2 issues that have really dominated the news. One, certainly over the past couple of years, which is the southern resident killer whales, and the second one, which is starting to come to the public's attention, which is the proposed cull of 50% of all the seals, sea lions in British Columbia. And we'll talk about that at the end of the day. For the speakers, to let you know, you gotta stay here. You can't wander off. We have a mic here, so you don't have to move anywhere. We have a clicker somewhere on here, which you'll be able to use to advance the slides. It should be fairly straightforward. And finally, when it is your turn to come up next, we have a speaker's chair down here just for you. So in order to make things move quickly, we'd appreciate it as the current speaker's coming up, you come down and take the warm seat, or the hot seat is what it's going to become as everyone swaps in and out. I think that's everything. Oh, we have one other notice in terms of the speakers, that Hudson, who's sitting up at the back corner for the speakers, he is putting onto your talks and slides your names and your titles. If for any reason that I, in my typing, misspelled your name, or we don't have your organization correct, you need to tell Hudson. And he's the one on the keyboards putting that in. Hunter, sorry. Hunter. Way to go. Really value you, Hunter. I always wondered who's back behind that wall. I'm sorry. Let's see, so we got that going on. We will have questions. If you have questions, raise your hands. We have a runner, which is Aaron, who's supposed to be down here, sitting here with a mic. He'll be passing that around or holding it. Get your questions so that it's online, and you'll have a chance then to answer questions. And I think that is... And online questions. Oh, and also online questions. So for anybody listening online, we do encourage you to send in your questions. They will be read out here to the people in the room, and there'll be a chance to participate that way.
They can do that on YouTube.
And you can do it on YouTube?
Yeah.
Okay, great. I've only been on this side of the camera. I don't know what it's like on the side of the computer. But we do look forward. In past years, some of those have been the best questions we've received. So with all that as an introduction, I'd like to move forward. Oh, there's one other warning, which is the rubber chicken. And fortunately, I know in this first set, I never have to use it. When we have so many speakers and you tell everybody it's a 5-minute talk. Now, I had one person ask for 7 minutes. Okay, they're going to get 7. But the trouble is we want to get through an entire day, give everybody a chance to speak. And if somebody goes on for 15, 20, 30 minutes, this is not your typical science conference. The idea is to get through, and I used to just stand up and move closer and closer to the speaker, and they just kept talking. And then I discovered that all they had to do was this. And that reaction from the audience would actually stop the speaker. So I do not want to use this, but the chicken is always ready if called upon. Okay, I know I'm terrifying the first set of speakers. Juan, you're good, I'm sure. I saw your slides. Okay, let's start. So I'd like to first call upon Valeria Burgers to talk to us about her work and research on belugas.
Thank you. All right. Hello, everybody. So that is, I hope, advancing, not advancing.
Right. Okay. Try the clicker then. I don't know why it was working.
Not happening. This doesn't count towards the minutes. I don't want that chicken.
Yeah, that's a good sign. We appreciate all of the IT support at UBC for all their excellent work. All right, here we go.
Let's
try it now. Yeah. There we go.
Great. Okay. So 2 years ago at this symposium right here, I mentioned this question. I mentioned that I was working on this question. Do wild belugas use vocal signatures? These are sort of, you can think about them as acoustic or sonic name tags that individuals in an aquatic environment use to recognize one another. And I'm hoping to summarize in the next 5.5 minutes our very recent published paper that offers preliminary evidence that they in fact do. So beluga contact calls have been identified in a number of populations, both captive and wild. So we have pretty robust evidence right now that they are very broadband calls, pulsed, and that they very often have a tonal or pulse component in the audible frequencies, and they're very easy to identify acoustically. The next clip I'm going to play, it's going to illustrate that. That's a contact call. That's another contact call. So very different than the chirps and whistles typical of beluga repertoire. The identity information that one can encounter in contact calls in cetacean societies is very linked to social organization. So when we have socially stable species like killer whales, for example, we can expect shared group-specific calls. And when we have fission-fusion societies, and a typical example is the bottlenose dolphin, individually distinctive vocal signatures are advantageous. And belugas fit this second group of species very well. They have long-term individual relationships with repeated interactions throughout life in the context of very fluid fission-fusion structures. So we can expect that vocal signatures would be adaptive. And we had the fortune to have a situation that allowed us to look very specifically into this question in Cunningham Inlet through 2 seasons, where beluga whales would split from the larger aggregation and get trapped in river canals at low tide for a couple of hours at a time. And this happened repeatedly, so we could record these whales that were producing contact calls predominantly because of that situation of isolation. So 60% contact call production compared to 10% that is typical in free-ranging herds. And we could drone the whales and have a very precise estimate of the number of individuals and group composition in each of these entrapments, which was also key to our study. We divided all of the contact calls that we found in these 14 entrapments into simple and complex. Complex contact calls are all those calls that had a very particular overlapping mixed component, usually tonal or pulsed. And we did this for 10,000 calls, really. This is why it took us 2 years. 80% of those calls were complex. And we created a catalog of complex contact call types for each of the beluga entrapments. So, for example, entrapment 11 had 13 complex contact call types, and you can see each row represents several randomly selected examples of a type. So they're very stereotyped. Overall, we had 87 types, with just 8 of the types shared across entrapments. And we validated our classification using human judges. This is a very robust method used, for example, in bottlenose dolphin studies, in all sorts of cetacean vocalization studies, with a very, and I won't go into the details, you can ask me during the break, because it was very fun to do, but we had a very high inter-observer agreement and a very high agreement with our classification. And we also corroborated our classification quantitatively, and again, the chicken won't allow me to give details, but ask me during the break. The most important thing to mention about the study is that the number of contact call types was directly related to the number of individuals, so that, and it never exceeded the number of individuals, so that an entrapment that had 1 individual had 1 complex contact call type. So our results seem to suggest that there's likely a system of vocal signatures, but what we don't know is whether those vocal signatures are encoded just individually or whether they share those signatures with closely related animals. And data from captivity from my own studies at the Vancouver Aquarium seem to indicate that offspring might sometimes share those contact calls. So the data explains both there can be a strong relationship with the number of individuals in an entrapment either way. And given the stability of matrilineal family units in beluga society in the context of fluid structures, sharing those calls in a family would help keep the group together. So it would make sense. But the answer is we don't know, and we're looking into this in the St. Lawrence using acoustic localization methods and D-tags. And we now have been able to pair the contact call of 1 individual to him, who's Neo, often found in isolation, 15-year-old male. So that's very exciting. And we are analyzing further data from 12 additional D-tags as we speak, so more to come. And this, of course, has conservation implications, because by identifying individuals or groups acoustically, we can complement monitoring, photo ID monitoring efforts in this endangered and small population. Thank you very much.
We have time for questions, if anybody has a question. And looks like maybe not. Okay, thank you. And next up we have Sarah Fortune to talk to us about bowhead whales.
Thanks, Andrew. Okay, so I'm going to keep the trend alive here with Arctic studies. And I'm going to take you to Cumberland Sound, Nunavut. And this is by far my favorite place in Canada, largely because the landscape is stunning, but also because this is an area where a segment of the eastern Canada, West Greenland bowhead whale population resides, principally in the summertime. And although whales have been observed here for hundreds of years, the biological significance of this habitat to the animals has not been well studied. And that's largely why we decided to collaborate with DFO and the local community of Pangertung to conduct a fine-scale foraging ecology study. And the goal of the study was to determine whether Cumberland Sound was a feeding habitat, and if so, what the primary prey was of the whales and how the animals were locating their prey, or what feeding strategies they were employing. And the way that we conducted the study was in part by deploying these fine-scale archival tags that would record the underwater behavior of the animals. And once I tagged a whale, I would track that animal from the vessel, which you can see here, and conduct focal follows. So I'd be able to continuously observe the animal's behavior from the boat, and also by flying a drone overhead. And then I'd relay the location of the tagged animal to a secondary vessel that was equipped with oceanographic equipment to document where the bowhead whale prey was located in the water column. And so we'd use nets to sample the individual zooplankton to determine what species of prey were available. And we also used an optical plankton counter, which would count and size the prey particles in the water column, telling us what depths coincided with the greatest abundances of zooplankton. And so one of the really awesome things about conducting the drone studies is that we could see quite clearly that while we were following the animals, they were not feeding. So what we found was often once we'd tag an animal, it would reside in these shallow coastal waters. Sometimes the animals would engage in rock rubbing behaviors to help expedite the molting process. Other times they would rest. But by and large, the animals had closed mouths the whole time. They would conduct really shallow, non-fluking dives. And so what this told me was that so long as we follow the animals, we're not able to record feeding behavior. And so we decided to adjust our strategy so that we would tag animals and let them go. And then hopefully they would resume their natural behavior, and then we'd record information about their prey in adjacent waters. And thankfully for me, I was able to record feeding behavior because my PhD depended on that. And here's sort of a glimpse at what bowhead whale dive data looks like. So on the y-axis here is depth, starting at the surface at 0 meters and going down to 300 meters. And these are dives that occurred over about a 15-hour time period during the day in white and during the evening in gray. And what you can see is that there's a ton of variability in terms of the animal's dive depth. But the animal did conduct a lot of shallow probable foraging dives and fewer of these deeper, longer feeding dives. And so this was a little bit perplexing to me because previous studies found that bowhead whales off the west coast of Greenland and the closely related North Atlantic right whale conduct really consistent deep foraging dives, and that these animals are usually exploiting a prey layer found near the sea bottom. And so my results really weren't matching up to what I expected. And in order to understand why the whales might be feeding at different depths, I looked at the optical plankton counter data. So plotted here again is depth in meters, and on the x-axis is the biomass of prey particles, and on the z-axis, where we have this color gradient, that's the abundance of particles. And what you can see is that in the surface, in the top sort of 50 meters of the water column, we have an increase in particle abundance that's associated with the high biomass as well. And then at depth, at around 180 meters, there's also an increase in prey biomass, but this time it's associated with low abundances of prey. And then if we look at the size of the prey particles, we see that in the surface, we have high biomass of small organisms that are around 2 millimeters, whereas at depth, we have high biomass that consists of these larger particles at around 3 millimeters. And so what this likely represents are actively feeding early life stage copepods near the surface that are actively grazing on phytoplankton. And then the larger organisms that are found at deeper depths may represent those that are undergoing diel vertical migration. So they're descending to the bottom to avoid predation from visual predators. Or they may have undergone diapause, which is essentially a form of hibernation. So I also was able to deploy longer-term tags on the animals to look at their feeding behavior throughout the entire summer. And I found that bowhead whales don't spend a lot of time feeding per day in August. So they only spend around 4 to 7 hours. And to you or I, that might seem like a lot of time, but it's not when you compare that to how much time the closely related North Atlantic right whale feeds during the same time of year. So right whales are feeding for 12 to 22 hours per day in August. And it might be that bowhead whales can engage in other activities like rock rubbing or social behaviors during the summertime because they have access to these high energy Arctic organisms that are chock full of lipids. So they're essentially feeding on the Big Macs of the sea, whereas North Atlantic right whales are feeding on comparatively smaller organisms that are of temperate origin and are lower in lipid content. Now, I also found out that bowhead whales likely feed throughout the entire year, and so that may also provide them some flexibility in terms of how much time they need to allocate to feeding behaviors in the summer. So the main conclusions from this study are that yes, Cumberland Sound is a summer habitat for bowhead whales for feeding and also for rock rubbing behavior. And bowheads employ a flexible foraging strategy while they're here, grazing on that lower quality prey, the low-hanging fruit that's found in the surface waters, and also exploiting the higher energy prey that's found at depth. But that also requires that the animals expend a bit more energy to consume the deeper prey layers. And the fact that bowhead whales only allocate a small proportion of their time to feeding during the summer may also suggest that they're potentially able to adapt to changes that are climate-induced in the future. So this was very much a collaborative project, and I'm very grateful to all of our partners, particularly DFO, World Wildlife Fund, LGL Limited, VDOS Global, and Woods Hole Oceanographic Institution. And thanks so much for listening.
And while Selena comes down, do we have any questions?
So Sarah, if the big copepods are undergoing diel migration, how come the nighttime dives weren't shallower?
Yeah, so I have found patterns of diel vertical migration in the beginning of August. So the first 2 weeks of August, I see really pronounced day-night dive patterns for bowheads. But then as late August rolls around, that seems to change a little bit. And so it might be that towards late August, some organisms have commenced diapause, but others have not initiated diapause yet and are still actively grazing. So the whales might be exploiting prey that remains at the surface during day and night, and then some that do descend. So there's some variability there.
Hi, thanks. That was really interesting. I'm just wondering, and this might be too far off from what you do, but can you say anything about how this planktometer, whatever you call it, can distinguish between plastics and plankton?
Oh, so how you could tease out other materials in the water? It's a great question. So actually one of the challenges that we have is separating the detritus from the zooplankton. And the only way we can do that is based on filtering the data by particle size. And so you could potentially, if you had maybe a really fine mesh net so that you could quantify how many plastic particles you have in the water column and what size they are, you might be able to relate that to the optical plankton counter data so that you could get more fine scale information about the vertical structure of plastics in the water. But it would be, I think, a little bit challenging, but not possible.
Thank you.
Okay, thank you.
And our next speaker is Selena Agbayani.
Wow, these lights are really bright. Good morning, everyone. Sorry, I'm having some technical difficulties. That should be a video. Anyway, good morning, everyone. Let's pretend that this little baby calf is swimming around. Have you ever looked at, say, some drone footage or a picture and wondered, how old is this whale? Anybody tell how, oh, thank you. Can anybody tell how old the baby is?
I don't know.
Oh?
It's not working.
We're going to pretend that it's still swimming. Can you tell how old a baby calf is? How long ago it was born? Perhaps how old a mother is? Is the calf doing well? Are calf and mother healthy? Can we really tell from just looking at a video or a picture? Well, as it turns out, we can't really tell exactly how old a whale is just by looking at a picture. But we have all this new data from amazing technology, and we can see the whales' bodies in ways that we've never really been able to see before. So we have all of these new measurements, but we need some sort of baseline reference to be able to compare those new measurements to. This is where growth curves come in. When I first started my master's, I had to go in search of the gray whale growth curve. And when I looked into the literature, I found a growth curve for fetuses and neonates, a separate one for calves and juveniles, and another one for adults. But what I needed was one comprehensive growth curve that would describe the growth rates of all the ages. And that became my task. The data that I'll be showing you today primarily came from counting growth rings from earplugs, or from counting what I like to call ovary scars from sexually reproductive females, and those are from Corpus albicans or Corpus luteum. But the important thing there is that this information can't really be gleaned from live whales. And so most of our data, or all of our data, pretty much came from scientific harvests, strandings, and whaling records. So when we analyzed the data, we found that the growth curves or the growth rates for calves were so different from juveniles and adults that we had to fit two different curves. And we can see here that at birth, gray whales are around about 4.6 meters in length. That's about 3 times my height. And by the time they've weaned, they would have doubled in length. The growth rates peter off after weaning. And if we zoom out, we can see the marked difference in growth rates before and after weaning. You'll also see here that there's quite a lot of variability between males and females in terms of size of adults. And we've noticed that females in general fall above the curve and males fall below. And so with this information, we were able to fit sex-specific curves. This is all super useful. But what about mass? When I looked into the literature, I wasn't able to find as many weight measurements as length. For some reason, it's logistically challenging to weigh a giant whale. But I was able to find just enough to fit an allometric relationship, shown here on the right in log format. And now, using a length measurement, I can glean 2 pieces of information. If I had a 10-meter long whale, I can tell that it's about 4 years old, and it should clock in somewhere in the neighborhood of just under 10,000 kilograms. If I were to repeat this calculation for every age, I'd be able to put together a mass-specific growth curve. Here we can see that when they're born, gray whales are around about 1,000 kilograms. That's about the same as 2 grand pianos. No, I'm not going to tell you in relation to my weight. But I can also tell you that by the time they've weaned, they've gained more than 5.5 times of their original birth weight. How do they grow so fast? Well, our preliminary calculations tell us that it takes approximately 30 liters, minimum of 30 liters mother's milk per day at 53% lipid content for the babies to grow as fast as they do. That's about half a bathtub worth of milk. That's a lot of milk. And so if we zoom out again, we can see that the biggest whales will clock in at approximately 20,000 grams. And so now we have our baseline reference. What can it be used for? Well, my favorite thing, species conservation and management. Today we have drone technology, and we can measure the length and girth of whales from photos, and using a little bit of geometry, we can calculate volume and mass. From there, we can go back to our growth curves and see what the probable age of those whales are. And also, we can compare the calculated mass to our expected mass at length to see if they're relatively healthy or if they're too thin. In this way, we can monitor the age distribution of our population and also assess the health of it. And I guess one of the things that I discovered while I was doing my master's is that while this is a really fundamental piece of information, we don't have complete growth curves for all of the marine mammal species that we're interested in. That's just something to think about. Anyway, that's also supposed to be a video. Okay, let's see if it works this time. Not working. Anyway, thank you for listening.
We have time for one question, if anybody has one. At the very back, and you're going to have a runner. No, we need it on recorded.
Thanks, very interesting. Are you able to use drones to not only estimate length and width of the whale, but sort of in a kind of a photogrammetric approach by, as the drone passes over, perhaps kind of integrate over the whale's full volume by taking views from different angles of the whale?
I don't know the details, but I could see how that would be possible. Yeah, if you had a really, I guess, clear waters, and yes, that's definitely possible.
Okay, I think we will move on. Thank you very much, Selena. And our next speaker is Cassandra Girdlestone.
Anthropogenic noise in the oceans is on the rise, and as a result, it's important for us to understand how this noise is affecting marine mammals, such as beluga whales, for instance, particularly regarding their hearing. One tool we have that can help us with this is the cochlear frequency map. Now, this is a species-specific map of the cochlea, which is located in the inner ear, and the frequencies detected at given locations the frequencies detected correspond to particular locations once this map is in place. So as you can see in this schematic, the high frequencies are detected at the base, and as we move throughout the cochlear spiral, which is similar to a snail shell, we reach the apex where the lower frequencies are detected. That means with a map such as this in place, if we were to find acoustic trauma or hearing damage at a given location, knowing what frequency is detected at that location could enable us to determine what frequency caused the damage and, in turn, the source of that frequency. Now, we can use live animals to determine the hearing range, but standard methods for creating frequency maps involve exposing an animal to sound and then euthanizing it to analyze the cochlea. Of course, we can't do this for marine mammals, so we need to find an alternative method which uses samples that are collected opportunistically. So here we see the hearing range for beluga whale. And we know the frequency, but we have no way of connecting that to the location. So we need to use terrestrial mammals as a proxy to do so. For this reason, we have been looking at echolocating bats as well as rats, in part because both of these species already have a well-documented frequency map in place. So that means we know the connection between the frequency and the location, which we can in turn connect to the morphology of the inner ear. And using this information, we can use the morphology to back calculate a frequency map for the belugas and determine the location and frequency. Now, just before we go too much further, to help orient you as to what we're looking at and talking about here, we have the cochlea in the upper left hand, and again, similar to a spiral-shaped snail shell. And if we were to uncoil that and flatten it out, you would see something like this schematic here. We have two types of sensory hair cells. the inner hair cells, which form a single row across the top of this image, and the outer hair cells, or the OHC, which form 3 parallel rows below that. And the morphology of these sensory hair cells changes from the apex on your left to the base on your right as we move throughout the cochlea. And these morphological changes include the overall hair cell shape, as well as the cell width and the spacing. And these change in correlation to the frequencies that are detected along the cochlear length. Now, we've looked at several parameters. And if we take a closer look at that, we see this scanning electron microscope, or micrograph, sorry, of the hair cells. And you can see the 8 parameters that were measured at all different rows of the hair cells. So I'm only going to show you the results from one today, and that's this distance between the inner hair cells to the 3rd row of outer hair cells. And again, we've measured these all throughout the cochlea. So this is for the bat. And you can see that that parameter decreases as we move from apex to base. And because this is the data for the bats, we also have the frequency, which is known, plotted across the top. So we can correlate that frequency with the location and now the morphology. So now throwing in the beluga data, we can see that there is also a decrease in that parameter throughout the cochlea. And there is some similarity between the 2 species, particularly in the higher frequencies. And this is important because that's what we need for our frequency mapping. And it would make sense that if there is this similarity between the 2 species, then the belugas would be hearing similar frequencies at those locations as well. Now, we've been looking at the parameter plotted versus distance along the cochlear length, but now I've switched up to frequency. And this is the same data that you saw in the previous graph, except plotted versus frequency. There are fewer dots just because we've organized it a bit differently and binned them differently from prior graph. So you can see that we can't use just the bat to help create the frequency map for the beluga because there's this huge gap at the one end. So to overcome that, we have added in rat, and that gives us a complete data set. So now with the bat data, as well as the rat data, we have all the information we need for the beluga frequency map to cover their hearing range. And after some multiple linear regression, we came up with the fact that these 4 parameters are responsible for the majority of the variation in the frequency data. And if you plug the values for those 4 parameters into this equation that you see, you would get the estimated frequency for a particular location. And to get the frequency map, you would just plug those 4 values in at every location along the cochlea. And this is the first prediction for a beluga frequency map. So you can see the frequency versus the distance, and this means with this map in place, if we were to find damage at 25% from the apex, for instance, we could go over and say it's approximately 30 kilohertz that caused this damage, and that might be attributed to side scan sonar, for instance. So this, again, is preliminary, so there's more research that needs to be done, and it can be expanded to all marine mammals, which I think is really important. So hopefully this is not the end of this story. And thank you for our funders and supporters, and thank you for listening.
Any questions? Going one question over here.
Is the next step to look at some actual ears of belugas? And
We have actually looked at, I believe, 6 so far. That's how we used the frequency map, or created the frequency map to use that equation and compare it to the beluga ears. My preliminary measurements were done on a few different belugas as well. But yeah, we would definitely want to expand that to additional individuals to see what kind of variation there is within the species. So yeah, definitely more belugas and more whales.
Thank you, Cassandra.
Thank you.
And the next speaker is Juan Jose Alvera.
Good morning, and thank you, Andrew. It's good to go back to the symposium after missing a couple of symposiums in the last 2 years. Today, I want to show a kind of a report of orca calf that was washed ashore alive in Ecuador early this year. And basically, the major idea to show this is because this is probably the first time that we have photo documented this case. And just to show you here, this is Ecuador. This South America continent also is right below. And the event took place in this fishing community called Cariate. It's a small town where basically people fish, and also there is some ecotourism in the area. So I just want to show that this was in the news, in the media, and at a first glance, you can see that this is basically a orca calf. But what was interesting and really was striking me was to see the shape of the animal. You can see here, for example, in the frontal part of the animal here, this concave area that basically tells us that something was wrong with the calf. The community immediately assisted the calf. There wasn't any from the Ministry of Environment, Fisheries, agencies or biologist expert to help the animal. So basically the people, the fishers or the tourism people that were there, basically took the animal and pushed it back to the sea. According to the anecdotal information, the animal was about 1.5 or 2 meters, right? And this really was an important issue for the people doing research in marine mammal, and I was in contact with my colleagues down there. And basically, we collected more evidence. The second author, Pedro Jimenez, basically, he was in contact with park rangers, and they collected this picture here. For example, you can see the lateral view of this animal, that there is basically a lot of fat reserves, both in the melon area, in the nuchal crest here around the blowhole, or also the depression above side of the animal. And in the frontal view down here, also, you can see that both sides of the animal show this lack of basically fat, and also here in this area. So this animal really was undergoing a case of sickness or malnourishment, or something was happening with the little calf. To calculate the age, basically, we use the regression relationship that was published by Fernbeck using the maximum estimate of length versus age. The calf was about, we estimate about 1 year or less than 1 year old, right? So I contact my colleague, Dr. Lance Berrenena, also Martin Jaulina for the aquarium. I sent the pictures to them, and basically they agree that this animal was probably an animal undergoing malnutrition, but we don't know for sure whether the animal was weaned at the time that this happened, or if it wasn't the case, whether he was taking enough nutrition from mom, or whether it was separate from mom, or the mom died, right? So, but you can see that the implication of this loss of nutrition in the animal, this emaciated, basically was a peanut head orca, basically can have effect in the animal health. We can see that basically the lack of connective tissue or fat reserve in the melon structure might have an implication for communication or even echolocation that might be push the animal to this stranded event. Or also the thin blubber and a lack of epaxial musculature in the nuchal crest of the animal also can have some implication, and this is an index of poor health condition, right? So might be related to a chronic disease. But we didn't have samples. We didn't even took a skin sample because no one was there to see the genetic, but was just observation from the Rangers Park, and also some other information that we were looking afterwards, right? So looking at the effort of the community to rescue this animal and basically push back the little calf to the sea, it might be that this animal didn't make it because of the lack of food. And in the literature, probably that is already reported that the lack of fat reserve lipid affect the buoyancy of the animal, maybe the animal drowned. And we try to follow all the work, and we are now contacting more researchers to see what we can do to establish a protocol, basically to try to make sure that next time that this happens, we can really responds in a pragmatic, technical way before the animal was delivered back to the sea, right? So this, I want to just thank Martin. I invited Martin to be part, but he was so humble to say, no, it's okay. He gave us a lot of basically insight. And also, yeah, over there. So, stay tuned because a short communication will come in Aquatic Mammal this coming year. So you will find more about the history of this little calf. But I just want to tell that orcas are the apex predator of the ocean, and they are telling us something. Something is changing in the ocean, and the fact that we found also these cases in tropical countries, and also here we are observing, because of the war of lands, that there are a couple of individuals that also are facing malnutrition or emaciation, means that the changes are affecting this apex predator, which are the canary of the Maya Sea. Thank you.
Any questions? Buddy, okay.
Hi, I was just wondering if what kind of cataloging is done for the orcas over there. Like, if another one was stranded that was older, do you guys have the identification of them?
There is a catalog actually for the Galapagos Island, which is 1,000 kilometers from the Ecuadorian coast. But for the Ecuadorian area, the continental part, some colleagues are just starting doing that. We really need to do a lot of work with orcas over there. Yeah.
One other question? Last question? Is that it? Okay. Well done. Thanks so much.
Thank you, Andrew.
Our next speaker is Brooke Bessison.
Good morning. My contribution today comes from 22 months of traveling back and forth to Mexico's Gulf of California to research and write the book Vaquita, Science, Politics, and Crime in the Sea of Cortez. With likely less than 15 vaquitas left, we all need to come together and try to find some solutions here. For Anna. This is Anna. She is a mother. She was seen last year and again this year, both times with a calf by her side. As one of the last members of the species Phaceanosinus, Anna has lost almost all of her family, nearly all of her friends. They are dead, like this little tot. Indeed, Vaquita is the world's most endangered marine mammal. And that charming tint of black around the eyes and lips led to the nickname Panda of the Sea. Vaquitas have been drowning in commercial gill nets for decades, but they are now entangled in a cartel-driven poaching operation for an endangered fish called totwaba. Totwaba swim bladders are smuggled, dried and smuggled from Mexico to China, often through the United States and perhaps Canada too, as part of the same multi-billion-dollar black market that peddles in rhino horn and tiger bone and pangolin scales. While Mexico spends millions of dollars subsidizing a gillnet ban, their success is stymied by strong-arm cartels and deep-seated corruption. As of December, Mexico will have a new president who ran on a platform of clearing out governmental corruption. And if he can be supported to succeed, that would bring some real hope to this situation. But what else can be done? What can we, you and I, do? What strategies can we support? Well, every country needs to double down on border control and penalties for wildlife trafficking. You might ask yourself, I ask, Vancouver is quite a cosmopolitan city. Does the totwaba trade come through here? Do your border agents even know how to identify totwaba bladders? In Mexico, on a local level, communities are suffering. People Until they can feed their families, they will not be able to have the capacity to care about porpoises. So it's important that we all remember that addressing human economics is conservation. As one realist told me, we cannot save Vaquita and have fishermen go extinct. NGOs are working with legal fishermen to help them move towards sustainable practices. And alternative fishing gear would give them the opportunity to keep working without killing vaquitas. Some fishermen are actually working for Vaquita, deploying PAM devices and also pulling derelict gear from the water. Some of these men would rather be fishing, but right now, the only honest money is found in conservation contracts, giving good economic incentive. We can also go to the northern Gulf of California, the upper Gulf, you and I. Tourism gives occupation alternatives to fishermen, and it also provides income to non-fishers, supporting whole communities. Of course, educational programs are critical. They help build public awareness, and they inspire people to realize that Vaquita is an important and beautiful animal and part of their magnificent marine fauna. Sea Shepherd has been working with the Mexican government since 2015, using direct action tactics against poachers, and their efforts have made a difference. Mexico is also overseeing a multi-institutional gillnet removal program, which is effectively, looks like, slowing the decline of the vaquita population. And by trawling for gear, trawling for illegal nets, they have already pulled over 1,000 gill nets from the water. You may know that last year, ex situ conservation was attempted, but that captivity program had to be was aborted after this little girl became too stressed and had to be released, and another adult female died. Now everyone is refocused on protecting vaquitas in their natural habitat. And core vaquita habitat may soon be partitioned off and actively guarded acting as an on-site sanctuary. Plus, I think there will likely be more effort for more photo identification of the remaining vaquitas, and I think this is important for all of us so that we can follow Anna and her tribe. There are a lot of talks today about a lot of dire situations, but for vaquita, time is running out. So please, please learn more and support every effort to save this species. I want to thank Porpoise Conservation Society and every other organization working against the tide to try to avoid the extinction of this extraordinary little cetacean. Thank you.
Question. Question up in the back.
I was just curious to know what the totuaba is used for in the Chinese medicine.
Very good question. The totuaba bladders are reconstituted for soup, and they are purported to have curative powers, and the main one is a nice complexion. Good circulation, nice complexion.
Any other question? Your last question, and then I'll ask Anna. Oh, you're...
How much has the loss of flow in the Colorado River figured into your story?
Yeah, that's a great question. I did a lot of research on this because the Colorado River has lost its flow over the last several decades, and there has been a change in habitat in the delta region of the northern Gulf, the upper Gulf. And so a lot of people have raised question about whether that has caused the demise of vaquitas. And in fact, some of the anti-vaquita conservation groups purport that that is the problem.
But from all the research that I have done and everything that I've looked into, everybody I've spoken with, it does not appear that that is causing the issues. Vaquitas are always healthy. They do not have lethal parasite loads. They don't have disease, the kinds of things we would expect to see from environmental deterioration and environmental problems. And so the one thing they always have are signs of entanglement on their skin and in their organs. So I think it's pretty clear that gill nets are the issue. If anybody has questions about the genetic viability of the population, please catch me during a break. Thanks.
And I'm going to suggest that we have 2 more speakers, but afterwards, if all the speakers in the first session would come down to the front so that those who have more questions can find you, that'd be great. Our next speaker is Anna Hall.
Well, good morning, everybody. I have the pleasure of serving as the president of the Porpoise Conservation Society, and today I'm going to tell you a little bit of some of the work that we've been doing over the past year around the world. But before we get into that, let's just have a quick look at how the porpoises of the world are doing, because the porpoises, in my experience, tend to be a species that people tend to know less about or confused with dolphins, although certainly not in this audience. But let's just have a quick review. We have 7 species of porpoise, and don't worry, I know I only have 5 minutes. I'm going to leave out spectacled porpoise. So we'll come back to that next year if my plans for research are successful. So globally, we've got the Dall's porpoise, we've got 2 species of finless porpoise, spectacled porpoise, Vaquita, Burmeister's porpoise, and the harbor porpoise. And if you look at the population trajectories, there's only 2 categories for these 7 species. We've got unknown and declining, almost in equal amounts. And if we look at the IUCN conservation statuses, it's actually a little bit dismal. We've got least concern for the Dall's porpoise, but I'll just note that it's been over 15 years since the assessment, and we're going to come back to Dall's porpoise in a minute. The 2 species of finless porpoise are now at endangered and vulnerable. Both are declining. The spectacled porpoise is least concerned, but we actually have got next to no information about the spectacled porpoise. They live in the Southern Ocean. We really actually don't even know exactly what their habitat looks like. The Vaquita, as Brooke just so eloquently told us, critically endangered and declining. Burmeister's porpoise, we don't know the trajectory, but we know that it's near threatened. And the harbor porpoise, not to panic, it's least concerned, well, except for the Black Sea population, which is critically endangered, and the Baltic Sea population, which is endangered. So it's not really looking that good. So what's going on with the smallest of our marine mammals, the smallest cetaceans? Well, it's the list of usual suspects. We've got entanglement in fishing gear, habitat degradation, habitat loss in some cases, directed killing, anthropogenic noise, a lack of scientific data, which stems from a lack of effort, which stems from a lack of research funds, and it's a big world out there, big ocean. And the biggest porpoise is the Dall's porpoise at about 6 to 7 feet long, 300 to 400 pounds. We're really talking dorsal fins, except for the Vaquita, of about 6 to 7 inches in height usually. Well, those of you who spend any amount of time on the ocean, that means the research that we do on porpoises requires Beaufort 0 to 1. Well, that happens a lot of the time, doesn't it? Right, and because we have this lack of information and these hinders to research, primarily being the animal's small size, there's got to be other things going on out there in the ocean. And one of the things that I would just like to mention, because it is subtly in here, but it's a real factor, particularly for animals that live in the coastal environment, which except for the Dalls and the spectacled porpoise is all of the other ones, is we talk about boat noise, we talk about ferry noise, we talk about sonar and military noise, but then we just have the everyday noise of coastal construction. There's a lot of that going on. And what happens to the little porpoise or the calf that perhaps is 200 meters from pile driving in Beaufort 4? The observers on site know that that animal is there? Probably not. And so I suspect that there are other factors going on that could, in fact, just be things as simple but as complicated as calves being separated from their moms. So let's just talk very quickly. As I said, I'm not doing all 7 species, but we are going to talk about the Dall's porpoise because there's something going on right now in the North Pacific Ocean that goes largely ignored. The Dall's porpoise is the target of the largest directed hunt of any cetacean anywhere on the planet, and the first official day of 2018 was November the 1. How many Dall's porpoise are being killed each year by the Japanese? Well, let's just have a look at some of the stats. Before I get into the stats, let's talk about how they're killed, because again, these are animals 6 to 7 feet long, less than 500 pounds. If you use an exploding harpoon like you would with some other cetaceans, you have nothing left. These animals are essentially speared and they bleed out. This happens by the tens of thousands of animals by the Japanese each year in the North Pacific Ocean. They go for the dolly type and the chewy type, which you can see here. And the recent quotas are roughly 12 to 13,000 animals. But in 2015-2016, although the quota was 12,364, the actual catch was much lower. I wonder what could be going on. Well, in the last 20 years, an estimated 190,000 Dall's porpoise have been killed. And if we go back a little bit farther, we have more than 500,000 animals. And in Canada, the last Acoustic assessment was in 1989. The last assessment by the IUCN was more than 15 years ago. And it turns out that there's a Japanese researcher who's quite curious about what's going on because catches are declining. This has never happened in cetacean catch before, am I right? We've never seen a population that's targeted decline in the catch rate. Oh no, that's right, we have every single species of cetacean that's been hunted. And in a publication from last year, because you had determined that the catch rates are declining, this is probably because both populations or subpopulations of Dall's porpoise that are being harvested, the chewy type and the dolly type, are declining. It's rocket science. It's not. There have been no assessments. There have been no biological assessments, no ecological assessments. And even in terms of what is going on and how the animals are moving around, we really don't know. But what we do know is adult males are killed, adult females are killed. Calves are often not killed, but definitely separated from their lactating moms. Right, after that ray of sunshine, let's talk about Vaquita. I don't need to go into the details because Brooke has just done it so very well for us. And by the way, I can wholeheartedly recommend her book. The Vaquita are dying because of the international greed and the international trade and the desire for a good complexion and money. Globally, the international trade of trafficked species currently is an estimated worth of $23 billion. This is big business. And there are tens of thousands of miles of nets discarded, actively fishing, whether or not they're attended. We have got to get them out, not just for the vaquita and the dolphins and the turtles and the non-target sea lions and fish species in the Sea of Cortez, but for every single cetacean around the planet. The vaquita population is really the poster child for this issue right now. The current population is less than 20, and all I can say is if only we had as many vaquita as we do southern residents. That's how dire this is. We hear about southern residents all the time at a population of greater than 70. If we had 70 vaquita, we'd have some very happy people on this planet right now, but we don't. We did have 6 animals sighted, and that was good news, because I'm very pleased to tell you that this animal still stands at a critically endangered status, not extinct. We do have the first photo ID'd images of vaquita, and we had calves seen in September, October of this year. If we look at the harbor porpoise, these are the animals I'm very concerned with. It's very likely their neonate nurseries are very close to shore. And this is an image taken of my husband's great-grandfather's house in the city of Granville, which I'm sure many of you never heard of. It actually burnt down in 1886 and is now the city of Vancouver. Surely nothing has happened to our shoreline since Vancouver looked like this. We're expanding our study to Scotland this year, to another site, near shore area in the northwest of Scotland, and many thanks to the Gairloch Marine Wildlife Centre for taking this on. We're also working with the Zoological Society of London because the finless porpoise also lives adjacent to very high human populations. where there is a different outlook on ecological needs. However, these beautiful animals still seem to be eking out a living. This is a Yangtze finless porpoise. We're also working down in Chile with Burmeister's porpoise. We've got a fantastic research team of locals, scientists, students, researchers, photographers, who tomorrow will be out in the boat conducting line transect surveys to do the first ever assessment of the seasonal abundance fluctuations and density and habitat use patterns of Burmeister's porpoise in this heavily impacted bay, where things such as sulfuric acid spills are still everyday events. And why are we doing this? Because again, we come back to directed killing, this time not in the large numbers of the Japanese, but certainly for use as bait in other fisheries. And this work cannot be done alone. It is absolutely not done alone. It is done by a whole team of porpoise people around the planet. But most locally, I have to thank Chris and Axton Hall, Judy Fitzgerald, and of course, Marcus and Christine, who are here in the audience, Dave and Claire Gummison as well, who ferry me around, because without these people, it would significantly hinder the work we are able to do. And just in case you're thinking, what can I do? Today is the International Day of Kindness. I think we should extend it to the 7 species of porpoise, and if you want to get involved, please volunteer, please contact us. Adopt a porpoise for Christmas. Thank you very much.
Time for one question. Up here.
Hi. I think you're right. I think most of us don't know enough about the porpoises, especially those of us who are out on the water on a regular basis. I know from my experience, I've been out on the water doing whale watching for about 7 years now. And as much as I know about the harbor porpoise and Dall's porpoise, I definitely don't know enough. What I have noticed myself, and I don't know if there's any correlation, but when I first started, there was a lot more Dall's porpoise. We saw Dall's all the time. And it's really sad not to see them as frequently. They're absolutely charismatic. But we see harbor porpoises way more frequently nowadays, which is exciting because they are, you know, small and shy. And so to see them more frequently is really cool. But do you think there's any, I mean, obviously the hunting is a big problem with the Dall's, but do you think there's any correlation between the two? You know, having lots of Dall's before and not so many harbor porpoise, and now having lots of harbor porpoise but not very many Dall's. Do you think there's any kind of correlation between the two?
And that's a very, very good question. And we certainly have seen significant changes in the Dall's porpoise habitat use and local abundance numbers over recent decades. And you're absolutely right. We're seeing fewer of them here. Why we're seeing fewer is a really good question. There's not a lot of overlap in terms of the habitat use. The harbor porpoise tend to be more of a shallow water species primarily, and the Dall's a deep water species. There could be some competition for prey, but then looking at stomach samples actually from the Japanese fisheries, it does indicate that there may be some difference in the feeding patterns of these animals as well. As to exactly what's going on, I actually don't have an answer for you. I think it's a very, very important ecological question for southern British Columbia, though, and there probably is a student out there who should take that on.
Thank you, Anna.
Thank you.
And the final speaker before the break is Cindy Ellison.
Okay. Is it over? There we go. All right, so Anna did a great job talking a little bit about the harbor porpoise. I'm going to go a little bit more into that. And pose the question, do they need passports here in the Sailor Sea? So I'd like to acknowledge my co-authors, well, presenters, myself and my assistant, Katrina McKeever from Pacific Mammal Research, and of course, Anna and Marcus from Porpoise Conservation Society. So just a brief little history of harbor porpoises. They are one of the smallest cetaceans at only 150 pounds, 5.5 feet, so say kind of like average human. What we know very little, and Anna kind of touched on that, very little about this species. We don't even know really how long they live. If you look at the literature, it's like, well, 8 to 20 years? I don't know. But regardless, they do live a shorter amount of time than other dolphin and whale species. So in order to get your babies out, you got to get sexually mature a little bit faster, 3 to 4 years of age, and give birth every 1 to 2 years. And so in the 50s and 60s, as we just kind of heard about, we had tons of harbor porpoises. Then they went down. They're almost gone in the Salish Sea by the 1990s. But luckily, they've had a recent comeback, and they're now up to close to 12 or 13,000 in the Salish Sea. We don't know why the decline happened and the recovery occurred exactly, but it probably has to do with pollution and habitat use and degradation and things like that that we've now tried to help. But either way, it's one of the great good stories that these guys are doing well. But we don't know very much about them still, right? Why the decline occurred, we don't know because we didn't know anything about them. Why the recovery happened, I don't know, because we don't know much about them. We don't know about their habitat use, their social structure, their population structure, site fidelity, movement patterns. We know they're there, we know basic life history traits, but we don't know, is it one giant population or are there smaller communities that interact? We have no idea. And so we touched upon earlier as well that we need to know the individuals, right? The power that we know about orcas, about gray whales, about humpbacks, about all these dolphin species, bottlenose dolphins, is because we know the individuals and we can track them over time. And so that's where Pacific Mammal Research has come in. And the first question we asked was, can you do it with harbor porpoises? It's rarely been attempted, and I'm sure you probably know why. Because usually that's what you see. A nice little fluke print, well, there was something there. Maybe if you're lucky, you get a splash. But most of the time, if you see them at all, it's a tiny little black fin, and as Anna said earlier, the dorsal fins are quite small. So they're not the first ones like, I'm going to do ID on that species. That's super easy. So I think it kind of got pushed to the side. There are other marine mammals and cetaceans that are easier to study, but these are good indicator species and top predators, and we should understand more about them. So that's where I came here in 2014. Founded Pacific Mammal Research and decided to see, can we do it? So we went out to a land-based study site, which I'll talk about in a second. And basically the short end of the story is that you can. They do have individually identifiable marks. The pigmentation patterns along the side of the animals, where that kind of lateral line is between dark and light, are individually identifiable. They are unique. Unluckily for them, but luckily for us, they get scars and lesions. And so we're able to use those as well. We use secondary marks. So we use an 8-category ID matrix because these guys are harder to identify. They're smaller, and it's just, you don't use the dorsal fin as much as you do in other small cetaceans. So we use the peduncle and the fin trailing edge. There are, believe it or not, some that actually do have nicks and notches in their dorsal fins. And then to really make sure that we're identifying the right individuals, we use conformation marks, including overall coloration and fin shape and size. We have found that there is a certain number of variations within the population of their dorsal fin shape. So you can do it. We have about 80 individuals that we've identified so far over the last 40 years, wow, no, that's how old I am. 4 years. And we have about 35 to 40% of those being resighted multiple times in our study area, coming back to the same place. So one of the big questions that we're going to hopefully answer with our collaboration is, do these guys need passports? So this is Jaws. We like to name ours really strongly. His coloration looks pretty cool. So does Jaws need a United States passport to come visit his friend up here in West Vancouver, and vice versa? So in order to do that, we need to collaborate, because I can't come all the way up here and they can't come all the way down here. So we need to work together. So in Burroughs Pass, that's me and my assistant out there on Fidalgo Island. And then up at White Cliff Park with some volunteers with the Porpoise Conservation Society at West Vancouver. So we take photos and we store information in a collaborative database. So we're working on getting that together, putting it together so we can both access the data and pull the photos from it and to get more information from what we're collecting. So we're going to use the ID matrix that we came up with at Pacific Mammal Research to see, can we use it here? Is it the same if we use it in our area versus up here in West Vancouver? Is it the same? Can we use it? Or do we need to modify it at all based on the population? And so what we're hoping to do is work together to form a tool that can be used regionally. So other interested groups can take this tool and start doing photo ID on the porpoises in their area. And also worldwide. So again, we need more information, especially on the Baltic Sea and whatnot. We need more information about these guys. So it's really important knowing these individuals and working together. Because we live in a transboundary ecosystem, we can't effectively conserve the species without knowing where they go, how far they go, do they live in small communities, are they going around the entire Salish Sea, is it one stock structure, is it multiple stock structures? We really need to understand that for effective conservation. So That's just a little bit of us if you're interested in seeing really pretty pictures of harbor porpoises. And a lot of times the first thing I get when I tell people I do photo ID in harbor porpoises is they laugh. Like, sure. But it can be done, and you can see some pictures on our website and whatnot. So thank you.
We have unfortunately just run out of time, but everyone's going to come down that spoke, and so you can ask porpoise questions, whale questions, and the speakers will be down here in front. 15 minutes. We're going to start at 11 exactly. If you don't need to leave the room, just stand and stretch, talk to the speakers. If you do need to leave, go out. Remember, it's a small door to get everybody back in. 11 o'clock, playing with walruses. We also have an overflow room if you really want to be by yourself and have a bit more privacy. See you in 15 minutes.
And just a reminder, we're still looking for Zach Shirker and David Castalgo for their presentations, please. Check 1, check 2, check 1, 2. I don't know if it's any better or if it's worse. Check 1, 2. I'm speaking over here. I'm looking over here. Looking to the right. Is it better? We can try it. It's probably better. Yeah.
And welcome back, everybody. We're now going to have an hour session focused on seals, sea lions, and walruses. It is interesting that we've got people watching, following us from Brazil, from France, and from Italy, as well as lots of people from the lower mainland. So thank you for joining us. Our next speaker is David Rosen.
Thanks, Andrew. It's quite exciting to have a walrus talk for the first time in years. Any questions? So normally, I kind of wear two hats these days as a researcher, both here at UBC and at the Vancouver Aquarium. And these walruses appeared at the doorstep of the Vancouver Aquarium last December. It was kind of an early Christmas present. And it was a present for me too, because I went, hey, more cool things to do research with. And so this is Lakina on the left and Balzac on your right, and they are two half-siblings that came from the Quebec Aquarium. They're the first two walruses to be successfully born and raised in Canada, in a facility in Canada. And I thought it was really cool to do some research with them. The Vancouver Aquarium also thought it was cool. In fact, they opened up the back research area into their research outpost, so no pressure there. We now had the public watching us to do research. And so the obvious question is like, okay, what can we do with these very large young, they're basically walrus toddlers, completely untrained? So yeah, let's do some research, but how do you do that? So I'm going to take through some of our thought process and some of our development on our new Walrus Research program. And the importance of having a Walrus Research program obviously relates to the threats in the wild. Unlike the Coca-Cola mascot on the right, walruses really, I always say, should be the poster child for climate change because of their reliance on ice for haul out and for feeding. The ice has to be at a particular location for them to successfully forage in the wild. So one thing that walruses do very well at aquariums is eat. So okay, there's something that we can certainly measure. And so we can be astounded by the fact that female walruses here in blue and the male walrus, and all these figures will be shown in red, sort of reverse sexism here, are eating between 10 and 15 kilos of food a day. And then you may also notice this significant uptick around this fall. So one of the things I'm interested in my studies are energetics and how food requirements and energy requirements change during the year. So this kind of piqued my interest there. The other thing you can do, of course, with animals in facilities is weigh them, which sounds really easy, except walruses, and I never knew this, are really lousy on land. And so actually training them to come out of the pool onto a flat surface was the first big challenge for the trainers. It's important not just for research, but also for husbandry to know how much they're weighing. How much do they weigh? A lot would be the short answer. But we can see that they have this developing sexual dimorphism against again, the male is on the top figure. We've been tracking their weight gain. And like most marine mammals, it's not constant. It follows these sort of seasonal ups and downs. And again, I want to raise this very interesting uptick that's happening this fall. So we can combine the weight with the food intake and kind of do things that, energetics people like to do, is look at how much energy they require per body mass. And as you expect with a growing animal, even though their food intake is going up, it's actually slowing down relative to their body weight gain. So, really young animals, a lot of growth, they're eating much more for their body mass than they are slightly older animals. These are still pretty young animals. So we see that decline that we'd expect to see, but we see a really significant upturn in how much energy they're eating per body mass this fall. And what's happening is they're starting to fall into this hormonal cycles that a lot of marine mammals exhibit where they have seasonal fattening. And so this is the first big year we've noticed this, all the food is voluntary food intake. They have to work a little bit for their food. So they're following natural rhythms, even though they're in an aquarium. And this is when in the wild, young animals would be really putting on the weight to get them through the next couple of seasons. Whoops. Okay. They don't just grow in mass. They grow at different parts of their body, and that's very important when you're trying to measure animals in the wild. The big challenge we face, the first big challenge is where do you measure a walrus. Like for us, we do waist size and belt size, and we have some standard things for sea lions because they have distinct sort of body portions, where walrus is basically a head and a bunch of other stuff. So we did come up with some standardized measurements, which was the easy part. Then we had like, how do you actually measure them? Well, we got the trainers here. There's a video of showing them with the male walrus. We basically use a rope, which with the sea lions, we can just put it around them, but you can't lift up a walrus. So getting them to lie flat and consistently, and then we take this rope and we measure how long the rope is. And we're getting very interesting measures of how different parts, their morphology changes as they get older. The other thing, of course, walruses are famous for are their tusks. And we're actually interested in how their tusks are growing, which seems kind of a weird thing to want to know, but there's a couple of very good reasons. First of all, in the wild, they age, Selena said, how do you know how old a gray whale is? Well, for walruses, the way they age them in the wild, particularly from photographs, is how much their tusk emerges from their lips. As you can imagine, there's a lot of guesswork in that. So we're actually part of an overall program that's measuring the tusk growth in these guys as they get older. So that's part of a long-term study. And the other thing we're interested in is sort of the fine detail of the growth, how they get thicker and thinner and elongate coming off the gum, because tusks are a great chemical marker that scientists can use both for present walruses and exhibits, that we can look at chemical markers for their environment. What kind of stable isotopes or chemistry are in the tooth that'll tell us what ecology they were, not just in the present, but also in the distant past by looking at museums. So we want to know how these are growing exactly. So we've trained the walruses to let us come up with these very fine scale calipers, and they keep their mouth open and we measure the various dimensions of their tusks. The thing, of course, I'm most interested in, for anyone who knows my background, is looking at metabolism. And so we had this crazy idea of let's measure their oxygen use or their energy use of these walruses by having them float in a dome. We figured that's, we don't know how long the walruses are going to be in Vancouver. Maybe we'll get some measurements before they disappear. Well, I'm very happy to say that with the training program, this is one of our early training films, that within a couple of months, they were stationing in a metabolic dome. We were getting measurements. These are toddlers that have to sit still for 7 minutes, okay? So think of a challenge that is. So we now have a couple of months of the first data of metabolic requirements of young walruses that have ever been measured anywhere in the world. Of course, all of this research, it's very exciting, very new. We're constantly adding to it, and none of it would be possible without the great training in husbandry that's available through Vancouver Aquarium staff.
Time for questions.
I'm just curious about the silver caps on the tusks.
Oh, yeah, so I meant to point that out. So yeah, you may have noticed the gang grill work on the walruses. So in the wild, walruses use their tusks primarily for ice picks for hauling out onto the ice. Concrete is much harder than ice, and so as a protective measure, the dental surgeons have put on these very expensive cobalt titanium or something fancy caps that last a couple of months, and then the vet staff have to replace them. And it's just to protect the tooth because the roots go very deep into the skull.
We're to stop there, I think.
Okay, thank you.
Very much. And next up, we have Chad Nordstrom.
Thanks, Andrew, and thanks everyone for being here today. Today I'm going to highlight some recent results that we've got back from a study, very team-based, very multidisciplinary, multi-group collaborative effort that's trying to sort of get back at the question of what is the major diet components in harbor seals in the Strait of Georgia. And today we're going to focus strictly on salmon, or specifically I'm going to focus on salmon. And I want to mention also that even though I'm up here speaking, said it was a very large team effort, and which was originally funded with some seed money from the Pacific Salmon Foundation. So this is the third year that we've been touching on this particular project. A quick update for everybody that on the project rationale really was to update the dietary information outside of estuaries in the Strait of Georgia, which hadn't been done really in any significant way since the early 90s. We also wanted to add to an estuary time series that had been rebooted in Cowichan Bay in 2012. And ultimately to ask the question, are the diets that are derived from scats collected in those estuary sites really representative of diets through the rest of the Strait of Georgia? Our approach was to use a DNA metabarcoding technique, and that gave us species compositions as well as the relative diet proportions. We then paired that with the traditional analysis of hard parts, which gave us size classes of the prey species. And then we could compare the diet findings. One is our snapshot between the estuary and the non-estuary in the time that we were collecting. And then again, as I was mentioning, sort of add to that long-term time series in Cowichan Bay. So in those collections, we were able to collect over 1,000 scats, both throughout April through November of 2016 and again in the spring of 2017. And there was 88 different species that were detected through those techniques. And here's an example of one of those plots. This is a summary of the spring season for our non-estuary sites. And on the y-axis is going to be sort of some functional groups that we sort of group those species into. And on the x-axis is the proportion of the diet. And we've started out with the gadids and the forage fish, here represented both by hake and by the herring, because they were by far the most dominant species at any given time. So collectively, those two functional groups totaled 55 to 85% of the diet at any given season or location, no matter how we split the data up. The rest of that diet proportions came from other functional groups like rockfish or flatfish and cephalopods. But for the rest of the talk, we're going to focus strictly on the salmon component. So jumping right in the salmon diet, we're going to start with our estuary versus our non-estuary sites. On the y-axis, we have the proportion of seal diet. On the x, we're going to have our two categories. We're starting here in the spring, and we're looking just at smolt consumption. So we've defined spring as sort of April through July. And in the estuaries, it references about 2.5%. That's collectively all salmon species. And in the non-estuary sites, it's just a little bit different, a little bit smaller, 1.5% roughly. And we can break that down further, finally, thanks to the genetics, into relative species contributions. Primarily Chinook smolts, again, 1.5%. And the other two species making up the bulk of the remainder is chum and, interestingly enough, Atlantic salmon. That was really interesting. And in our non-estuary sites, those more exposed rocky sites, shown as in the example underneath of Rebecca Rocks, about half of those smolts were Chinook. And then the secondary species, the next highest one, actually transitioned to coho in those non-estuary sites. Now we're going to transition into the fall. So we're looking primarily at adult salmon now at this point. Non-estuary spikes dramatically, as we would expect, 35%. So these are fish that have now come into the estuary. They've sort of survived the gauntlets of the killer whales and commercial fisheries. And they're hanging out in these shallow estuaries, particularly here in Cowichan, waiting to make their way up the river. This is a mix of wild-caught fish, or wild stocks, as well as hatchery fish. And in the non-estuary sites, so these are sites that are more rocky, more exposed, we're about 9%. And again, that contribution highly dominated by chum, at least in this particular year in the Cowichan. So in the estuary, so 30% chum, 5% adult Chinook. In the non-estuary, mirrored pretty much the same thing, primarily chum salmon again, with a smattering of everything else. So that was our one snapshot in time, sort of 2016, where we could compare our estuaries and our nons, and this is sort of integrating things into that longer term time series at Cowichan. And I'm not going to focus specifically on the numbers, but we're going to sort of just in this plot look at the overall trends. So we start out here in 2012 and 2013, where we have lower consumption in the spring, and then it increases into the summer and fall. Then we saw that again in 2014. This time the collection was taken up by Ben Nelson, a PhD student here at UBC. And then we followed up in 2016 and 2017. And the same pattern persists every single time. Not surprising given the biology and what we know about salmon. But if we do want to focus a little bit on one particular time, let's look at the spring period and look at some of the variability that we see. So in 2012 and 2013, it averaged around 12 to 13% salmon in the diet. Then Ben came along in 2014 and it dropped for anywhere from 0.5% or a couple of month periods up to about 5%. And then in 2016, we saw roughly the same thing. So we were 5, 4, and 2.5, roughly 2.5%. So what can we take from all of these sort of summaries that we've been able to grab? Well, number one, salmon consumption, much like salmon runs, are both variable in space and time. No surprise there. So what we want to stress here is that site selection clearly influences any kind of estimates of consumption that you want to make. So when we were comparing our inside and outside estuaries, we saw some major differences in the fall on adults, and then again some minor but potentially important differences in the spring. Our annual and seasonal variability also clearly influence those diet estimates. So diet in the estuaries follow that annual pattern, but it's really highly variable year to year. And so collectively we can say that there's really should be in the take-home message today is there's no single number that can be used exclusively for salmon consumption. And really the long-term monitoring is the key to assessing impacts on these commercial and culturally important species. And I'm happy to say that we were able to DFO was able to maintain some of the collections at some of these sites in 2018, as well as getting out of the Strait of Georgia into some other locations for some where salmon runs are increasingly important. Thank you. Be happy to take any questions.
Question? Question up here.
Hi. Do you think there's much of a difference in dominant years for sockeye? Like, are we going to see a lot more from this year's data that maybe sockeye could be one of the primary salmon species that we're eating?
Absolutely. So back to the space and time. So spacing, we were collecting in Cowichan, not a lot of sockeye through there, but if you were sampling, say, in the Fraser River, in the summers, so you'd see a much different picture for the species and potentially fluctuations through that 4-year cycle. Absolutely.
I have to stop there.
You betcha.
Thank you, Chad. And a reminder to our speakers if they would come down and use our speaker chair. We talked before, so I know where you are. Our next speaker is Zach.
Thank you. Many thanks, Andrew. So I'm a graduate student here at UBC. I work in the Marine Mammal Research Unit studying birds to save the salmon. It's all interconnected. Surprisingly, that's not how I came out here originally. Andrew shipped me out from Nova Scotia to focus on seal predation on salmon smolts. But what I quickly found out is that it's not just seals that are eating the salmon. I'm going to tell you a little bit about that. So seals have been identified. Seals have been identified as a major predator of outmigrating salmon smolts, and actually seal density in bays has been linked to low survival during outmigration. However, recent studies have suggested that there seems to be a high amount of mortality, a high level of mortality during the outmigration. So before the smolts even enter the bay, there's a lot of mortality in the freshwater system beforehand. So I decided, you know what, I'd like to know what's going on there. And looking at the literature, I decided that probably the best predators to focus on would be river otters, American mink, raccoons, and mergansers. The literature was pretty adamant about these guys being major predators of salmon in Atlantic environments, and I thought it might translate over to our system. So what we used was PIT tags, passive integrated transponders, that were released in a number of river systems throughout the Pacific. And we were looking for these tags in the scat of these predators as well as in the digestive tract. And surprisingly, what we found was nothing. So I spent a lot of time looking for this, a lot of time sort of in the grudge work, in the thick of the scat. And I found nothing, and that was about 3 months of my life. And then I thought, I should probably start asking some questions around here and see what's going on. I ended up moving out to focus on seals in the bay, looking for tags and haulouts, and I was getting a ride with a Cowichan Tribes biologist, and I was sort of vetting my discouragement, and he said, well, there's probably a solution. Maybe, do you ever think it might be the herons? And I thought, well, of course I've thought that, but just to be sure, how would you look at the herons? And we ended up going that day and scanning the heron rookery at Cowichan Bay, and found some of my tags. So the heron rookery, we found the tags in the scat underneath the nests. This is what the heron rookery looks like at Cowichan Bay. This is what a happy camper looks like in Cowichan Bay Heron Rookery. Just thrilled to be back in the scat. And what we found was in Cowichan River, where we focused most of the study, we actually found about 500 tags, 450 tags in that heron rookery after 3 months of finding nothing. So I thought, you know what? I wonder if it's just the Cowichan River herons or if this might be a bigger trend. we ended up looking up in Big Qualcom River where there was one large release of coho salmon tagged, and I ended up finding about 130 tags there. And then I finally saved up enough money to get a ferry home, and I went over to Stanley Park for a walk, and I saw some heron rookeries there, and I checked, and about 600 tags in the Stanley Park heron rookery, and I thought, Tim, you might have been onto something. And so we found over 1,000 tags to date in local heron rookeries. And when you look at these tags, so for the rest of the study, for the rest of this talk, I'm going to be primarily focusing on the Cowichan River, because the Cowichan River is the Chinook stock of the Cowichan River is actually an indicator stock used by DFO to assess the overall health of Chinook in the Salish Sea. So we figured if there's something going on, it'll be happening to these guys as well. And what we find is that so we used the number of tags released. The proportion of the numbers of tags released compared to all the number of hatchery smolts released. And we were able to estimate the total number of smolts consumed. And we find that in a relatively normal flow year, there was about 10,000 smolts of the 600,000 released that were subsequently eaten by herons. In 2015, another relatively normal flow year, about 5,000. And then 2016, we've got a severe low flow year, and what we see is a big old spike. So predation, it just about doubles, and this might be attributed to the fact that herons are limited to foraging by water depth. So when the river flow goes down, it may be that there's just more access to the fish, more areas and habitat to forage. Also, when it's lower flows, the smolts tend to take longer to move down the system, so it may just be spending more time in these predator hotspots as well. And then 2017 returned to a relatively normal flow year and a relatively normal amount of predation. And when we look at the number of fish that this equates to per nest, it's actually quite a high number of nests. So there's about 100 nests active nests at the Cowichan Heron Rookery, and they're each getting their fill, is basically what it looks like. And when we look at sort of the size distribution of these fish, so this is a density distribution of the fork lengths of tagged fish, all the tagged fish released in those 4 years. And then when we look at how this relates to the size of the fish that we found at the heron rookery, we see that the fish are generally larger, the ones that the herons are taking. Now, because there's not a very large difference, although it is a significant difference in the fork length size, we suspect that this isn't necessarily selective foraging by herons, but it may be more likely variability in the habitat use between different size classes of fish that may influence susceptibility to heron predation. And that's all I have time to talk about right now, but just a general look forward here. I'm going to be analyzing the other two data sets that we have, the other two river systems where there's been large amounts of pit tagging. We're actually going to use bomb calorimetry and dietary energetic requirements of breeding herons to determine what proportion of the energy requirements are actually met by salmon smolts, both hatchery and wild smolts. And we're also going to be looking at the relative susceptibility of coho versus Chinook salmon from the other two data sets where there was multiple species tagged. And from that, we should get a pretty good idea of what's going on, which will be interesting. I should note that surprisingly, herons don't exclusively crap in their homes. So this is a minimum predation estimate. So not all the tags that are taken by herons are subsequently deposited in the rookery, and of those tags, there's only a certain amount that are actually found, maybe due to broken tags or a lazy field assistant, whatever it may be. So it should be stressed that although this predation is 1 to 3%, seems to be depending on flow, it's likely considerably higher. I see Andrew motioning here, so I'll start shuffling off. I want to say that surprisingly, I didn't do this by myself. I worked with BC Conservation Foundation, helped me in the field, Department of Fisheries and Oceans, in collaboration with Cowichan tribes, and this project was funded by Pacific Salmon Foundation through the MyTax program. And the pictures were provided by Robert, who was a man that I met at Cowichan Bay, who just had a really nice camera. And I want to thank you all for coming, and I'll move on. Thanks so much.
I have time for one question. If anybody has one, up at the very back.
Sure, yeah, no, that's, yeah, I mean, that's the one that's not mine. All the other stuff is mine. Yeah, you have that one, sure. Here, let me just, this was all crap, apparently. We'll just shuffle right through that. Oh, the seal one, yes. Okay, this one I did make. I feel better now.
Okay, Zach, of course we have to move on.
Okay, thanks so much, Andrew. Appreciate it.
Thank you, Zach. And I'm very pleased now to welcome up Strawn Tucker, our first-time presenter at our BC Marine Mammals Symposium. Welcome.
Hi, thank you. I'm just going to touch on things we've been up to and things we hope to do as far as population assessments go for pinnipeds breeding in BC. Just going to focus on that today. So as far as stellar sea lions, aerial surveys are undertaken during pupping season for total breeding population assessments. Range-wide surveys are conducted on a 4-year interval in coordination with our US counterparts. So the last survey was in 2017, and our final abundance estimates from this are expected to be reviewed in the fall of 2019, and this is in an internal DFO peer-reviewed process. So you see from the plot, following some intense, periods of intensive hunting and culling and subsequent protection, that stellar sea lions have population has grown exponentially. We're currently at about 40,000 animals. As far as harbor seals, the Strait of Georgia is an index site, given that it has the highest densities of seals and about 40% of the population. And here, surveys are undertaken every 5 years. So our last survey was 2014, and we plan to undertake the Strait of Georgia survey this summer, hopefully in conjunction with our colleagues down in Puget Sound. Again, since DFO began their standardized surveys in 1971, I should have mentioned that, you see this exponential growth, but here in the Strait, the population actually plateaued and has remained sort of constant at around 40,000 animals. And this happened back in the mid-90s. So as far as estimating harbor seals coast-wide, so since the late 1990s, all areas of the coast have been surveyed on a 5 to 10 interval from which we derive a coast-wide abundance estimate. It actually takes a couple seasons to undertake this, as we literally look at every rock on the entire coast for seals. So the last compilation was in 2008, and we just completed the survey this past summer. So the final counts and results from that will be reviewed in 2 years. And down below is just the line is just the trajectory of the population. Again, you see this rapid response, cessation of exploitation, but that growth of the population has generally tailed off in subsequent years. So we seem to be in and around historic norms at this point. Just to drill down a little bit into how these numbers are estimated, it's basically, so here I'm talking about harbor seals, it's basically a two-step process. You obtain the census from the aerial surveys of haul-out sites, and then you have to correct for those by accounting for the proportion of animals that are not hauled out at the time. And this is done by a sample of telemetry tagged seals. So you can understand the proportion of animals that are hauled out during your peak survey times related to tide and time. So we think we're seeing about 60% of the animals now. But the last of these deployments were actually done in the early 90s. So since then, a lot has changed. So as you recall, the harbor seal population in the Strait of Georgia is no longer increasing. There is evidence for redistribution of animals to the north. Maybe there's some competition or density effects. Also the prey base has actually changed over this time too. But also their major predator, transient killer whales, have been increasing and are more commonly observed in this area. And I think maybe Lance will be further exploring this. So there is some evidence suggesting that seals might spend more time ashore to avoid killer whale predation. So it's possible, maybe likely, that haul-out behavior has changed in the intervening 25 years since those last deployments. So to that effect, we plan to undertake new deployments starting this winter in the Strait of Georgia. It'll likely be a multi-year effort. And then from there, we hope to move to other areas of the coast to similarly develop these calibration coefficients. So remains to be seen where we're going to be and what the implications might be for our population abundances. So as I'm kind of the new kid on the block here, as sort of the new lead for the Pinniped program, I thought I'd just briefly introduce myself. I cut my teeth in the Pinniped realm on the East Coast, comparing diets amongst 3 species of North Atlantic seals. As it can be hard to find jobs in the Pinniped world, I spent the last dozen years studying the ecology of juvenile salmon, ranging from finding stock-specific coastal migration patterns, look at the effects of variable ocean conditions on growth and survival, or say looking at the role of infectious agents on predation susceptibility. So I'll just do a little plug for our program. Of course, population assessment is foundational to any further research, and we are a research program. You know, we're a team of ecologists looking to ask ecologically pertinent questions. So, excuse me. Yeah, so we're just across the pond. We're looking to expand our capacity and our collaborations, and give us a call. Look forward to working with you in the future. Thank you.
Questions? Any questions? What are you going to ask? Okay. I guess you're off the hook.
All right. All right.
Thanks very much, Scott. So I'd like to ask Katie Florco to come up.
Thanks. So for the last 5 years, our team has been going up to the Churchill River estuary in western Hudson Bay to study the behavioral ecology of harbor seals. But what I'm going to talk to you about today is some trends that we've noticed in the abundance there. So I'm sure most of us in the room have seen about 1 million harbor seals, and we know that they're really well distributed throughout the coastlines in North America. They're also found in the coastlines in some areas of the Arctic and subarctic, but presumably in lower numbers. So they're really versatile seals, so if that's what you're looking for, these are your guys. I want to introduce you to another important seal species, the ringed seal. And ringed seals, looking good, they're the most abundant Arctic seal. And so they're widely distributed across the Arctic and subarctic, and they have a life history that's really tightly linked to the sea ice. So they do things like maintain breathing holes in the ice as shown here. And they give birth to their pups in birth layers on the ice and that kind of thing. So they're really fit for the Arctic environment. And so in Hudson Bay, we have both of these species. So it's an area of the species overlap. And Hudson Bay is also an area that there is seasonal ice coverage. And so there's this seasonal trend where in the fall, ice freezes up, freezes over, in the spring it breaks up, and then you have this open water season. And I'm going to talk about the harbor seals in the Churchill River estuary, which is located here. And so, as I mentioned, at the end of winter, all of this is frozen, and all of the seals, both species, are in the bay. So no one's in the estuary at this time because it's all frozen over. In the spring, when it breaks up, the estuary breaks up first, and it's like clockwork. When the ice leaves the estuary, the harbor seals jump in right away, and they reside there for the open water season. Whereas the ringed seals will stay on that last remaining ice that's there, and then when that clears out, they'll reside on the coastline of the Hudson Bay. And so we have this really great opportunity when we have the harbor seals in the estuary to study them. And so when we first went up, we were doing behavioral observations. So we were doing things like looking at social interactions, and for my honors thesis, I was looking at haul-out trends. So things like what predicts the number of seals that we're seeing out, or that we're seeing hauled out at any given time. Is it time of day? Is it temperature, wind speed, that kind of thing? And so every 30 minutes we would do a scan count of the population, count the number we saw, and then carry on with our behavioral observations, then every 30 minutes and so forth. I'm not going to talk about those results today, mainly because that was before I had an appreciation for normally distributed sampling effort. So I had to get pretty creative to pull a thesis together for that. So hopefully one day we'll have some wonderful hull-out estimates and correction factors like in the last talk. But for now, we kept going back to try and hammer out what our questions were and that kind of thing. And so, of course, whenever you're studying the ecology of an Arctic species, you have to address the elephant in the room, and we certainly weren't the first to look at the ice trends in Western Hudson Bay. And we found that over the last 30 years, and this is a common trend that we're seeing, there's some changes in the timing of ice events. So where we're seeing that ice breakup in the spring is happening is happening earlier in the year, freeze up is happening later in the year, and overall what we're seeing is this increase in the duration of the open water season. And so what does this mean for the seals? So the really abundant ringed seals, they have been monitored more regularly. So we have seen there's quite a bit of interannual variation in the density of seals in Western Hudson Bay, but with an overall declining trend. There's also been an overall declining trend in body condition. So what about the harbor seals? So luckily for us, we had spent quite a few days doing this and this and this. And so we had a lot of count data throughout the open water season. And what we were able to do at this point with this nice data set is extract the maximum number of seals that we saw every year to get an idea as the minimum known alive that we have for that year. We also got our hands on some reports from the late 90s and early 2000s that had done some similar population surveys in the area. And what we found was an increase in the number. So that was something that was kind of interesting. We also saw some other interesting things for the first time. So we saw perhaps some evidence of breeding or pupping. So we saw some males with some fresh-looking wounds, some females with some fresh-looking pups. So you can start to get an idea of how they're using this habitat. And now the mechanism of this increase in population, it's hard to say what it could be. It could possibly be a population increase that could be associated with that longer open water season and increased productivity. It could also be immigration and redistribution, but it's hard to say, so hopefully we can get a handle on that in the future. So for now, what we're looking at up next is looking at some of the behavioral responses that we may see of the shift in species in this area. So their role in the food web, perhaps, with potentially more harbor seals, less ringed seal, what would that mean in the food web? So looking at vigilance and that kind of thing. And I'll have you know I am considering normally distributed sampling. Thank you.
Questions? Over here.
So I think I'm just overcome by all the scat talks. Is anyone looking to see if diet has changed over this time?
No, unfortunately. There is a PhD student at the University of Manitoba who's looking at the ringed seal diet with fatty acids and stable isotopes. So hopefully that'll give us at least an idea in what the fish populations are doing.
Last question.
Yeah, I was just wondering, did you observe any killer whale predation on the seals?
We didn't, no.
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 Were killer whales in the area but targeting belugas or something?
I don't think that they went in as far as where the hull out is. So they were more close to the mouth of the river.
Okay, thank you very much. Now call upon David Costalago.
Thank you, Andrew. So we're going to leave British Columbia now. We're going to leave Canada. We're going to leave the American continent. I'm going to take you to Northern Europe. The Baltic Sea is one of the largest brackish areas in the world, and it's also home for 3 species of seals. We have ringed seal. I think Katie and I took a very similar photo here. Which it's pretty much in the north of the Baltic Sea and a little bit in the east. We have harbor seals in the southwest, and in the central region, what is called the Baltic proper in blue, we have gray seals. Particularly, this population of gray seals have been increasing exponentially since the late 80s until very recent years, mostly due to the ban in the use of chemicals like PCB and DDT. Also in the Baltic Sea, we have very important fisheries for especially cod, herring, and spread. And it happens that the stocks for these three species have been either decreasing or at very low historical low levels in recent years. And particularly for cod, if we look at here, this steep decline started also in the late 80s, around the same time when the gray seals started recovering in the region. So obviously this raised some concerns about the role that the seals were playing in the decrease of these fish. So we decided to investigate if the gray seal predation in the Baltic proper was having an effect on the fish biomass. So to answer this, we used a food web model that was built by Maciek Tomczak and collaborators using the EcoPath with Ecosyn software. And so this model comprises 23 functional groups from phytoplankton and cyanobacteria all the way up to in the trophic chain to seals, and also 3 fisheries for cod, spread, and herring. And we had time series data from 1974 to 2015. But we're going to focus only on these 4 groups here, represented here: adult cod, adult herring, and adult spread, and the effect of seals on those 3 groups. So what we did with the model was we ran simulations from 2016 to 2098, but before that we provided the model with some particular possible future scenarios. So we had 2 cod fishing scenarios. So these are cod mortality levels due to fisheries. On the right side you see FCOD1, which is relatively high cod fishing mortality, which is similar to the fishing mortality that there was at the beginning of the 21st century in the region. And then the FCOD03 is the cod fishing mortality according to the advice of ICES. We also provided environmental scenarios. These are very complex scenarios, so you have the reference there, the references to go to if you want to know the details. But we can summarize this as the environmental 0 scenario as the best case scenario for climate change and for nutrient levels from fertilizers in the Baltic Sea. The intermediate scenario as EMV1 and the worst case scenario as EMV2. And on top of those, we put some seal abundances scenario. So we had a fictitious scenario where there's no seals in the Baltic Sea after the year 2016. We have a scenario with a number of seals equivalent to the current number in 2015 for all the simulated period. And then we have another scenario where we let the seal abundance increase up to 50 times the number of seals that there were in 1974 at the beginning of the time series period. So going to the results here. On the y-axis, you see the average biomass for the entire simulated period. The x-axis is the different environmental period, the best case scenario, the intermediate scenario, and the worst case scenario. And the different colors are the fishing scenarios for cod. And these I'm showing here only in the no seal scenario. And if we look at cod at the top, we see that the cod biomass is much higher, obviously, when there is a lower cod mortality from fishing. And interestingly, it's in the intermediate scenario, environmental scenario, where we have the higher biomass of all of those scenarios for cod. But if we look at herring and spread, we see that it's under the high cod fishing scenario where we have the highest biomass. Obviously, because cod is also predating on these 2 species, so when we remove the predator, this spread and herring will increase as well. But surprisingly, we had a highest biomass for these 2 species under the worst case scenario, probably due to the increase of nutrients from the fertilizers in the Baltic Sea. But what is even more surprising is that when we include the seals in the equation, we see no difference virtually in the fish biomass, meaning that this number of seals were not having an effect on the fish biomass. So if we increase the seals up to 50 times, we still see no significant differences in the fish biomass. So we can conclude from that the environment and fisheries have a stronger effect on fish biomass than the seal predation in the Baltic Purple, which coincidentally is very similar to the title of the paper that just got accepted a few days ago, and it's going to be online next week if you are interested, hopefully. And I have to end by thanking my collaborators in Sweden and the funders and data providers. Thank you.
Have any questions? Question? Oh, no. That was good, David.
Thank you, Andrew.
And David will be down at the front afterwards to take other questions or discuss some of that. Like, I want to talk to you. Right afterwards. Mike DeRusso, next speaker.
Thanks, Andrew. There's been some great talks this morning, and now we're sort of shifting into a little bit of a different vein here with just a quick update on what we've been up to over on Salt Spring Island in the skeleton shop. Figure out which right one. All right, there we go. So our first project that we were working on this year is the Biggs killer whale T44. And this, of course, is for the Whale Interpretive Center in Telegraph Cove. So we've been quite busy and taking on a few volunteers and staff. The new trainees sometimes fall asleep on the job, unfortunately, but doing well. And it's also great and a lot of fun to involve 3 generations of the family now, for big days like the moving day. And I do encourage everyone who's going anywhere near the North Island to get into the Whale Center, the Whale Interpretive Center, and have a look at T44, who's just a fantastic specimen, one of the largest killer whales on display in a museum. He's just about 25 feet long, so a real big guy. Moving on. I used to get model kits as a kid. Now this is one of the most ultimate model kits. We collaborated with the Pacific Museum of the Earth across the road here. I guess they were a little bit jealous of the blue whale, and so they wanted their own. This is not a marine mammal, but it did swim in the oceans. It's a 42-foot prehistoric marine reptile, so not technically a dinosaur, but lived during the same era. This summer, Michi and I went over to Australia to check out one of our new jobs, which actually started a very, very long time ago. So blue whale skeleton from 1898 that's been on display. It was one of the first blue whale skeletons on display in a museum anywhere in the world. 1902 was first put up, and now it's waiting for us to do a new revamped articulation and display. It'll be opening in 2020. So who knew that one of the most important whale researchers on the coast, John Ford, would have an offspring who became an artistic welder and is now putting together flipper armatures for humpbacks and other things. So just after getting back from Perth, we started focusing on another fantastic project which we've just finished and installed up in Telegraph Cove. So here's Katie Ford inside the belly of young humpback. Many of you might remember this individual washed ashore in White Rock, live stranded in 2012, and then was brought up to Telegraph Cove. So this was just a couple of weeks ago, getting this whale installed, and really neat sort of perspective. These guys have huge heads, and kind of fun to sit inside the mouth of the whale. Also, one of my favorite animals that I've worked on, just with these massive flippers, and I encourage you guys to get up and see this one too. So it's been a great busy year, and thanks for listening.
Any questions? I will say for those who are not familiar with Mike's work, it's all over this building. And I'm sure he'd be pleased to walk around and point out things you probably never noticed on them. And we're hoping that he'll be doing a northern elephant seal for us. So next time you come next year, there'll be something new to unveil. Thanks very much, Mike. And our next speaker is Nicole Haynes. And if Eric is here, maybe have you come down too, near the front. Over to you.
Hello, everyone. How's everyone doing? Woo! My name is Nicole, and I am one of the 3 co-founders of Whale Tales. My 2 other colleagues are here with us. We have Lindsay Curtis here, giving a wave. And also way at the back, Sarah Given, who has my 4-month-old son in her arms. So just apologies in advance if he starts to cry. He'll be good. So I wanted to come here today and give everyone a bit of an update about what Whale Tales has been up to over the last year, and also, for those of you who don't know, who we are. Which button do I press? Because I missed that. The right one? Thank you. Okay. So for those of you who don't know what Whale Tales is, we started 4 years ago. It's okay, honey. We started 4 years ago, and we launched right here at the UBC Marine Mammal Symposium. So it's actually a very special event for us. It's where we were born, you can say. But our idea came from, we wanted to create a place online that would be free and accessible to anyone, anywhere around the world who wanted to learn the stories of whales. Because we're based here in British Columbia, all 3 of us are from BC and familiar with the whales in these waters. That was really our starting point, but ultimately we really wanted people who lived on the coast and who lived in landlocked areas but were passionate about whales to be able to get access to the stories that those of us who are lucky enough to spend our lives on the water know about. So that's where we started, and officially we are now a living library of cetacean stories. This past year, our 4th year, we added 144 new stories to our library. We launched our 500th story just last week, which was a huge deal for us. And we now have just about 20,000 followers who can go into our library and access these stories. And coming from myself, as I grew up in Winnipeg, Manitoba, but I've been passionate about killer whales since I was 4 years old, I always like to imagine that at least one of those 20,000 people is a little girl like me living in the prairies who just wants to know about whales. We also launched our Tales of Saving Whales blog series this year, which I'll talk a little bit more in just a minute. In total, though, these are the numbers that really impress me and really kind of make me think, holy, what did we do when we created Whale Tales? As I said, we have 500 stories now up online. 291 of them are orca stories. We have 96 people who have submitted stories. We have 10 regularly contributing storytellers. These are people who spend primarily most of their life out on the water and who send us story after story after story after story. I see a few of them in the audience today. And we have over 30 different species of cetaceans whose stories have been cataloged. This is the really impressive one for me, though. Those 500 stories span over 16 countries. So we're getting stories from all over the world, and what started as a very local, homegrown BC storytelling space is now a worldwide library. We wanted to be more than a library, though. So starting this year, we also wanted to try and encourage those people, again, who live in the coastal zones, but also live in landlocked areas, to get involved with what they can do to protect these cetaceans they're passionate about. So we launched a blog series called Tales of Saving Whales, where people who both are marine biologists or researchers or whale watchers, but also people who are artists and who are accountants and who are teachers who don't live anywhere near the ocean, where they can share their stories about what loving whales has meant to them and how it has impacted their lives and what changes they're making to try and protect the oceans no matter where they live. To help those people who maybe didn't know what they could do to protect the oceans, we also, let me go back for a second, we also launched a page on our website called What You Can Do. Go figure. And this lists things that are very easy for people to do, that make, thank you very much, Andrew, that make people think maybe, okay, well, I'm going to get just a metal straw instead of a plastic straw, but also really big things like how you can get in touch with your member of parliament or with your congressperson, depending on where you live, to try and get access to help make bigger changes. If you would like to share one of your stories with us, we would love to hear it and we'd love to post it. This is what our website looks like when you go to whaletales.org. Just click the share button right there. It's easy peasy. You can also share on Instagram, whaletales.org on Instagram. And there's all the information there. Thank you very much. We've got a little bit of mom break. Shamelessly share my picture of
No,
myself.
that's fine. Don't get it. Any questions? I might ask you just one. And what's the most favorite or most listened to story on your site?
That's a very good question. We have a lot of stories about Granny, and I think those are probably certainly some of my favorites. But a lot of people like reading those stories. Yeah.
Thank you very much.
Thank you.
And next speaker is Eric. And it'll be lunch right after.
Good morning. My name is Eric Schwartz. I'm going to tell you a little bit about the Wild Ocean Whales Society. We're a Canadian registered charity based in Powell River, BC. Since 2010, our Marine Conservation Society has been working to highlight the whales and dolphins and porpoise of the BC coast and to raise public awareness, respect, and enthusiasm for their protection and welfare. We have a number of major projects. First is the Whales and Dolphins BC website. We are involved in producing cetacean sightings mapping. We conduct public and boater cetacean awareness campaigns. And we distribute thousands of pamphlets each year to marinas, to businesses near public docks, and at public events during the season. Our pamphlets inform and engage the public as active participants in ensuring the well-being of our cetaceans and as advocates for their protection and conservation. And you can find those pamphlets outside on the table near coffee. Our society is equipping public cetacean viewpoints with binoculars and cetacean information plaques. And our first marine life webcam is located at Malaspina Strait at Grief Point near Powell River. Our cetacean education work focuses on kindergarten to grade 12 students and the general public. And teachers and enthusiasts can find educational resources on our website, and more are being added all the time. We hold multimedia education events on cetaceans for hundreds of school-aged children. We hold free public presentations, run workshops for whale enthusiasts, and deliver guest presentations. Each year, thousands of cetacean sighting reports are submitted to WOWs by whale watching and tourist boat crew, by other boat operators, and by whale observers from shore. Our reports are received by text, VHF, online forums, phone, email. And our international team of dedicated analysts, volunteers, all of us, review and break down the raw reports into classified, consistent, geolocated cetacean sighting records of value for research, as well as informative sighting text of interest to our cetacean enthusiast readers. Our cetacean report photos and videos are handled by our volunteer media editors who match the media files to submitted sighting reports. Our approved sightings are published online in Whales and Dolphins BC sightings updates twice a week during the season and twice a month otherwise. Publication notices reach thousands of subscribed readers around the world via email and social media. Each issue also includes local wild cetacean photography and video supplements and our Wild Cetacean News magazine. The Sightings Archive dataset is available in its entirety for download. Published under Creative Commons license for non-commercial scientific, educational, and personal use, the dataset includes just under 15,000 sightings, records between 2014 and the present. The bulk of the sightings fall between West Vancouver and the Broughton Islands and into the inlets. Most of them are during the boating and whale watching season, although we get reports all year round. And of the 15,000 reports and 17 species, over 7,000 are humpback whales and about 3,500 are Biggs orca. We are very eager to get feedback from the research community. This data is available for download for your use. The data set may be analyzed on our website using a Google Fusion table that provides search, filter, and download, together with links to all the photos, video, and audio files. Formats available are Google Sheet and Common Spreadsheet file formats. Our site also includes the Archive Explorer, our public online cetacean sighting mapping tool. July 30th, 2017, our sightings update reported that Gary Henkel of Aboriginal Journeys, Whale and Grizzly Bear Tours had photographed and reported the entanglement of the extremely well-known humpback whale known as kelp creature, or KC for short. Spends most of his time in Discovery Pass, Soodle Channel area, and subsequently disappeared. The Society assisted the DFO whale and disentanglement team searching for KC, providing them with an updated animal track information from our sightings map archive. Our August 3rd issue subsequently reported that our favorite humpback whale, KC, was finally found after a couple of days searching and looking back through the track through our maps archive for most likely search location. He was found at one of the most distant locations over the previous week for disentanglement, free of the floatable line. These are our websites. I'm Eric Schwartz. My contact info is here. We welcome questions from the research community. And as we said, our data is available for download. You're welcome to access it through our site. Thank you.
I want to ask one question to you before we break, and that is, how can people get involved with your group if they're interested?
They're urged to just send a question to info@Wild Ocean Whale Society or wows.org. You can find our volunteer link on our websites, and access to our latest sightings are available every 2 weeks this time of year and twice a week during the season. You're welcome. We have volunteers from really all over North America right now, and we're always looking to help train additional volunteers and connect with other organizations. Thank you.
Thank you, Eric.
Thanks.
I want to remind the speakers to please come down to the front in just 1 minute. And also want to wish sort of bon appetit. We're going to have our lunch here. Where you are, it may be lunch, it could be dinner, it could be a midnight snack, or maybe it's breakfast. We will be back in 58 minutes. And we've got a great afternoon here of seals, sea lions, whales, and yes, the southern resident killer whales at the end of the afternoon. See you in 58 minutes.
Just a reminder, Joan Lopez, if you're in the building, I need your presentation, please.
We're good to go. Welcome back, everybody. It's now 1 o'clock in Vancouver, BC. My name is Andrew Treitz, and I'm a professor and director here at the Marine Mammal Research Unit. And for those that are just joining us online, this is the 26th annual BC Marine Mammal Symposium. We're going to quickly move here into a session on seals. We're good to go. Welcome back, everybody. It's now 1 o'clock in Vancouver, BC. They're 1 minute behind us. My name is Andrew Treitz, and I'm a professor and director here at the Marine Mammal Research Unit. And for those that are... Is this UBC IT, Marcus? No? Okay, UBC gets some slack this time. I do want to let people know that are watching online that coming up after our afternoon break, we have another 3 hours of presentations, about 20-some talks, and we will be talking about the southern resident killer whales and some of the ongoing research and concerns about them. Our next speaker coming up, assuming we're all set to go, is going to be Rhea Storland.
Thanks, Andrew. So I know a lot of the time when we're thinking about marine mammal science, we often think of ecology and we think of field work. As a physiologist, my work is a little bit different. So what I'm going to share with you today is my experience in the lab, but it's a lab like no other. So when I started about 2 years ago, I was incredibly fascinated by the ability of marine mammals to hold their breath. And I was really curious about how their hearts allow them to do that. There had to be something unique about the heart of a marine mammal that would allow them to hold their breath for so long while they're diving so deep, all while actively foraging, as well as avoiding predators. So I set about exploring that question, and it was really important to me because knowing what kind of physiological constraints there are to diving has huge impacts for an animal's dive behavior. So what I know about hearts and what I know about human hearts didn't match up with what I could see happening with marine mammals. So there are two big challenges that a marine mammal's heart would face. The first is a slowed heart rate, and that happens while marine mammals are diving. And with a really slow heart rate, in some species it's down to 2 or 3 beats per minute, that could actually cause blood flow to slow down or even stop. And if blood's not flowing, that means that oxygen isn't getting to the tissues that need it. More specifically, it's not getting to the heart, and it's not getting to the brain. Additionally, marine mammals may be struggling with an increase in blood pressure while they're diving. And this is caused by peripheral vasoconstriction. So the blood vessels at the muscles, they actually constrict. And you can think about how that would increase pressure if you imagine blowing through a flattened straw. It's much more difficult than when the straw is full. And so that can create an increase in pressure that the heart would have to pump against in order to get blood flowing. Now, I talk about these as two challenges. These are actually two components of a marine mammal's dive response. So these are the two of the things that allow them to do the dives that they do. To me, that means that their hearts are going to be facing these challenges repeatedly and for sustained periods of time. So in order to answer this question, I had to look at some hearts. So I got a chance to work at the Stellar Lab at the Vancouver Aquarium, and it's a lab like no other. So what you can see here in this photo, that brown furry couch, that's a Stellar sea lion. And attached to its flipper there, you can see that it's got a heart rate monitor, and that's those wires that lead to the computer. But that's not just a computer, that's actually an ultrasound. And beside me in that photo is Dr. Marco, and he's a veterinary cardiologist, and he's the reason why we were able to see the sea lion hearts. So we use a technique called echocardiography, which is just an ultrasound of the heart, and it allows us to visualize the heart while it's beating. So we can watch as it contracts and it relaxes, and we can take measurements on the dimensions of the different cardiac chambers. We can look at how thick the muscular walls are. As well, we can even measure blood flow. What's fantastic about this technique is that it's standardized. So there have been measurements that have been taken in a few other species, such as cats, dogs, cows, buffalo, even wolves. And what I was able to do was then compare our sea lions to those terrestrial mammals to see what was different. And this is what I found. So if this is our stellar sea lion heart, the first blood vessel leaving from the left ventricle is called the aorta. And in marine mammals, it's enlarged. And we saw this in our stellar sea lions. Now, how would that help? Well, first of all, it can keep blood flowing. So that would deal with that challenge of a slowed heart rate. Secondly, it could actually reduce the pressure that the left ventricle pumps against. So to imagine that, I've got a little demo here. So if you can imagine that this balloon is like a large aorta. So it's pretty easy for me to blow up. However, if it wasn't so large, it would be like me trying to blow into this balloon. And that's so difficult that I'm not even going to try. And so what I want you to think about here is that would be the amount of work that the heart would have to do if there was no large aorta. So when we have that potential increase in blood pressure while a marine mammal is diving, the heart might not have to work as hard. Additionally, we looked at the size of the left ventricle when it was contracted and relaxed. And what we found is that there was less contraction in the ventricle of a sea lion than terrestrial mammals. Now, the thing to think about here is that all of the measurements I was taking from these sea lions are essentially resting measurements, so they're not diving. And so what this suggests to me is that there may be some capacity for marine mammals while they're diving to actually compress their hearts even further to increase their force of contraction. And again, that would allow them to address that second challenge of the potentially high blood pressure that they could be facing. Now, in addition to these measurements, I was also looking at the electrical activity of marine mammal hearts. So I looked at a wide range of species of marine mammals and compared them to terrestrial mammals, and I was also seeing differences in cardiac function there. So to sum up, what I've seen is that yes, marine mammals do have specialized hearts. And what that means is that if we continue to learn more about their hearts, then we may be able to learn more about their diving ability and what constrains it. So I'd like to say a huge thank you to everyone who's involved with the project. I know many of you are here, so thank you very much, as well to the audience. Thank you.
Do we have any questions? Question over here.
So did you solve the problem of how something like an elephant seal manages when its heart beats only 3 times a minute?
I have not solved that problem. So that kind of speaks to the large aorta that I was talking about. And it's a structure that they've termed the aortic bulb. And what we believe is that it acts like a wind castle. So similar to the balloon that I just blew up, when the heart beats, the blood would be pumped into that balloon that would expand. And then just due to the elastic recoil of the balloon, when the heart's not beating, what's going to happen is it will just let the blood flow continuously. So that's what we think is happening, but I haven't observed it myself. I think there has been a study looking at it in an MRI, but that's the extent of my knowledge.
Can I? So I taught this stuff at one point and I never got it, so you're perfect. When the animal's pushing blood around its body, it's supposed to use those big renal portal veins to store blood. Did you do any work looking at that?
I haven't looked at the veins yet. The hepatic portal. I have not been looking into veins at all yet. I do hope to continue that as I continue on in my research, the cardiovascular system though. Thanks.
Thanks so much for your And now I'd like to call up Joanna Fee.
Is the video or the video?
Yes, go
Hi, so I'm Joanna Fee, and I'm just going to be telling you a little bit about my honors project that I'm working on, which is chemoreception and stellar sea lion foraging. And a more simple way to say that is, can they smell? And so there's a few things we know about the sensory systems of stellars. So that would be how we know how they find their fish, how they find their prey. So we know that they have eyes that are adapted to see both in the water and on land. However, this visual acuity, it decreases. It decreases when they dive into reef systems and into kelp forests where there's a lot of turbid waters, and it decreases as they dive to depth to find their prey, and the light in the water decreases. As well, they have vibrissae on their face that are able to detect movement in the water, so they're able to follow the hydrodynamic trails of their prey. However, also that decreases when they're looking for their prey because there are tons of fish around, there's tons of movement in the water that interferes and makes it harder for them to find their prey. There's a lack of evidence for echolocation. I say this because we have a lot of cetacean researchers here, and with sea lions, we haven't found conclusive evidence that they're able to echolocate to find their prey. We do know that other pinnipeds can detect chemical cues in air, so there's been several studies on fur seals that have showed us that. And there's a lot of other marine animals that are able to detect their prey in the water. So as we know, fish are able to detect chemical cues by moving water over their sense organs. However, cetaceans, again, have absent or reduced olfaction systems. There is this really cool phenomenon that's been pretty recently observed, and well, it says 2008 on the picture there on the side, where star-nosed moles, another aquatic mammal, are able to engage in what's called underwater sniffing. So what they do is they produce air bubbles against an object and actually reabsorb those air bubbles, which is believed that they're sensing a chemical cue. However, we don't know that about sea lions, but we think that it would be an interesting question to investigate because we do see this really cool phenomenon in other aquatic mammals. So that's what I'm looking at, is are stellar sea lions able to detect chemical cues in air and water? And so what exactly I want to do is develop an olfactory training protocol with the trainers of the Vancouver Aquarium on how to train olfactory discrimination in these sea lions. So it's a more experimental approach, like in the lab. And with this protocol, I'm hoping to determine if stellar sea lions are able to detect the presence versus absence of chemical cues in air and water. So I'm using some experimental subjects that are the stellar sea lions at the Open Water Research Station. So currently I'm working with 4 of them. And what we're going to do is we're going to train them, and it's what we're trying to do right now. So we're using discrimination testing. So basically a discrimination test is when we present a scent and the absence of a scent in the case of my project, and see if they can discriminate between those. So we'll be training them using paired behaviors and positive reinforcement. So phase 1, which is where we are right now, is we're training the sea lions to discriminate between the presence and absence of chemical cues in air. So we'll be using a vanilla extract cue, and this is probably a question that'll come up, and why am I using vanilla? I'm using vanilla because I tried with squid for many months, and the thing is, squid has just become habituated to their environment, and it's not anything too exciting, so we want a very distinct thing that will elicit a response in them. So vanilla, we have found, is not aversive, but it it brings their attention more than the squid did. So what we're trying to do on land is shape a behavior that we can transfer to water trials, which will actually answer the question in my research. So right now what we're doing is, as you can see in the pictures, this is one of the trainers from the aquarium. We train the animal to approach a diffuser and take a deep breath in, and then it is supposed to pick a target. So we have paired the black target with the absence of scent and the white target with the presence of scent, the vanilla scent in the case. So next should be a video. So in this video, a slow-mo video apparently, you can see the sea lion approach the diffuser and take a deep breath in. There she goes. And then pick a target. So that's where I am right now in my research. So we'll know whether or not the sea lion is able to discriminate between the cues when it's picking more than 75% of the time the right choice. So we present the scent 20 times in a row, or the presence or absence scent 20 times in a row. So the next steps in my research are to take this to the water. So once we've trained it on land, we will be taking them to the water and bubbling the air past a scent cue. And the animal will dive into the water and again, hopefully take a breath, or however they may interpret the scent in the water, and then pick a target. So that's where I am in my research right now. And the whole point of this project for me is to determine how they might find their food in the environment where they hunt. And obviously, I don't do this by myself either. I do this with a lot of people. So my supervisor, David Rosen, and a really awesome team of marine mammals and technicians at the Open Water Research Station. Thank you.
Are there any questions? Not. I'm going to let you off the hook and have you come back next year and tell us what you found. Thank you. Next up is our runner with the speaker, or the sneaker, Aaron Purdy.
So I'm really excited to see Andrew run around with the microphone after this. So to start things off, I'd just like to ask a quick question. Who all here, just by show of hands, is familiar with the concept of the wall? And how many of you are actually runners? Yeah, that's where I lower my hand too. So in running or in a marathon, the wall is this point where you're running along and then you hit this point where you physically feel you can't go any further. There's been a change inside your body, some physiological limit that you've reached that hinders your ability to move. So what I'm interested in looking at is similar types of physiological limits that sea lions face while they're diving. So obviously, like I said, I'm looking at their diving. You don't usually see sea lions running in marathons like this, but when sea lions are diving, they're looking for food, and it's really important that we understand how they are capable of diving and when they reach these physiological limits, because it allows us to make predictions about how they might react if there are changes in their food or in different types of environmental factors. So a sea lion, when it's diving, it's usually quite good at this comparatively. It has all these physiological adaptations that allow it to stay underwater for a long time. They dive, they're looking for food, they're eating, they're having a good time, and then bam, they hit the wall. Now, I should say that this wall is not the same that you would expect to see in an athlete who is running a marathon. Instead, this is something called the aerobic dive limit. So this is the point where lactate begins to accumulate in the muscles of these animals. So for my research, what I was interested in looking at was when and how stellar sea lions are hitting this physiological wall of the aerobic dive limit. So just a quick overview of how we think of the aerobic dive limit. So this is how it's been thought of in the past, is that dives are usually separated into two distinct points. At the beginning of a dive, it's considered an aerobic dive. So this means they're using aerobic metabolism to produce the energy they need to actually sustain that dive. These dives are considered efficient because they rely on oxygen, and also that they're quick to recover. They're producing lots of energy, and they're able to recover very quickly from that dive. However, eventually they hit the wall. The aerobic dive limit, after this point, they are considered to be going into anaerobic diving. So instead of using aerobic metabolism, they're instead using anaerobic metabolism. Anaerobic metabolism assumes that at this point, they assume that they've used up all of the oxygen that they've brought down with them in their lungs, blood, and muscles, and now are only going to be producing energy through this less efficient form of metabolism. In addition to that, they're accumulating lactate in their muscles, and this lactate can cause fatigue, potentially cause fatigue in their muscles, but also needs to be processed once the animal returns to the surface. So that means they're going to have an increased recovery time as well. So this portion of the dive is considered inefficient. There's producing lactate, which potentially is causing fatigue, and also they're slower to recover from. So how do we actually measure the aerobic dive limit? So this is data that we see from a Weddell seal, and it's actually of blood lactate measurements once the animal is returned to the surface after varying durations of dives. So what we can see is that there is at the early portions of a dive, or for a short dive, lactate levels are very flat. And then at a certain point, they begin to skyrocket. They begin to accumulate. And this is the point that is considered the aerobic dive limit. Now, that's what is the case for a Weddell seal. How about a stellar sea lion? So to tackle this research, I've been lucky enough to work at the Open Water Research Lab with 4 trained stellar sea lions who are all trained to dive in the open ocean. I'm sure many of you have heard about this. On the left there is one of the animals that I work with. Her name's Hazy. On the right is the platform, the research platform that we actually do our research on, which I'll go over in a little bit more detail. So how this actually works is on this research platform, we have feeding tubes. They extend down into the water. They go down to 40 meters, which is a relevant foraging depth for stellar sea lions. And they're called feeding tubes because we're actually able to pump fish through them. This gives us some control of how long these animals are going to be diving for, because a sea lion's only going to dive so long as they're getting fed. So as soon as that fish stops, the animals are trained to surface and come up onto the barge, where we're actually able to collect voluntary blood samples and measure how much lactate is in their blood. We actually use a lactate meter, the exact same type of one that if any of you have done training for running, it's the same type of meter that we use there. The reason that we're able to do this awesome research is because of the incredible relationship that all of the sea lions have with the trainers at the Vancouver Aquarium. It's incredible that we're able to take them out into this open water, but also incredible that we're able to get these voluntary blood samples. So what I mean by voluntary is that the animal isn't under anesthesia and they're actually presenting their flipper willingly to actually collect a blood sample. It just shows how much trust there is between the animal and the trainer and vice versa. It's really an amazing thing. It also means that we can collect our blood samples very quickly after a dive. So we're able to get a relevant blood sample with that lactate in it. So as a quick reminder, this is what it looks like for a Weddell seal. The blood lactate for early dives is very flat, almost nothing, and then after a certain point begins to skyrocket. This is what it looks like for the stellar sea lions, and as you can see, it looks quite different. This isn't what we expected at all. So the first takeaway here is that lactate is accumulating right at the beginning of a dive. Not only that, but there doesn't seem to be any distinct switch where it's flat and then it increases. This seems to imply that not only is anaerobic metabolism occurring early in a dive, but also that it is continuing to be used maybe to a greater extent as the dive progresses. So what does this actually mean? Well, for starters, it means I kind of failed in my research. I set out to try to find when and how stellar sea lions are hitting this physiological wall, and it seems that there might not be a wall at all. So I should clarify that I don't think stellar sea lions are doing anything particularly different than other marine mammals. What I think is instead we should maybe reconsider how we think about this aerobic dive limit. So this is our historic view, as I shared before, of how we thought about the aerobic dive limit, where the dive is separated into two parts, the aerobic and anaerobic portion, with a distinct switch at some point in the dive. What I would propose is that instead maybe we think about it instead of a wall, but as more of a transition, where at the beginning of a dive, it is mostly aerobic, and as the dive progresses, there's a slow and gradual transition towards more of an anaerobic dive. So once again, coming back to why we do this, it's important that we understand how these animals are diving so we can understand how they might be meeting these physiological limits in a changing environment, whether that is there's a change in their abundance of prey or they're changing to a different type of prey source. Using this research, we'll be able to better understand and predict how they're going to react to changes in the future. Really want to send out a big thank you to everyone who helped make this research possible. Obviously, all of the trainers and staff at the Vancouver Aquarium, as well as everyone with the Marine Mammal Research Unit, plenty of other people as well. Happy to take a couple questions.
Oh, runner's question.
At the back, preferably.
Aren't I? Here we go.
Is there any reason to think that your subjects who spend most of their time getting their food handed to them, how their anaerobic, how their lactate levels would be different from those who spend 100% of their time collecting food diving?
Yeah, absolutely. If you think of the way that lactic acid might be accumulating in my body versus a trained athlete, it's likely going to be different. So yes, that is definitely a possibility. It's something that would be interesting to study in the future. However, it's really hard to get these types of blood samples from a wild animal. So this is actually as close as we can get where these animals are diving in the open ocean and getting this type of diving experience more so than an animal that is in a pool. So,
thank you, Aaron.
And next up, we have Wendy Zanislow.
Good afternoon, everyone. I hope you've all had your lunch because I'm bringing it back to scat. I know you're all liking the scat and poop talks earlier. I do want to acknowledge the Pinniped program at DFO, without which this project would not have been possible. This was a personal project that started a few years ago and was greatly supported by the Pinniped program, and it's turned into an exciting collaborative project, which I'm going to share with you right now. The purpose of my project was to investigate the seasonal diet of sea lions in Clackwood and Barkley Sounds. I have a few different objectives. Today, I'm only going to be focusing on the first, and that's determining the seasonal diet of stellar sea lions at Long Beach Rocks, which is a seasonal haul-out site in Pacific Rim National Park Reserve. So, why scoop poop at all? A few reasons for doing it. First, there are a few things that we do know about sea lions. We know they're recognized as indicators of ecosystem health and fish abundance. We also know that stellar sea lions are, they feed on seasonally available prey species that are abundant and densely aggregated. And if anyone has been watching the media, particularly social media to do with marine mammals, you're probably also aware that the increasing number of stellar sea lions and California sea lions are raising concerns regarding their impacts on fisheries. What we don't know, however, in BC is the seasonal diet of sea lions. And the DFO Stellar Sea Lion Management Plan has identified studying the diet outside of the breeding season as a research priority. This is one of the reasons I took this project on, other than being very interested in trying to know what the animals were feeding on at other times of year. And my hope is that the results will increase our knowledge regarding the potential for fisheries competition for prey resources. So the study site, this in green, we have Pacific Rim National Park Reserve off the west coast of Vancouver Island. Long Beach Rocks is right up here, smack in the middle of the Long Beach unit. So that is a year-round stellar sea lion haul-out, and that's where the sampling was done. For methods, scat was collected once per season at Long Beach Rocks during the fall of 2015 and winter through summer of 2016. Today I'm only going to be commenting on the results of the first year. I did collect once per season for a second year as well. During the second year, I also collected California sea lion scat to add to the project, and that was collected once per year, only in the fall, and also collected in Barkley Sound at a haul-out called Folger. 40 scats were collected per site per species. For analysis, I haven't had the pleasure of joining DFO colleagues in the lab for this, but I hear that it's going to be my turn very soon to deal with the other end of the scat processing. The DNA analysis follows protocols described by Thomas et al., and the hard parts are also going to be analyzed. Samples are going to be identified the lowest possible taxon. And I know a lot of you have heard talks or presentations about diet and the scat, and it occurred to me that unless you're actually on a haul out, you don't really know what that scat looks like. So this is the things that we're looking for on these haul outs. And I have to say, it's pretty amazing the different textures and colors that scat comes in. Just a little aside there. So preliminary results, again, I'm so thankful to the support I had by volunteers. Some people had a bit of trepidation coming out, but coming off the haul out, I had people with great big smiles, bags of scat. They absolutely loved it. So it was just great to have them all along. So for year one, I do have the DNA analysis done, only for year one. So I'm going to show you a few plots here, and what I'd like you to pay attention to is the overall diversity of species that have been consumed. So this was the fall collection. About 30 different species were consumed during this season. And I just want to point out the top 3 prey assemblages. Salmon, number 1, followed by flatfish, and then forage fish. So I just want you to kind of remember that in your mind as we switch to the winter. Quite a difference. So again, one thing that's similar is that there is quite a diversity of species that have been consumed. Again, about 30 species. But here we see that the forage fish and gadids are the top prey items. And what I found fascinating was cephalopods, octopus and squid, coming in third. I also heard from those lab colleagues that that was a very disgusting sample to be working with. Apparently the cephalopods are quite stringy Maybe I won't use the other words that I was told. So spring, this was the season that had the greatest diversity. 39 species were consumed from the samples that we collected. Again, the top 3 prey assemblages are gadids, other, and then down to cephalopods once again. Now, I did want to point out that the only one value of a specific species that I have retained in these plots are Chinook salmon. And that's just because, again, a lot of attention in the media regarding Chinook salmon, and I anticipated some of you may have wanted to know the value specific to Chinook. So that's why I have specifically kept that value in. Back to summer now, and again, fair bit of diversity in the species that were consumed. We're now up to salmon being the top species that was eaten, followed by forage fish and down to flatfish. So the year in a glance, quite a change over the seasons, but the one thing that is consistent is the diversity. So my hope for next year is that I'll be able to come and present the data for year 2 as well, and have the project's complete data set to be able to present to you, as well as the results of the hard parts analysis, and be able to also share with you what we found the California sea lions to be eating. I wanted to give my acknowledgements to all the supporters and helpers and funders that I had for this project, including the Pinniped program with Fisheries and Oceans. The Clayoquot Biosphere Trust was able to help support my role in this project. And then with all the other organizations, I had lots of volunteers come out eagerly helping to collect the scat, and it was incredibly appreciated. Thank you.
One over in the far end.
A quick question. You said you had 40 from each species when you're out there. What's the difference between a stellar poop and a California sea lion poop?
We actually, the California sea lion scat was collected at a different haul out altogether. Yes.
Do you know anything about the diet yet?
No, not yet for the California sea lions. Not yet. Eagerly awaiting it.
Next year, come back. We're going to move on to thank you. 2 talks coming from the Vancouver Aquarium related to marine mammal health. First up, we have Megan Strobel, and if Marty wants to come down and take the hot seat, it's waiting for you.
Oh, that's bright. Hi, I'm Megan. So I'm going to be talking about a case that we had at the Marine Mammal Rescue Center. His name was affectionately Yuki. But I'm going to talk about his ballistic trauma that he sustained that we treated a few months ago. I will give you a trigger warning. This involves gunshots and a deceased animal. So the Marine Mammal Rescue Center was called by a member of the public in Ucluelet that said that he was an adult male stellar sea lion with about a 2-day history of sitting on the side of the road, which you can kind of see in this photograph right here, that he was emaciated. The public was able to approach him and touch him without really much response from him at all. And he had nasal and kind of ocular discharge coming out of pretty much every hole. And he was coughing. So we assembled a team of about, I think, 8 people who went from Vancouver to Ucluelet. Once we found him, because he had actually moved away from the road, he was kind of in this brush area here, and then kind of over on this side was a little bit of a shoreline, and then there was about a 7-foot wall from which we could get access with a truck. So once we found him, we watched him for a few hours before the van was able to arrive. A team of 2 had come in a plane. He was lethargic. He was barely responding to anything that we were kind of touching him with. He reached his head up at one point, which you can see this photo here. Once the van got there, we sedated him, rolled him into kind of a sling, moved him to the base of this wall,
Some really awesome people with a crane helped crane him over this wall and into our van, and then we went to the ferry. In the truck, he was started on fluids and antibiotics, and then kind of awaiting further diagnostics. I think that skipped a slide. Oh no, okay, sorry. So we got some blood work on him, which was consistent with inflammation. He had a very mild regenerative anemia, which was 27%. He was hypoglycemic, so his blood sugar was very low, and he was dehydrated, so there are some markers here that we were looking for in his blood work. We tested him for leptospirosis, which was negative. His fecal culture had normal kind of things that you find in a stellar sea lion poop. We took a swab of his nasal discharge, which grew Streptococcus equi and Arcanobacteria foci. So he was on proper antibiotic therapy for that. We continued his medications, which the doses are right there. I don't want to go too much into the medicine with this. We added some pain medications and an oral anesthetic gel. He was still not eating, and then about 3 days later, we kind of wanted to, once he had been a little bit more stabilized, we actually sedated him again for another exam. So this is a view of his x-rays that we got, which you can see these little metal pieces in here, which are consistent with bullet pieces. At that point, we also did a really good physical exam where Marty found a large hole in the top part of his mouth that was spewing out discharge, which was where the origin of all that discharge they had noted. So unfortunately, he continued to decline. He wasn't eating at all, and about a week after we did the x-rays, he really wasn't doing well, and so we made the decision to humanely euthanize him. And so this is a post-mortem CT that we did, which really highlights, all right, so I guess I'll go back. So this is a 3D reconstruction model of his CT that we did after he was euthanized. So this is actually kind of the trajectory of the bullet wound. So on the top of his mouth, you can see right here is the original hole straight from the left side through to the right side of his eyeball. And then this side really highlights the bullet wounds, which are these kind of like starburst features here, and all the damage to his right orbit. This very quickly, you're going to look for starbursts, is going from his eye to his brain, maybe.
Wrong video.
Oh, there we go. So all these starbursts are little metal pieces that you can see within his brain, or within his orbit, not within his brain. His brain actually didn't have any bullet pieces in it. How do I go to the next slide? Okay, this is the graphic photo I was talking about. So this is his hard palate, and this is the original entry wound with all that inflammation and necrosis that you can see around this. The scissor right here is actually the trajectory of the bullet from the left side into the right side of his eye. And then we actually got little pieces of the bullet that the Vancouver Marine Police Unit took a look at and identified it as a 5.5 caliber bullet that is most consistent with the size that is shot in an AR-15 rifle, or, but it can also go in several hunting rifles as well. So as a restricted weapon in Canada, this could have been done in the US or in Canada, but it could also have been like a hunting rifle in Canada. And so I just want to thank the Vancouver Aquarium Marine Mammal Rescue Center, the Marine Mammal Department, the Veterinary Department, all the donors, DFO, Parks Canada, the Windsor Plywood that supplied the crane, Canada West, Eric Kiss for putting together the CT images, lots and lots of people. So, thanks.
Any questions? I'd like to ask? Oh, one in the very back. You're both going to be talking on.
I was like, I'm out of time.
I just wondered if the supposition was that the gunshot wound had been done on purpose, or if it had been accidental, or whether there was any thought given to
I
that.
think it's assumed to be on purpose because he actually had no wounds under here. It was actually, he had to have had his mouth open. I think it's generally assumed that it was purposely done. I don't think so. It was a very specific trajectory as well.
Thank you very much. And our next speaker will be Marty Helena.
All right. Sorry, I wasn't paying attention to how this works.
No, just leave that there.
Just leave that there. So far, so good. Okay. Thought I'd spend some time to tell you the story of how the veterinary group was involved with J50 this last late summer. Seemed to be a story that generated a lot of interest, certainly within this group, but also outside as well. And there was a lot of media attention brought to this little whale, who's pictured here in happier times. Working with a whole lot of folks on this. I apologize if I've left anyone out, especially if I left any institution out. I'm sure I have. Here's a small snap of the institutions that we were involved with over the course of about 6 to 8 weeks that we were brought in to discuss J50 and what to do about her. If you don't know, J50 is obviously a member of the southern resident killer whale subpopulation. She is approximately 4-year-old, or was a 4-year-old calf, born to J16, pictured here. A lot of our information comes from photogrammetry work by both Holly Fernbach and John Durbin, and also technique pioneered by our own Lance Barrett-Leonard as well. And it was some of the most objective, valuable data that we had to work off of. Back in about May or June, scientists from NOAA were alerted by Ken Balcom and his group that J50 was in much worse condition than previously been reported. She'd always been a small whale. However, in the last little while of 2018, she'd become prominently emaciated with that loss of nuchal fat, and then that term I absolutely cannot stand, peanut head, which made everyone in the world an expert on the peanut head syndrome. She was also noted to have possible some fetid breath by one researcher, and follow-up photogrammetry continued to show lots and lots of weight loss, and there's the progression there. So you can just see her kind of wasting away between in front of us. I saw her close up twice within about less than a month between episodes, and she was remarkably thinner on the second go around. This is the graph of her and some of her cohorts. You can see the black line just drop out, and essentially the quote from Holly and John was that we've never ever seen a whale come back from this body condition, and of course that premonition held true. This is some of the sort of the, I don't know, this is the stuff we did, summarized by Kristen Wilkinson at NOAA, just showing you the heavy observation that she was under, some of the veterinary intervention at the time, some of the biological sampling that was happening as well. Obviously, we were very limited diagnostically. As a dumb veterinarian, it was, you kind of have your hands tied. We had a lot of observations, essentially her losing weight for a very long period of time without any evidence of her actively feeding. We were able to take advantage of some techniques like blowhole samples and catching some feces as well from her group to look at different things, but nothing to hang your hat on, nothing conclusive. Again, bacterial samples and consistent with organisms that you might normally find in the water or normally in upper respiratory tract of whales. Feces and worms that you might find normally in whales as well. So basically what we boiled down to was, what can you give a juvenile killer whale that will do no harm, to the best of your knowledge, that may help or might cure a completely unknown chronic condition? And so a lot of our decision making was based on our experience with animals living under human care, was based on pathological data from animals that have stranded through Washington and BC. We know what medications have been used in killer whales and similar species and what their outcomes might be. We're limited to things that can be delivered into the muscle, limited to the volume of the dart, and we're limited to how often we might be able to see the animal. So you can see the problem here, right? So we decided on going on with an antibiotic named Convenia, because it is convenient, that can be concentrated. And we also decided to try and treat with ivermectin, which is an antiemetic, an antiparasite drug. Not that parasites would be a primary problem, but perhaps they give her some opportunity to recover. This is her being darted. Can you start this? Because I have no idea how to do this. Click the mouse. Mouse. No. Click back, then click this mouse. Okay. Oh no, it's really slow motion. I got 13 seconds left. Why is it in slow motion? No one knows.
Your video is too high.
My video is too high quality, UBC.
That'd be good. If that comes up again, I'll take it.
Oh no, that's me.
I see her.
Oh, that's even me talking. And essentially, this is how we deliver the medication. She's going to come up on the second time here. We timed it. This is Dr. Deborah Giles, who's driving for us. She's absolutely awesome. Worked with a lot of incredibly experienced folks around these animals. Here the click, but the sound is way in front of the thing here. So that was the click of the dart. There she is. And there's the dart. And then there was a feeding trial that was tried as well and associated with the lamination. That unfortunately did not prove very successful, but it was an early attempt. I wouldn't discount it in the future, but it was a way to try and deliver other medications to her orally, as well as to just gather some diagnostic information. Was she eating, or what could she even eat? We didn't know that stuff. And then of course we went to capture contingency and all that stuff, but as you know, we did lose sight of her. The vet team saw her on the 7th when they delivered some ivermectin, and then after about the 8th, we couldn't find her at all, and so she was pronounced dead. Learned lots of lessons. The big one is how to work together with a large, diverse group of folks that have a large number of different opinions on things, but everybody working for the same common goal. That's always something very important to remember. Everybody loved this whale, and everybody wanted the best for what was, for this whale. And we never lost sight of that big picture. That was very important. We knew that we were just trying to save this one whale, but we know that there's a lot of big issues facing this whole population. But those things have to work in synergy, in my opinion. We got to work hard for every little whale while we give them time, while we work on the bigger pictures as well. And that's, I guess, where we are. So we've got some different techniques. We've got some good conversations going. We've got some great people on both sides of the border, and government and other institutions as well. And that's where we are. Thanks.
Somebody want to toss a question Marty's way? Okay. Hey.
I'm just wondering if you ever saw any prey sharing behavior with her family. Like, did any of her family members try sharing prey with her?
Yeah, so there's a bunch of folks in here that know a lot more than I do. So as far as I know, during the time that we were involved with her, although other members, we did observe, foraging with other members of her group. The Jays were actively foraging. We never ever saw any evidence of her prey sharing off any of those catches. She was around, she was in proximity, but through the photogrammetry while they were being caught, or with us directly from the boats, and the observers that were with them that really know their stuff, nobody ever actually saw her eat.
Thanks, Marty.
No worries.
And Jessica is our next speaker.
Hi, everybody. So my name is Jessica Terode. I work at the Coastal Ocean Research Institute, and I'm here today to talk to you about an exciting new project that we've been working on, the Whale Report Alert System, or RAS for short. So what is RAS? It's essentially a cetacean conservation tool that we created for commercial mariners in order to reduce cetacean vessel disturbance and collisions. So it's an alert system. It's only available to commercial members, commercial mariners, and not members of the public. And it alerts mariners of large commercial vessels to whales in their vicinity. Just a little bit of background about the program. I'm the coordinator of the BC Cetacean Sightings Network. I'm sure many of you are very aware of our program. We are a citizen science program. We collect sightings of cetaceans and sea turtles throughout BC through a volunteer network of over 6,000 observers. We currently have 113,000 sightings and counting in our database. And what's really great about this database is it's always been curated by at least one full-time staff member, so it's really high quality data. And these data are used for conservation-based research projects. In 2015, we developed our first app, the Whale Report app. So this was established for more accurate and efficient reporting by our observers, as well as to increase real-time whale reports. So observers can submit a report in under a minute. As well, the exact location of their sighting is recorded in the report because it speaks with the phone's GPS. We've had a lot of success with this app. So now over 70% of our sighting reports are received through Whale Report. So this led to the development of the Whale Report Alert System. So this was funded by the Port of Vancouver and the Port of Prince Rupert, and we have just received confirmation of funding from the Government of Canada as well. It was developed with a working group comprised of marine professionals that provided advice and expertise, and they're all listed on the right-hand side there. So this is how it works. So an observer would spot a cetacean. They would then submit it in real time through our Whale Report app. It then goes through a vetting process. So it's an algorithm that checks for qualities. So it has to be a trusted observer, so someone that we know is experienced, as well as if that observer has a high species ID confidence level. So once it passes that vetting process, it goes to the Whale Report Alert System. So then when a commercial mariner is within 10 nautical miles of this reported whale, they can receive alerts in one of two ways. It can come in straight onto their cell phone through an SMS text message that then prompts them to open up a map, or it can come through the vessel's operations center. So these operations center staff can look at it on a map and then inform the bridge crew of that vessel that there is a whale nearby. And then the mariners are able to provide feedback as well, so they can let us know what mitigation measures they were able to take in the presence of these whales. So some of those actions can be slowing down, diverting course, turning off their sounders, or keeping it in mind and increasing vigilance through that area. So this is what a RAS user would see. So that little blue dot there is the vessel location icon, or in this case, that's my office at the Vancouver Aquarium. And then the red circle there, that is a humpback whale alert. And it might not be hard to see, but there is a bit of a kind of orange halo around it. So that means that that alert is less than 30 minutes old. So all of these alerts have a decay function, so they're only active for a certain period of time, and this is species specific, so it depends on the known behavior of the species. So then a user can click on the sighting and they can receive more information. So the time that the sighting was received, the number of animals in the group, the location coordinates, and the direction of animal travel. There's also a feature where you can look back into archive sightings for 24 hours, and this is really useful for route planning for vessels. So looking forward into the future, we'd like to do a 6-month trial assessment. So this will look at the utility of RAS as a technology as well. We really see visual detections as just one part of the story. So we've built RAS to be able to incorporate other whale detection technologies as they become available, such as infrared detection or acoustic detection. As well, we've also built it to eventually incorporate it into AIS as that becomes available to us in the future. And of course, the backbone of this project really is real-time, high-quality sighting reports using our Whale Report app. So we really encourage everybody here in the room to report their sightings in real time using this system. And yeah, thank you so much for listening. And of course, thank you so much to everyone who reports to the BCCSN, as well our app developers at Spatial Vision and everyone at the Corey Lab. Thank you.
Any questions from anybody? One up here in the middle.
So the Whale Report app, is that specifically just for vessels, not for people like whale watchers who are out there all the time and know where the whales are? If we were to, are we able to report specifically to that particular app, or would we have to go through the Cetacean Sightings Network?
So you would report your sightings with Whale Report, and then they would push your sightings to the Whale Report alert system. So Whale Report is public for everybody, but you don't see sightings from that. And the Whale Report alert system is private, and it just shows the sightings. You can't actually report using the Whale Report alert system. That makes sense.
Thank you, Jessica.
And if anyone wants to see it, I have it on my phone, so find me afterwards.
Thank you. Our next speaker is Lisa Spaven.
It is bright up here.
Hi everyone, I'm from Fisheries and Oceans Canada. I just wanted to give you guys an update on a fairly giant survey that we did this past summer called PRISM, the Pacific Region International Survey of Marine Megafauna. And let's see if I can make this thing work. The catalyst for doing this survey, a survey that hasn't been done at this size in scale in BC before, is essentially coming out of the US. A rule under the Marine Mammal Protection Act that's been in place since its inception, but only just being enforced now, is a rule for fish and fish product import. And it means that foreign countries wanting to export their fish to the US have to prove that their marine mammal bycatch limits are sustainable using a couple of different methods, and that the countries are monitoring that bycatch and implementing methods to limit bycatch if it's above standards. So in the past decades, we've done a lot of work on a lot of things with Fisheries and Oceans Canada in our survey work. Most of that's been focused on distribution and diet and habitat use, and not so much on population abundance. But we need population abundance for each species in order to determine what PBR, or potential biological removal, is, to be able to meet those needs under the Marine Mammal Protection Act bycatch rule. So work that we've done before isn't up to standards for developing these population estimates, although work had been done previously by Raincoast, and those are in the inshore waters of British Columbia, and those are just slightly out of date at this point. So we did a lot of work this summer. We got a lot of ship time, and all those red lines are where we went. It was a systematic line transect survey, coordinated with a survey that was done on the US coast as well. And the inshore component of this survey was replicated on the design of the Raincoast surveys that were done between 2004 and 2008. The result is that we traveled 17,000 kilometers, and that's 17,000 kilometers of effort. So in really bad weather conditions, that's not considered effort. So that's a minimum number of kilometers traveled there. There were over 800 hours of acoustic data collected. And I guess I should tell you that not only were we visually observing for marine mammals, we were also towing an acoustic array 24/7. And we deployed 120 sonobuoys over the side at specific nodes in our grid, or when there were animals of interest in the vicinity. We had 2,800 on-effort sightings during this time, and you can see on the map they are well distributed throughout our grid. We had 20 different marine mammal species observed, and 144 acoustic detections were made. A couple of key species I will tell you about. Bluefin humpback whales. We had 6 visual sightings of blue whales. You'll see them in the blue dots on the map. Those were of 10 separate individuals, and as you can see, they are fairly offshore in their distribution. The fin whales, the yellow dots on the map, are fairly widely distributed. There were 252 visual sightings of 383 animals. Humpback whales, as you can see in green, are very much distributed on shelf. 812 visual sightings and over 1,200 individuals seen. With sperm whales, we saw 17 and had 17 sightings that actually, even though we only saw 17 of them, we acoustically detected 53. So with sperm whales, they're deep diving. If we're traveling at a certain transect at a certain speed, we're not going to see them all because they're down deep for, well over an hour. And we had 12 sonobuoy detections. So you can see the difference there. The visual detections are in blue. Anna, you'll like this slide. These are the harbor porpoise sightings that we had during our survey. Very few offshore, as one would assume, given their distribution, although there were some further on shelf on La Perouse and so on off the west coast of Vancouver Island. 286 visual sightings of harbor porpoise, and we did have Beaufort 0 to 2. That's the only way those sightings are happening, and that whole section from, say, Desolation Sound all the way around to the mouth of Juan de Fuca, we had perfect sighting conditions for porpoises, and we were very happy. We were concerned we wouldn't have enough sightings for an abundance estimate. And we finally, after how many years? I've been working for the federal government for 19 years, and we hadn't seen a sei whale yet In fact, we haven't seen a sei whale in a very long time, and we finally saw one. There's proof. In fact, we saw a few. Here's a bit of a history on the sei whale. There were over 4,000 animals killed during the whaling era up until 1975 in BC. They were everywhere. And since then, there have only been 2 sightings of 4 individuals seen actually by a NOAA Japan Cetacean survey back a couple decades ago, over a decade ago. But now we have an updated map. 4 visual sightings of 5 individuals and 8 sonobuoy detections throughout this survey. This was big news for us. Perfect timing. So I wanted to just mention some acknowledgements. Because we were able to get this extended period of ship time with the Coast Guard, we had to convince a lot of our DFO colleagues to offset their own work to give us this ship time. So great thanks to them. Great thanks to the Coast Guard crew for on the Tully and the Tanu and all of our observers and our acoustic team. But with 11 weeks at sea, we needed a little levity. And we were a little bit obsessed with the life aquatic. And we actually turned our fearless leader, Thomas Daniel Valcroze, into Steve Zissou. And if you really want to know what goes through the mind of a marine mammal observer while at sea for just that long, I put together 166 songs in chronological order throughout the survey. And you can probably guess what was happening that day based on the song titles, and I'll just read out some of them here. Let me tell you about my boat. We were really proud to be on board. Let's go west. Smoke on the water. We had troubles with that this summer. In fact, that's a new visual category for observations, smoke on the water. Foggy mental breakdown. It happened. The horizon has been defeated. It happened a few times. Sad, Lisa. I can see clearly now in every breath you take. You're welcome to follow that list if you'd like.
Have any questions? Got one here.
How long do you estimate it'll take for a report to be prepared based on that with abundance estimates and so on?
We're going to be working hard on that over this fall, and I believe it's next year we have a peer review process within a DFO that we'll be presenting for. Yeah.
Okay, we have an online question, and then we'll take yours, Catherine. Oh, you don't have a mic. Okay, in the meanwhile, we're going to take Catherine's questions, and we'll take the person online.
Lisa, I was just wondering how well you were able to tell that you were hearing individual sperm whales. Like, do they have different vocalizations, or how did you know that there were those number of individuals?
I wasn't part of the acoustic team, so I can't say that I can answer this one with accuracy, but to my understanding, the detections were detections of that species, not necessarily of individuals.
And the online question.
We do have an online question by Heather, and she wants to know whether there were any differences in observations when there was greater ship traffic present.
That analysis has not been done, so I can't really speak to that. I know that in where we were looking at high ship traffic was mostly, at least for the portion I was dealing with, was around Vancouver, and I mean, there was killer whales and harbor porpoise all over the place that day. But we weren't tracking vessel traffic in conjunction with whale presence for this survey.
We're going to cut it right there.
Yes, and while I do have a microphone, I would just like to remind our online audience that if you want to ask questions, because we do have a bit of a delay, ask your questions as soon as possible. So once you have that question in your head, just let us know right away so we can ask that in time before the presentation ends. Thanks.
Thank you. Thank you, Lisa. And our next speaker is Simon Surma.
Hi there. So I'm a PhD candidate here at the UBC Institute for the Oceans and Fisheries. And so this is a small sliver of my dissertation work, what I'm going to be talking about here today. So as part of my research, I was looking at what proportion of total production of various prey groups did marine mammals consume off northern BC First of all, in three periods. So first of all, around 1900, so before industrial whaling took off in this area. And then secondly, in 1950, so during the heyday of industrial whaling and when the pinniped culls and bounties were getting well underway. And then thirdly, currently, when both the pinniped populations and the whale populations have either already recovered or some of them are well on their way to recovery. And the toolkit I used to address this is EcoPath with EcoSym, which is one of the most commonly used ecosystem modeling frameworks in the world right now. It's based on a principle of mass balance, which basically in layman's terms, it's a restatement of the first law of thermodynamics. It's based on the idea that the total production of a certain group of organisms in the ecosystem must be balanced by the removals from that group by fishing, by consumption, by predators, other natural mortality, etc., etc. So the input data you need for a model like this is you need diet compositions for all the consumers, which can come from, like you heard, the scat analyses or stomach contents from whaling records, etc. You have biomass estimates, which come from abundance surveys like the one we just heard about, although these would come from earlier versions. Mortality rate estimates, which come from various things, and estimates of consumption per biomass, which is a bioenergetic parameter. And what this EcoPath model, which is basically a sort of static snapshot of the food web, the biomass pools and the fluxes of biomasses between different groups, what this would produce, the outputs would be the total production and consumption of various groups within the ecosystem. So getting down to brass tacks here, we've got in 1900, if you look at the proportion of the total annual production of various prey groups, this is just a selection of the groups in the model, by the way, you can see that, for example, these fish-eating rockfish, a very large proportion of these fish were being consumed by marine mammals, specifically sperm whales, apparently, which were quite abundant here before whaling. For a lot of the other prey groups, the whales and pinnipeds seem to have been consuming about 10% of the total animal production. And the reason this number is so low, despite the vastly greater abundance of many whales here in that time period, is that it seems the ecosystem was quite a bit more productive or had a much higher rate of turnover than what you see now. So in 1950, what you have, in 1950, you still have a substantial consumption of walleye pollock by quite a number of marine mammal groups. For several other groups in both groundfish and forage fish, you have consumption about 20 to 30% of annual production being consumed by marine mammals. A lot of that is still within whales, but also smaller dolphins and porpoises, and is beginning to shift to pinnipeds. And currently, for most fish groups, it's pinnipeds and dolphins and porpoises that are accounting for the bulk of the consumption by marine mammals in the food web. And as you can see, with the recovery of pinnipeds and also humpback whales, which are the black group consuming herring in the lower left-hand corner, you can see that the consumption rates, again, are now approaching between 15 to 20% of the total annual production for many of these groups. So the conclusions we can draw from this very quickly would be that marine mammals were notable consumers of many prey groups in this ecosystem in all three of these periods. They seem to be most important as consumers of forage fish, such as herring, and groundfish, such as rockfish and pollock and so on. Pinnipeds seem to be more important as consumers in the food web now than they were in the past, while whales seem to be slowly recovering their past importance, especially humpback whales, while sperm whales still have a long way to go in that respect. So I'd like to acknowledge my supervisory committee and Dr. Andrew Trites, who's also supported this research with a lot of very valuable advice, as well as my funding from NSERC. And I'd like to ask if there are any questions, if we have time for that.
Thank you, Simon.
Thank you. Thanks for listening.
Anybody with a question? Maybe, Simon, I'll just ask you, so the future, as the sperm whales recover and we get sei whales back, what do you think will change?
With the sperm whales, we may be possibly getting some depredation of longlines like we see in Southeast Alaska, although most of the sablefish in fisheries in BC seem to be dealing with trouts, which would be harder for sperm whales to get at. We may see some competition between rockfish fisheries and sperm whales, although sperm whales up here mostly eat squid, but they're large males which are more piscivorous than they eat more fish than the ones further down south, and that's why they're eating quite a bit of rockfish. The baleen whales, well, the humpback whales are already eating quite a bit of herring, but that doesn't seem to be the major reason behind the herring population problems in northern BC. That's dealt with elsewhere in my dissertation. Blue whales, sei whales, they mostly eat plankton and offshore pelagic fish, so they shouldn't be affecting the ecosystem very heavily. There seems to be more than enough zooplankton to go around, for example, so the whales shouldn't be much.
Thank you very much, Simon. Next up we have Ben Hendricks.
Hello, everybody. I have a little problem, which is I learned 2 hours ago my speaking time is actually only half of what I expected, which means I'm seeing this chicken very vividly in front of me, but it also means that I will be skipping some slides. I'm sorry for that. The work I'm presenting is about localizing whales with long baseline hydrophone arrays. And the work is really just a part of a larger initiative that is conducted by the North Coast Cetacean Society, that is a local NGO in northern BC, with the goal to better understand the habitat needs of cetaceans in northern BC. What they're doing is they're performing acoustic and visual surveys and monitoring in about 200 square kilometers of marine habitat. They've built 2 research cabins for that purpose. 2001, the first one, and in 2017, the second one shown in this picture. The work I'm presenting is a subpart of this project that I highlighted here, with the goal to provide real-time acoustic analysis and information for vessel management. We're located here between Prince Rupert and Vancouver in the southern part of the Kitimat Fjord system. And the Kitimat Fjord system is really a special place acoustically because it has vocalizations and the presence of 3 large species of whales, that is the northern resident and the transient killer whales, as well as humpbacks and fin whales, which is unique for a coastal setting in BC. We also listen to a lot of ship noise, anything between recreational to tankers and cruise ships. We also have other marine life and some electrical noise, which is important to consider for an automized analysis system that we're building. This plot here shows the human habitat in that area, and specifically the shipping traffic equipped with AIS from 2017. Our study site is shown, as well as Kitimat in the north. And as you may have heard in the news, Kitimat will become the terminus of a $40 billion LNG project, and that will bring tankers to that place, a projected 2 passages per day, cutting right through our study site, which makes our research also a timely thing to conduct. This is our acoustic monitoring site. So we have 4 hydrophones that are separated by about 10 kilometers. They're permanently recording and transmitting the data in real time to the research station we have on Finn Island. What that means is we're collecting about 35,000 hours of data per year that wants to be analyzed, and that's what I'm for. Skipping this one. Showing this one, that's just a visual impression of our research cabin with a humpback whale just hugging the shore. That's a view from the inside, so I would sell it as oceanfront property, I guess. And this is one of our hydrophones hidden behind this yellow sock to protect it from all sorts of growth. Briefly about what the automized detection and localization software is doing. Detection classification, what it provides is real-time information about calls we are listening to. It also provides something that is shown here, which I would call an acoustic soundscape summary. So on the upper part, it's just the bubble net feeding calls of humpbacks that we detected within a week in July. You see the day and night pattern during that time. The ambient noise is shown in purple, and the recording consistency of the hydrophone. So that provides already valuable information for anyone who's actually being provided with that data. I also should say we get a lot of whale calls. For humpbacks, more than 50,000 this year. Fin whales and orcas, also several thousand, so it's really acoustically very rich. Moving on to the localization part, which is the hot topic because it's just been developed this summer. This is the theory, and I spare you this, so lucky you. We are going right to from theory to practice. So this is a really important slide for me because it's the ground truthing of how our algorithms are doing. What we did is we went out on a boat with an acoustic transmitter and a GPS device, and we tried to reproduce the GPS location of the signal acoustically from what we recorded. And what we found is on average we could localize to within 40-meter precision. I like there was 30, then I could say it's the length of a blue whale, but so it's a little bit more. And technically everywhere we do better than 100 meters. So we were really happy with this, which brings us to the results, which are hot from the oven, detected between, or prepared between August and September this year when the system went online. This is just a couple of examples for humpback whales. The first one is not even a vocalization, it's a breaching humpback whale. So what we detected is the slab of its body on the water surface, detected on all 4 hydrophones, so we could localize it right in the center of this channel. These are a group of humpbacks bubble net feeding along the coastline, so you can see the group. We could track them for about 40 minutes on September 25th, and the group is working its way from south to north with 5 individual feeding events happening during that time. This year is one of our highlights. It's a singing humpback whale happening on August 25th. For 40 minutes, that whale was performing, and it did so in 4 individual sequences. Each sequence lasted for a couple of minutes with a couple of minutes break in between. And you can see we could really nicely track that procedure it was doing. 1 minute left, and I'll have left 2 slides. I'll make it. Another highlight, just because we saw the picture from the FO before that the fin whales are all offshore. We actually do have fin whales in here, and we detected and localized them. So here they are with 20 Hertz pulses shown in this picture, and we could localize these fin whales in the center of Squally, of Squally Channel. And the last slide is a group of northern resident killer whales that made its way on September 25th between Finn and Pitt Island, and we could track it for more than 3 kilometers throughout the channel. So all that made us really happy. We were able to detect and localize each species, each vocalizing species we have in there, all made possible by a bunch of really great people. We are only a small NGO, so we need the support, and we're grateful for all these contributions. And finally, I want to say that if there happen to be any students in this room, we are always looking for any contributions from summer students who help out to any academic projects from bachelor, master's to PhD. We have a lot of data, acoustic, visual, and in the future, drone data. Thanks.
Any questions? One question from you, Rob.
As someone who built a system like this for the Vancouver Aquarium, but unfortunately never got it completely finished, I'd be curious to know your algorithm that you used, but more specifically, how did you tune for the arrival time distances, and did you make any differentials for time of year and salinity and things like that?
I tested the effect, how well we have to model the acoustic environment. And that would have been part of like a 15 or 20-minute talk. In very short, we were able to just use an average sound speed for the area, which was fine enough. But we tested a complete physical simulation, and it just didn't help in our case. Yeah.
Thank you very much.
Yeah, thank you.
Next up, we have Sarah De Brito Tavares. Go ahead.
Hi everyone, my name is Sarah, and I recently started a postdoctoral fellowship at TFO at the Pacific Biological Station in Nanaimo. And this presentation is a little bit to introduce myself and the project that I just started. So I started in September. I don't have any results yet, but I would like to tell you what I'm doing now. And before I do that, I would like to tell you what I was doing before. So I did my PhD at the University of St Andrews in Scotland, and I was studying the Icelandic killer whale population. So specifically, I was studying the social structure, relatedness, and the population genetic structure of this population. And for this, I was using mainly two types of data. So I was using photo ID and genetics data. And I'm sure most of you already know this, but we can use the unique natural markings of the animals to identify the individuals. And we can track them over years. We can use their markings and the size and the shape of the dorsal fin and the saddle patch, which is that grayish area on their back. And so I can see individuals that are associating in close proximity, so they are surfacing together, so I can see who is hanging out with whom. And with genetics, I can see if the individuals that are associating more, are they family or are they not related, and also how diverse is the population. So I don't have a lot of time to tell you the results of my PhD, but just to give you an idea of what we have been discovering about this population. We now know that not all individuals that are seen in Iceland are seen year-round. Some are only seen seasonally, either in the summer or in the winter, and some are actually seen traveling between Scotland and Iceland. And then regarding diet, we are also discovering now that they don't all seem to only feed and specialize on herring. So, and some animals are actually seen feeding on herring in Iceland, but then in Scotland they are seen feeding on seals. So we have this population with so many individuals, different behaviors and diet patterns, and then in Iceland they are seen in herring feeding grounds, and they are all seen very frequently in these large aggregations where they all seem to kind of associate in close proximity with most of them, and they are all changing associations over the day. So in the beginning of my PhD, I thought that the associations and the social structure of this population could be best represented by this. So it's just a complete mess for me. And once we had more than 150 killer whales inside a small fjord, so it's just very confusing. But with time, I realized that this population had a much more dynamic social structure than we think for killer whales. And some associations were constant and long-term, but others were more fluid and they were changing with time. Also, what I saw is that the different movement patterns and the different diets, they were not necessarily equivalent to the different ecotypes that we see here in the Northeast Pacific. And also is that killer whales that associate more frequently, most of them will be related and from the same family, but some of the frequent associations are also between individuals that are not related. So now I'm hoping to adapt all the techniques that I've learned during my PhD and study the social dynamics of the offshore killer whale population here in the Northeast Pacific. And this is a very interesting population because we don't know most about it. We almost know nothing about it. So we know that they are unpredictably found in nearshore waters. They are frequently seen in large aggregations of 50 individuals or more, and they are thought to eat mainly sharks. That's mostly what we know about them. So I'm really happy to start this project. And this project, my supervisor is Thomas Daniel Valcroze. He's the head of the Cetacean Research Program. And I'm also doing this in collaboration with Hal Whitehead in the University of Halifax. And yeah, I'm just diving into this project now. And it's really important for me because I feel like only by knowing how each individual population lives, we can predict how they might respond to environmental changes, and then we can work on better management and conservation plans in the future. So thank you very much for listening, and I would happily respond to questions now or either during the break. Thank you.
And do we have any questions? We have one. Actually, we'll take two questions. And then we're going to wrap up with Joan before a break.
So are they the same whales which are?
Yes, so the same individuals are seen moving between Iceland and Scotland. Not all of the population. I think maybe now we've matched 7, 8 individuals, and some of them are seen feeding on seals in Scotland.
So they like the herring in Iceland and the seals in Scotland?
It seems like it is possible. It's a lot of different kinds of information that we've been collecting, and it's visual, isotope data, but everything together seems to point that that's a possibility at least. And in Iceland, they are seen in herring grounds, behaving like the other whales that are seen feeding on herring, and actually associating in very close proximity with whales that we see year-round in Iceland, always in herring grounds.
So do you think the BC, when we say offshore whales eat seals and the local ones eat herring and salmon, is that the same thing will be?
The offshore population here seems to feed mainly on sharks. So again, it's a bunch of different information, and most of their diet seems to be sharks, some other fish as well. And then the residents seems to be specialists on fish, mainly salmon, and mammal eaters on seals. So here in the Northeast Pacific, you seem to have very specialized populations. And the Icelandic, it's even hard to talk about it as a population, because then it has so many individuals that maybe they don't behave all the same way and don't have all specialized diets as you see here.
Yeah, sorry, I was just wondering, is that same 8 individuals part of the West Coast community group, the Scotland ones? Or is it a different population that you're talking about?
Is it the West Coast?
The West Coast community.
The one that is dying?
The ones in Scotland.
Is it the one that is dying that hasn't replicated? I don't think they are.
Different ones?
I think so.
Okay.
But my knowledge of the catalog, so my brain just focused so much on the Icelandic catalog, and there are like 500, 600 or so that I think they're not from Scotland, but I should double check that.
Okay,
but I think not.
Okay. I don't think I see any other hands, so thank you very much, Sarah.
Thank you. Thank you.
And our last speaker before our break is Joan Lopez.
Oh, hey, there we go. So yeah, something completely different here. This is not science like a lot of the students and so on have been doing. This is a little bit more of sort of the citizen science sort of collaborative approach on things. Collaborative because it's with many of my colleagues that I work with. So yeah, things have been changing in the Salish Sea over time. So I kind of have been doing this for 3 years now, giving you sort of a rundown of on any individual day, what did we see. So if we had more than one encounter on a day with, say, transient killer whales, it will only show up as one. It's just the way I did it initially, and now I realize that probably wasn't the best way. However, you can sort of see trends here. So the bigs or transient killer whales, pretty constant this year to what we had last year, and that had increased a bit from 2016. So they have definitely been in sort of the, I would say, northern Salish Sea. So the central Strait of Georgia, Gulf Islands, our sightings range from Howe Sound to Nanaimo, say, down to San Juan Islands, Victoria sort of zone. We had 36 days this year with encounters with southern resident killer whales, which is up just a little bit from last year. Our first encounter was not until the middle of June. Most of these were a few towards the end of August, mostly in September. They were often small groups, a macroline or two. They were also tended to be rather short, maybe half an hour tops with the whales, with those whales, and they weren't particularly social or vocal this year. So for myself, I've been doing this since 2003. This is a real change, not only in number of sightings, but also in their sort of overall behavior. We're going to hear a lot more about southern resident killer whales. The real growing one here, we had 80 days with encounters with humpbacks, and that was throughout the season. It is a growing thing, it seems, and the majority of those encounters were in August, believe it or not, and October. Just one with a minke whale, one with a gray whale, so those really don't figure highly. We had 18 encounters this year with groups of 10 or more big killer whales, so that's down a little bit from the last couple of years. This particular picture was taken in Western Howe Sound, sort of between Gibsons and Port Mellon, where this group had gone kind of stealthy. They all came up en masse, and the next time they surfaced, they were underneath a log boom. Do we have to cull the seals? I don't know. I think these guys have sort of figured out some of the places where they can go for an easy seal meal. Log booms, you know, it's kind of, they can get up in between the logs, and the seals just didn't even see them coming. So a little bit of tables here, and I'm not going to dwell on this too much because it's like a lot of information. Anything that was in purple was from last year. From 2017, anything in red is from 2016. Sort of the idea is the trend, that there are certain whales or whale families that tend to show up more at certain times of year than they do at other times of year. And that means that probably, these are all transient killer whales, pardon me, all Biggs killer whales. Probably that means that they're using different parts of the coastal area at different times of the year. Okay, so anyways, we'll just kind of take a look at sort of just the general trend of how that moves. And we'll just skip over that. Lots of babies in the transient killer whales. This year, T123D was probably about a September, October birth, really tiny there. And of course, you know, they're the hunters. They don't just hunt seals. The other emerging thing is humpbacks, and we are seeing all behaviors here from them. This lunge feed is down near Point Roberts this spring. If you get a good shot like that, you can clearly see this whale is Nike. Can you see the swoop there on the right hand? Yeah. So the nickname is agreed upon by pretty much everybody. What's not agreed upon is the identification number for that whale. It has 3. So hopefully in the future, all these different catalogs will come together, and we'll be doing an even better job of identifying humpback whales. And that's it. A lot of smoky days this year. So questions?
I guess my only question to you is, do you observe many direct kills when you're out with the transients?
Yes. I wouldn't say many, but yes, we definitely do observe direct kills, for sure. Yeah.
All right,
But here's something interesting. The southern resident killer whales are chasing harbor porpoises too. They're just not eating them. So there's something to think about.
Okay, thank you, Joan. I want to ask all the speakers to please come down to the front so people can find you to ask any additional questions. And we're going to take, for those online, a 30-minute break. We'll be back exactly on the hour. And coming up, we have southern resident killer whales.
And I have a request as well. If Wendy and Brittany from DFO and Corey are still in the room, please do see me down here. Thank you so much.
By the way, we're still looking for Kate and Ruth to give me their presentations, please. That's Kate Yelly and Ruth Joy.
Philippe? Philippe?
Ladies and gentlemen, Ruth Joy, if you're in the room, Ruth Joy, we are looking for your presentation in the front, please. Ruth Joy.
Okay, welcome back, everybody. We're in the last 90 minutes, and there may be some discussion afterwards. We'll see where the interest lies, but we have another 90 minutes of presentations. And we're going to start off first, before we get to the southern resident killer whales, we're going to be looking at 3 research programs and getting some overviews of what they're about and up to. So our first speaker here is Karina Dracott.
Good afternoon, everyone. My name is Karina Dracott, and I'm the coordinator for the North Coast Cetacean Research Initiative up in Prince Rupert. So, we actually established our office up in Prince Rupert about 4 years ago, and this is a northern extension of the Marine Mammal Research Program and the BC Cetacean Sightings Network. And the idea behind this was to monitor cetacean populations up on the north coast through both field research and citizen science, but also to engage with community through education and outreach. And one of those goals was to increase our sightings for the north coast. And you can see here we've seen a general trend upwards, which is great. And a huge part of that is thanks to one Caitlin Birdsall, which many of you in this audience might know. And she's got her hands a little bit full at the moment. So she's joining me in January of next year. Just a brief overview of a couple of our research initiatives. One is a seasonal and daily patterns of habitat use by harbor porpoise near Prince Rupert. So we know that harbor porpoise are in near-shore coastal ranges, and they actually can have relatively restricted habitat. And within those ranges, there's small areas that are characterized and can be used more frequently by harbor porpoise and are considered important areas, which means that some of this targeted habitat use might make harbor porpoise more vulnerable to localized depletions. And so something we've noticed outside of Prince Rupert at the entrance to the harbor is this pretty interesting aggregation of winter harbor porpoise of groups of up to 50 to 100 harbor porpoise. And you can see here, this is our study site. This is a density effort-corrected map from the Sightings Network database. And we have a pretty clear high abundance in this region. Just to compare, in the summer months, they're obviously using other habitats in nearby areas. So what are we seeing? We're seeing documented high energy harbor porpoise behavior. They're approaching moving vessels, playing in wakes. Sometimes we even see those rooster tails, attempts of mating behavior potentially, and porpoise breaching. So pretty interesting to see. And so what we wanted to do was look at daily and seasonal patterns, potentially impacts with tide, habitat use associated with anthropogenic factors, possibly vessel traffic. This is a pretty busy area, and it's only going to get busier. And we also wanted to look at comparatives to the southern coast. So our methods include using the CPOD, which is a passive acoustic monitoring device, and it's essentially a click train detector. So we're looking for those detections of harbor porpoise, as well as a land-based survey. And we've done that through a citizen science project. They're done on 2-hour periods and 10-minute swaths. And we're recording all vessel traffic as well as porpoise sightings. So what have we found? Preliminary results, we've done about 7 deployments, and we're getting help from the Port of Prince Rupert's Harbor Authority. And we're averaging just over 2.5 hours per day of detection positive minutes during deployment time, which is on average around 75 days. And preliminary look at that data seems to indicate some diurnal and possibly tidal trends, and that in other places around the world we've seen that tide correlation with porpoise feeding. So another thing that's interesting is of our 45 land-based surveys, only 5 of them didn't have porpoise presence. So we're seeing them there all the time at this site, indicating that this could be an important area. Usually we see groups of 2 to 5, and then sometimes some bigger groups. But to date, with the land surveys, we haven't seen those big aggregations. But at least last winter I was out, we saw at least 30 out there. They're definitely present. So we're hoping to complete this time series, hopefully deploy a second CPOD, and continue to look at these correlations and dig into that data. So another thing we're working on is completing our North Coast ID catalog. So this area focuses on Chatham Sound and Work Channel and the eastern part of Dixon Entrance. So that's been going on for 4 years with contributions from our observers in our network as well. And we have 179 unique whales, which is great. And we are also collaborating with this province-wide initiative for an updated humpback whale catalog, which is a pretty big project. Wintering humpback whales. This is something that's also caught our attention in the area. We've seen about, some of our whales, we've seen about 60% that are just present in the summer months. So that's usually about May to September. And then we see about 30% that are just seen in winter. And that's between about November to March. And then we have this kind of 10% that are seen in both, such as this character here, Underbite, and he or she has been seen in January as well in summer months. So the question, we have all these questions around what are humpbacks doing in this area during winter months, and we want to explore habitat use, feeding ecology. We'll start to collect some prey samples and fecal samples this winter to dig into that. So just a brief look here at this map. This is a density sightings map for summer for humpback whales in our area. Huge hotspot up near Work Channel, which is well known for bubble net feeding, as well as a comparative in winter studies. We're still seeing those humpbacks hanging around, so pretty interesting. And then lastly, I'd just like to say that we do have support from DFO's Coastal Environmental Baseline Program, the OPP, and significant contributions from the Port of Prince Rupert and DP World, as well as support from many other partners and funders and supporters in the area. So many thanks to that. That's all.
Any questions?
And if anyone is ever up in Prince Rupert, please come say hi. I'm just based out at the community college there, which is now named Coast Mountain College. So we have our little satellite office there, and we're there all the time.
Thanks very much.
And next up we have Brittany.
No worries. Well, guys, good afternoon. I'm going to give an update on what the Coastal Ocean Research Institute's Marine Mammal Research Program has been up to over the last year. So we started off 2018 organizing 2 scientific workshops on issues that seem to be increasing in BC, one on whale depredation and one on whale entanglement. So we're going to have some summary reports of these workshops that will discuss what discussions had happened in these workshops, as well as what the key findings are. They'll be available on wildwhales.org in early 2019. You've probably all heard Lance give talks about our photogrammetry work in the past. So this project continued on in May. So the team was out photographing the southern residents. Unfortunately, the southern residents did not get the memo and did not show up in the Salish Sea. So we did not get any photographs of them this year. However, the team did photograph 28 individual bags and several different whale species. This is going to be the last field season for Lance and our team in the Salish Sea. So from this point on, our team will be taking over the northern resident component of photogrammetry work, whereas John and Holly will be taking over the southern resident component. So in August, we were out in Telegraph Cove photographing the northern residents. And as I mentioned, we did have a new team, which consisted of Lance, Dylan, and myself. It was quite a successful first year. We photographed 63 individual northern residents, 60% of which we had photographed in 2017. We did notice some pregnant individuals. We did photograph A79, part of the A42s, who was sighted 2 weeks later with the new calf down around Campbell River area. We also noticed a couple of injuries. So we recited A109, who was struck by a ship in early summer. We also noticed a couple other individuals that had injuries that looked to be related to vessel strikes. In addition to photographing northern residents, we photographed 11 bigs, as well as 11 humpback whales. And we also photographed a number of Pacific white-sided dolphins associating with northern residents. So all in all, it was quite a successful field season. Starting in 2019, we're gonna start a new project in the Conservation Genetics Lab. This is going to be led by Carla Crossman, who many of you have seen give presentations in here almost every year. So what she's going to be looking at is epigenetic stress markers in northern and southern resident killer whales. So in case you're not familiar with epigenetics, it's basically a study that's looking at these long periods of stress that could be caused by things like famine and how it affects gene expression. So these changes in genes that are expressed, that's inheritable. So it can get passed down from first, second, and third generations. So what Carla will be doing is she's going to examine how cumulative impact of stress on gene expression is affecting resident killer whales and why one population might be doing better than the other. That's kind of what she's looking to answer. What happened this year with us is we opened up a Victoria office. So this was initially open to help promote our BC Cetacean Sightings Network and get people to increase their sightings through the whale report system that would then get relayed onto the whale report alert system. So this is coordinated by Sarah Patton, who some of you might have already talked with and probably will talk with this whale watching season coming up. Just wanted to let you know that we are doing a Naturalist Night in 2019. So this is an event we hold every other year. We get cetacean researchers to come and talk about current work that's going on. We haven't quite figured out the location and dates exactly yet, but we do have an email list. I had it up on the last break, but come find either Jess or myself to sign up for that event to get emails, or you can email sightings@ocean.org to get on that email list, or if you'd like to present. I just wanted to say a quick thank you to all of our supporters that have helped fund a bunch of our projects this year, and a shout out to all of our loyal adopters from the Wild Killer Whale Adoption Program. The funds that come in from that directly support our lab and field research on wild killer whales. So if you don't know what to get someone for Christmas, you can always get them a Wild Killer Whale Adoption Program. I have brochures if you want one, or you can go to killerwhale.org to learn more. And I'd like to say a special thank you to all of these companies here. I sincerely apologize if I've missed anyone from the list, but all of these guys have helped promote our fundraising program. And I'd also like to say thank you for all of the companies that have given sightings to the BC Cetacean Sightings Network, as again, that gets relayed on to the Whale Report Alert System. So thank you all for supporting us this year, and thanks for listening.
Have any questions? No, thank you, Brittany. And next up we have Dom Tollett.
Thanks, Andrew. I'm going to give a quick update, very quick update on 7 Canadian projects that SMRU Consulting have been doing in the last year or so. SMRU Canada, as is SMRU Consulting, is owned by the University of St Andrews. The first project is talking about comparing the noise effects of commercial ships with whale watch boats, and that does include recreational boats, not just the industry. And just to bear in mind that salmon is the population driver here. We developed a southern resident killer whale noise overlap model. Ruth Joy, our biostatistician, key to that. And the model basically predicted that both, unsurprisingly, both noise sources have effects, but they cause different effects. The larger commercial boats were causing what we call behavioral responses, and the whale watch boats were causing click masking. And together, they had the potential to disturb foraging time up to 20% of a day that whales were in the Salish Sea. That was work with the ECHO program of Port of Vancouver. The next one was also with the Port of Vancouver ECHO program. For the last 2.5 years, we've been monitoring ambient noise at Limekiln on San Juan Island. And we're trying to understand what we see from those data, and we're seeing considerable seasonal and between-year differences in ambient noise levels, particularly in that first decade band, between 10 and 100 hertz. And we're assessing the cause of those differences, whether they're natural from sound speed profiles or wind or flow noise, or whether they're due to boats and large vessels. And this has sort of clear consequences of the need to remove those confounding factors before you look at the benefits of noise reduction actions by the ECHO program in 2017, 2018, where there was a voluntary slowdown of commercial vessels. And Ruth Joy will be talking about that slowdown in a couple of presentations. We've been working with DFO on trying to understand habitat use and foraging areas of southern resident killer whales in the Salish Sea and beyond. We've created for DFO a composite map using the best available data for each sub-region. And the next step is working with UBC Department of Statistics on a synthesis relative use map that also incorporates key environmental correlates. The fourth project is the development of a real-time coastal acoustic buoy we call CAB. And this is for noise level monitoring, noise mitigation, and killer whale detection. At the moment, we're working with Marine Resources Committee of San Juan County to collect noise and killer whale data off a possible boat no-go area off Salmon Bank near San Juan Island. The plan is to use 2 of them for source level measurements in Burrard Inlet, and the aim is also to use them as a real-time mitigation to alert cetacean presence, hopefully to feed into RAS. Okay. The next project is a piece of work we did that subsampled some of the data that Chad described in 2016. And this was to actually do a comparison of the DNA method of assessing prey in the diet of harbour seals using relative red abundance with a biomass reconstruction that incorporated correction factors that account for the digestion of bones. And as you can see on the left, the blue is the DNA results, and the red and yellow results are the biomass reconstruction that we did with correction factors and without correction factors. And I hope you can see basically the 2 techniques matched up very well at these levels of prey proportions, including the percentage of salmon. As you heard earlier, the diet was primarily hake and herring, and the sort of composite of both biomass reconstruction and DNA is clearly the best way to go forward if you want to understand diet of harbour seals. This last project is work we've been doing since 2011 in the Bay of Fundy. There's an area in Minas Passage where they've been deploying tidal turbines to collect, to provide renewable energy. We've been using those C-pods, these click detectors. We've got about 1,200 days of data. And we were interested in the effects of an operating tidal turbine. And in this plot, you can see a probability of detecting a porpoise in 1 day. And the two sites closest to the turbine within 230 meters in the hatches are where it was operating, the solid bars when it wasn't operating for the same time period, and those 2 closest sites showed a significant drop in activity from these C-pod click monitors of about 10% and 30%. And we're moving on to assessing a sonar that was on the turbine to look at nearer interactions. Just draw your attention to a number of publications, one on killer whale habitat use, one on detecting marine mammals in low visibility conditions, one on the diet of stellar sea lions in the Aleutians, and then 2 papers on movement around operating tidal turbines. Lastly, the final project is one we're all involved in. When I was a kid, I had a book that had a picture of the world with a sort of Band-Aid on it. And now I kind of feel like that same book should have the world maybe on an ER cart of some sort. The data is coming in and it's so clear now. We've got declines in wildlife populations that are 60% in the last 44 years. Turtles are down 95%, large fish down 90%. Perhaps most disappointing is a potential loss of all our coral reefs by 2050 if we hit a 2-degree rise in global warming. Ocean acidification is going 100 times faster than any time in the last 20 million years. So we've got a situation that we do need to do more. And I think I'm going to challenge you now to try and consume less. So less meat, less driving, less flying, Just consume less shopping. I'm glad we're here on a Saturday on yeah, exactly, Black Friday, whatever this colour is. Stop shopping so much. Buy what you need, not what you want. We haven't got a second chance here. Thank you.
Anybody any questions? I think we heard your message.
Yes, good.
Thank you, Dom. Very well given. We're now on to what everyone's been waiting for. Oh, this is a great setup for you, isn't it? Come on up. Our speaker here is Caitlin Yaley, and we're now going to be talking about southern resident killer whales and ultimately getting into the potential cull of seals has been proposed. We're going to start first with some basic research into southern and northern resident killer whales.
Thank you, Andrew. Hi everyone, my name is Kate, and I just want to introduce you to a project that kicked off this summer that I'm doing here as a master's student at UBC and with Porpoise Conservation Association. So I'm looking at assessing stress in the southern and northern resident killer whales using their feces. This project is part of a collaborative agreement through Fisheries and Oceans Canada, the Oceans Protection Plan. So the overall goal of this is to contribute to our understanding of the threats facing the southern residents and the health of the population. So we've had a few talks about feces today, but I'm going to talk about how feces can tell you about stress. So in mammals, the adrenal cortex and the thyroid work together to regulate metabolism and respond to all kinds of environmental cues and stressors. So if you follow the diagram down from the top, these glands produce hormones, and in the diagram there it's cortisol is a hormone, into the bloodstream. And those circulate all around the body and produce all kinds of different results to mediate stressors from the environment. Following the diagram down, the hormones make their way into the liver where they go into bile and are excreted in urine and feces. So that's why we can measure these hormones in feces. We're going to focus in on glucocorticoids and triiodithyronine, or T3, it's easier for me to say. And cortisol is a glucocorticoid. So with any kind of environmental stress, including nutritional stress, glucocorticoids typically increase, or the production of them increases. So this has been observed many, many times that chronic stress is often seen as elevated concentrations of glucocorticoids. But on the other hand, chronic stress, and especially related to nutrition, so prolonged periods of malnutrition, are associated with the suppression of the thyroid axis. So this is often seen as depleted concentrations of T3. This is really basic for endocrinologists and physiologists out there, but for the sake of 5 minutes, this is what you need to know. So unlike measuring this in blood, measuring it in feces, and the square brackets, concentration of fecal hormone metabolites, FHM, that's what I'm talking about there, you're going to see it a lot, is relatively non-invasive. It also represents average concentrations of hormones over roughly 24 to 48 hour period in killer whales. So it's a good non-invasive measure of daily stress. Most of us here know that 2 of the threats identified to the southern resident population are lack of prey and vessel disturbance. So if either or both of these are causing stress in the whales, we should see increases in glucocorticoids and decreases in T3 in their feces. Relative to what, though? So some of you are probably thinking, hey, isn't there already a group that's looking at this in the southern residents? You're right. There's a group down in Washington that's been looking at this. So why am I looking at it? That comes back to the issue of a baseline. We have the advantage of looking at it in both populations. So if the southern residents are experiencing more stress than the northern residents, we should be able to see differences in these concentrations in the feces of the 2 populations, with the idea that the northerns might act as a control. Secondly, there's a lot of confounding factors actually when you're looking at hormones. So there's lots of natural daily fluctuations, natural seasonal fluctuations, and a huge one is natural fluctuations dependent on diet. So it's been shown that just accounting for water content doesn't actually account for dietary changes. So I want to investigate if any changes in individual diet from each of the feces samples might be affecting these concentrations. Thirdly, I want to look at the relationship between the concentrations of hormones and the body condition as seen from aerial images through photogrammetry. So how am I doing this? I'm out in the field collecting samples from the southern and northern resident populations in important foraging areas, Juan de Fuca Strait and Johnston Strait, during peak foraging time. So in the summer, over 3 seasons, we just had our first field season. Some of you might be familiar with Tucker and then Dio, the scent sniffing dogs that they have down in Washington. Sadly, I don't have a dog yet, but I do have a drone. So I'm working alongside the Oceanwise photogrammetry team, and you can see just in the distance Scanna and their drone is up there. So we stay a bit further back, and when they see something like that in the water, they let us know, and we zip over and we collect any floating pieces that we can find. Yes, it does float, or some of it does anyways. We process it right on board immediately and get it into a -80 right away. And there's just a nice photo of me surrounded by a bunch of samples on what we like to call a particularly shitty day out in the field. So I know you're all on the edge of your seat, like, okay, what's the answer? Sadly, I don't have anything to tell you yet. My samples are still sitting in the freezer waiting for me. Hopefully I'll get to them this spring. And I'll be looking at concentrations of glucocorticoids T3 and other androgens and estrogens, which can tell you about reproductive status, genotyping those samples to individual animal ID to account for age and sex classes, and getting into the diet analysis or figuring out if lipid content is going to tell us anything. Also, hopefully doing some collaborations and sending some samples away for parasite and microbiome analyses. So the takeaway message from today that I just want to share with you is that feces are really a gold mine of information, or sometimes slightly green or sometimes slightly reddish. And hopefully next year I'll have some more data to show you. Just want to thank Fisheries and Oceans Canada, the Oceans Protection Plan, Oceanwise, and the University of BC, and really amazing field teams that came together fairly last minute this summer and really made everything possible. I had no idea so many people could be so dedicated to collecting feces. Thank you.
Do you have any questions? Okay. It'll be for next year then. Oh, there is one at the very back. There we go.
You just mentioned that you're creating baselines of comparison, or that you have the potential to, between the northern and the southern populations. I just wondered if you plan to collect samples in the northern populations as well.
Oh, we are. Did I not mention that? Sorry. Yeah, I am all summer doing collecting for both the southerns and the northern residents. Yeah. Time or not?
Yeah. Down here. You can sing or recite poetry. Oh, here we go.
So what happens if, let's say, something happens in a northern residence and all of a sudden they're stressed, and you end up showing equal stress in the northern and southern residents?
Great question. It could definitely happen. And you know, the idea of using the northerns as the control, it's not black and white, right? Like there's, oh, I didn't even intend to say that. Certainly, we could see all kinds of different responses, and I'm right at the start, so we're gonna have to think carefully about how we interpret the things that we see.
Okay, thanks very much. And our next speaker is Ruth Joy.
Good afternoon, everyone. So Dom introduced a little blurb about what I'm going to go into a little bit more detail about the voluntary commercial vessel slowdown that happened in 2017. So this was a 61-day slowdown trial that was strongly encouraged, but still was voluntary, with the pilots bringing in commercial vessels through the shipping lanes. And it's a collaborative project with JASCO, who built our noise layers for the model, and then the program directors, Krista and Orla at ECHO program. So why was the slowdown initiated? I guess I'm the first one today to say that there's not 75 but 74 individual southern resident killer whales. There's been a lot of attention drawn towards them because of their declining population status. And every time I build these simulations, I have to keep pulling another southern southern resident out of the simulation. So unfortunately, southern residents aren't doing well, and this is part of trying to figure out how we can change the way we do business to benefit the southern residents in our Salish sea waters. And so what was the trial? It was there's another one in 2018, which I'm not presenting today, but 2017 data was to 2-month voluntary slowdown. And so these commercial vessels were asked to slow down to 11 knots through a 16 nautical mile section of water off of the west side of San Juan Island. And on the right, you can see the area, and I think I have a slide just coming up that might show it a bit better. And the key question to this trial was, does a vessel slow down, reduce the ambient noise that could potentially benefit the southern resident killer whales foraging in this area? And so the results of this are a mixture of the simulation and the acoustic results. And so just briefly run through what we did, which is we built for each day 1-minute noise files, which would tell us how noisy this region of interest was off the west side of San Juan Island. And based on the number of vessels, the speed of the vessels, and the vessel's source level, we would then estimate what the impact of ships, this many ships going at this speed, would have on the number of whales that were allowed to change over each month based on the data that we had, also based on the locations, so the hot spots as those change over time, and where on the map the whales were located. And so from these metrics of the received level of the whales, we were able to estimate, based on a dose response curve, what the expected response based on another set of data that came from Southall's work, what the expected time for a whale would be where they would stop foraging and allow the ship to pass and then resume foraging. And so there was a couple of different kinds of responses based on low frequency noise, which was thought to be in their either in their communication range, or else the high frequency, which they use for foraging and echolocating, and those were the high frequency noise layers. And so the results of the trial were that 60% of the commercial pilots tried to comply with the voluntary slowdown request, and the ships that did comply had a significant reduction in their noise, and noise, of course, is on an exponential scale. So I can't actually tell you what 2.8 decibels means, but it is a significant reduction, and that's per knot of slowdown. And so some of these vessels would usually transit the area at 18 knots, and now they're being reduced down to less than 12. Ideally 11 knots. So it's a real reduction in noise in this area of hotspot for southern resident killer whales. So the results of the simulation suggest that on an average traffic day, there should be about a 10 or more percent reduction in the noise experienced by the southern resident killer whale. So that means in the amount of cessation of foraging based on that dose response. And so that the amount of time that the killer whale is expected to stop feeding in response to the ship's noise being above a certain threshold that would elicit a response, that is brought down 11% or 22% over the trial duration. And so concluding very quickly, seems that the commercial ship slowdowns in Harrow Strait were effective at decreasing the ambient noise levels, despite, of course, when you're going slower, it takes longer, but you're a lot quieter. And particularly at those low frequency ranges that commercial vessels are sort of dominate our ambient noise spectrum. And it seems, at least from the simulation, that those that translates to a real reduction in the impact that those commercial vessels have on southern resident killer whales. Thank you.
Do you have any questions? Okay, we got one at the very back.
Well, given that you've only got 60% compliance with the voluntary slowdown request, is there any prospect of a mandatory slowdown? Perhaps it would have to be a transboundary agreement, given that this is right on along the border between Canada and
yeah, I think right now we're looking at the feasibility and the safety issues of whether or not it's even possible, and where we might be successful in making something like that work. So we're at the early stages of moving in that direction, but certainly it's been tried on the east coast in the northern right whale.
Yes, yes.
Yeah.
Another possibility would be perhaps some kind of a carrot. Some kind of a carrot as opposed to the stick. So
yeah, there was a carrot.
Kind of like reduced port fees for vessels that were known to slow down on the way in.
Yeah, certainly the ECHO program has thought of all that, and I think there was a small carrot for complying or for volunteering on this.
Great, thanks.
Any other questions? Ruth, I've got one for you, which is just this trade-off between a vessel going fast and making a lot of noise, and a vessel goes slower, makes less noise, but for a longer period of time. So this trade-off between reducing the total sound or the duration. Did you consider that?
Yeah. So the thing with the dose response is that it's a nonlinear relationship. So the louder you are, the more likely you are to elicit that response, but it's much higher at the peak noises that a very fast-moving vessel emits. So so bringing the noise level down puts it into that part of the dose response which is less likely to elicit a behavioral response from a southern resident killer whale. So a slower vessel is less disturbing because of that relationship.
Okay, thanks very much, Ruth. And our next speaker is Philippe Robert.
Hello, can everyone hear me? Yes, hi. I'd like to say thank you for everyone who came out and communicated their science today, and I'm going to be talking about that a little bit. The observant ones among you have realized I'll be showing a video, so I'm going to get to that in just a second. But a bit of backstory. I was there in third year, and I was leafing through a research paper, and I just thought, there's nothing I love more than reading peer-reviewed research articles, but there's got to be a middle ground. There's got to be something. I felt like there was a bit of a disconnect between the research that is published in those peer-reviewed research journals and then just kind of what the general public sees in their day-to-day reading. And so I wanted to find, is there another way that we can do this? And I approached Andrew with a really rough idea, and I was like, I want to do research for you, A. 2, I can make a video. If we can spin that in, that would be great. Obviously, Andrew had the answer, as he always does. And I ended up doing a bit of a research project on how, if you were trying to, how would you make a viral video on YouTube specifically for communicating science? So I have all the answers. So using using a bit of stats and just leafing through, there's been previous studies on this. We found that your best bet is to make it between 2 and 10 minutes. Video style should actually include a narrator. Should have a pretty quick pace of delivery, so just how fast the words are said, because with videos, people can always pause and rewind if they don't understand a segment. And then it should also, you should try and have it engage the viewers, the audience, and have them kind of participate in it. So that being said, I ended up there was a job that opened up in the museum where I now make videos about the research. So now it's like I need to prove that my research was right and that I can actually do this. And so I'm going to show you guys the first research video that we made. It's on YouTube. Sorry, audio visual people, if this doesn't work. It should. And yeah, so this is about a project on southern resident killer whales. So let's see if this works.
Southern resident killer whales are endangered, and we're trying to find out if it's because they can't get enough salmon to eat.
Our study uses hydroacoustic technologies to look at beneath the surface of the ocean, trying to figure out how many fish there are, what kind of fish there are, and where they are. こんにちは、佐藤芽衣です。私は今、ブリティッシュコロンビア大学でオルカとサケの生態系について調べています。Southern resident killer whales are very picky on what they feed on. So there are 5 different species of salmon in British Columbia, and they feed on mostly Chinook salmon. That's the most energy rich and the largest among all the species. So what we are trying to do is to figure out whether there is enough Chinook salmon for southern resident killer whales to feed.
Part of our study is trying to compare the declining southern resident population with the increasing northern residents. When we look at their body conditions, the southern residents are thinner on average compared to the northern residents. And that's our strongest clue to suggest that the problem is food availability. They're simply not getting enough to eat.
So our typical day starts 4 in the morning. We wake up and quickly eat the breakfast and pack up the bound with the gear and then drive to the marina. And so when we get to the marina, we load all our gear to the small vessel and then leave the marina by 6 a.m. Once we get to the site, we deploy the CTD, which measures conductivity, temperature, and pressure, providing us some environmental parameters where the Chinook salmons are staying. Then we use the multi-frequency echo sounders, which have 4 frequencies from 38 to 200 kilohertz. By having multiple frequencies, we can separate fish from zooplankton or perhaps a different species of the fish.
So we're using technology to find fish. In fact, we're using the same technology that killer whales have used forever. They too send out sound and it bounces off the prey back to them and they get it in their melon. And from that, they can visualize what's there. And they're finely tuned to identify Chinook salmon in particular and go for them.
Killer whales can sweep across the frequencies. So I'm pretty sure that they're getting way more information than we have. So that's why probably they can detect the Chinook from other salmon. We are using a similar technology, but not quite yet as sophisticated as a killer whale is using. And also we need a small vessel to deploy it, and we also need to validate with some more sport fishing techniques.
When we look at the surface, it almost looks like a desert, and it's hard for us to imagine how rich these waters are. And yet, if you look at the surface, you see the seabirds that are feeding. You see the seals, the sea lions, the white-sided dolphins, the humpback whales. This is such a rich ocean. And it's been therefore so puzzling when we look at the southern residents because everybody else is doing so well. The southern residents are an outlier. Why can't they make it when all the other species that are feasting on all this prey that are in the ocean are doing so well? Why can't the southern resident killer whales do it as well? And that's been so puzzling to us, and we hope to get to the bottom of it. When we're looking at a problem as serious as why are southern resident killer whales declining, you think, well, maybe a killer whale specialist could answer that question themselves. But in fact, we need more than just a killer whale biologist. We need people who understand acoustics, who understand how to look for fish underwater. We need to work with nutritionists. We need to work with laboratories that can analyze the fish. It takes a whole team to come together to solve this problem.
So I hope you guys enjoyed that, and I just wanted to put in a little something. So going back to that audience engagement, the last point here, UBC posted this, as was the goal, and it did generate some conversation, which I think is a really cool thing about using videos to communicate your research. So we had different reactions. So we had some positive ones like, Keep it up, UBC. So glad this is a priority to some scientists. We had some negative ones too, called the sea lions and maybe all the seals, which I know a lot of people have been talking against that today. But it's good because it encourages this conversation, and so it gives the opportunity for people to teach others, you know, compared to what humans take, seals and sea lions take nothing. And then other ideas that are different in themselves. And it's cool because I've never had a research paper that got 34,000 downloads. Although some of you might have. So for me, this is a cool way. And I know that if Despacito can get like 3 billion, then, you know, there's room here. Possibilities are endless. So yeah, lots of reactions and lots of shares, which is the coolest part about this. Yeah, that's everything I have. Any questions?
Maybe just one for you is you're now also working with other researchers, working on everything from termites to other things. And how do you find trying to get them to communicate their challenges?
No. I mean, that's definitely always a thing, right? You have different levels of any topic can be made extremely complex, as is the case with whales or termites, protists, whatever, you name it. But I also think that in a way that any topic can also be simplified to some extent. Richard Feynman was a big proponent of that. So I try and keep it informative, and you know, it takes a lot of trust. Trust is one of the main things when you're working with someone, to get them to say it in a way that is accurate yet understandable. That's been one of the main things we're working towards.
Great.
Yeah.
Thanks so much, Phil.
Yeah.
Next, I'd like to introduce May Sato.
Thank you, Andrew, and thank you for the wonderful video, Phil. I really enjoyed having you on the cruise this summer. So as you see from the field's video, I'm looking at the prey field of killer whales using the sonar technologies. And we are specifically trying to answer the question about whether there are enough prey for the endangered southern resident killer whales. We completed our first field season this summer in August, looking at the prey habitat of southern resident killer whales in Juan de Fuca Strait and compare those of the northern residents in Johnston Strait to see whether there is any difference. So what do I mean by enough prey for the killer whales? There are several factors to measure the prey habitat. One is abundance, whether there are enough fish or only a few of them. The second is distributions, whether they are located near the surface or near the deep waters, which has a consequence for the accessibility for their predators. And the third is behavior, whether the fish is changing their behavior relative to the presence of killer whales nearby. So to measure these parameters of the prey habitat, I use the sonar technologies as a remote sensing tools. And today's talk, most of them use acoustics in terms of more like a listening device, like a passive acoustics, but here we use as active acoustics. So I would like to explain briefly how it works. So there's ships on the surface and fish schools in the water column, and I'm here presenting two examples for comparison. One is lower frequency, 38 kilohertz, and the second one is higher frequency, 120 kilohertz. When the ship's echo sounder releases the sound and reflect back from the fish schools, there's an echo return, which is we measure the strength of the echo return, which depends on the size of the fish and also the abundance of the fish. And this response changes depending on the animal species. In case of the zooplankton aggregations, we have much stronger return on the higher frequencies than lower frequencies. Using this difference in frequency response, we can separate fish from zooplankton and sometimes fish species. So I'm going to show you an example of the acoustic data we collected this summer. X-axis is the distance over 600 meters where the ship drives along the transect line, and y-axis is the depth for 45 meters. And color shows the density of the animals. So warmer the color is, higher the density of the animals in the water column. So you can see that the bottom shows up as a gray, and then the small echo returns near the bottom is the coming from the individual target, like individual single fish. In this particular case, it's verified as a Chinook salmon using the sport fishing techniques. Another example is the big red ball, which is accumulation of the Pacific herring, which is verified using the mid-water trawling. So using this different type of morphologies, we separate individual fish from the schooling fish, and I'm going to focus today's results on the individual targets, including Chinook salmon and then other fish, but looks like an individual target fish showing up as acoustics record. So how many fish are there in Juan de Fuca Strait? This is a 1-week study in August this summer. Here I plotted y-axis as the density of the single targets, which basically means the density of the fish in the water column. And x-axis is, on the left, is shallower than 120-meter depth, and to your right is deeper water column. So at the shallower depths, there are about 50 to 100 individual per 1,000 meter cube, or sometimes more than 300. At the deeper depths, it has much significantly fewer fish, about less than 50. So it suggests that there are fewer fish in the deeper water. How about their sizes? How big were they? So now I plotted the target strength on the y-axis. So this basically means that the strength of the echo return from the fish. So as the target strength values become larger, the fish size become larger. So for the shallower depths, we have about minus 47 decibel, and at the deeper depths, it's about minus 37 decibels. So it's about 10 dB difference in the size. So this suggests that there's significantly larger fish in the deeper water. So in this case, for the killer whales, perhaps that deeper water may be more important habitat for them to catch the bigger prey, even though there are only a few individuals over there, because they can only capture one at a time anyway. So this talk, I have been focusing on the data from southern resident killer whales habitat collected in the Juan de Fuca Strait. We are currently working on the data analysis for the northern resident killer whales in Johnston Strait to compare whether the prey habitat characteristics is different from the southern resident killer whales, so that we can fully answer this question soon. Many people help our field surveys, from the design to the putting together all the equipment, and then on the ship-based surveys this summer. And I would like to thank the DFO for funding, Sport Fishing Institute of British Columbia, Poncho Fishing Charters, and Pacific Angler for their expertise to catch the Chinook salmon using the fishing techniques. And thank you for listening.
Do we have any questions? Question in the middle.
What made you choose that? What made you choose that section of the Strait of Juan de Fuca versus other areas like Harrow Strait or the banks like Constance, Hine, Salmon Bank, or even the Strait of Georgia?
Yes, we originally tried to cover all the critical habitats of the southern resident killer whales, but the limitation was the ship time. So we only had 1 week to cover the southern resident killer whale habitat. So we had to make the decision. And we wanted to compare with the northern resident killer whale habitat. So Juan de Fuca Strait is pretty similar physical oceanography environment compared to the Johnston Strait. So that makes it easy to compare our results as a first step, but we hope to expand our study region next year.
Question over here. .
So fish for schooling behavior will change with tidal cycles throughout the day as well as throughout a lunar cycle. Did you account for that in your survey design, or was it just transects in one area, or were you doing circles in certain areas to account for tidal changes that would affect fish behavior and where they're located in the water column?
Yeah, tidal cycle, I haven't get to that level yet, but then we plan to analyze the tidal cycles for the analysis in the future. But lunar cycles, because of the 1 week study period, it's probably difficult to address for these studies, but we plan to, we hope we are putting together a proposal to put the moorings for the acoustics for the long-term monitoring in the future. So if that happens in the future, we can answering those questions.
Are you going to correlate your Hi, I'm over here. Are you going to correlate your results at all with experience from commercial fishermen or traditional ecological knowledge from First Nations?
Yeah, we hope to. We already start talking to the commercial, to the actually sport fishing guides this summer to help for them to get the understanding of where actually we should go look for the Chinook salmon, where should be the targets for our surveys, and they're very helpful to incorporate. Very helpful to provide their knowledge so that we actually change our survey design based on what they told us.
And are you looking at specific stocks of Chinook in terms of which ones are specifically being used by southern residents?
No, at this point, we are just looking at that. We cannot separate the stock of the Chinook from the acoustic data set for sure. So we are looking at the size and more general patterns at this point.
Maybe I can ask you one last one. I think a lot of people will want to know, how does this compare to Strait of Georgia? In the end, you're comparing the southerns to the northerns. Where are you with that analysis, and when do you expect to have your results?
You mean Strait of Georgia?
No, I'm sorry, I mean Johnson Strait. Just to give a sense. I kind of know the answer, but I know that there's a lot of expectations since everything comes back to food, it seems, and your study is directly trying to get at that. And so you're showing us a little piece of the data. What's coming up?
Well, I'm working on the northern resident data right now, and I'm hoping to finish the preliminary data analysis by March. But then we are hoping to compare this summer data to the winter data, which will be going out in March 2019, so that I can give you a little bit more of bigger picture next year of this symposium.
Thank you, Meg. And our next speaker is Lance Barrett Leonard.
Thank you. Gosh, I haven't done a harbor seal talk that has anything to do with harbor seals for a good long time. I was just thinking, I was reflecting during the previous talks that exactly 30 years ago, I was working with Graham collecting harbor seal scats. I didn't want to talk to you about it without mentioning scats. And working with Graham and Peter Lesiak on a diet study of harbor seals. I've since moved on to work mostly on killer whales. This is actually a very easy talk. Andrew invited me to have a few extra minutes, which is fabulous, but there were so many talks that have set the stage for this that I think I'm done. I'm going to sit down. I think Strawn and Chad's talks were very helpful, and Zach and David and Simon. Thank you, everybody, for paving the way. I don't need to do this because we've done it already. The current population size is 74 animals for southern resident killer whales, as far as we know. It was at the end of September. And the key threats are outlined here, and I think well understood by this group. The single-minded dietary preference of resident killer whales for salmon is one of the things that made me so interested in this species many years ago. This focus on Chinook has been described already. They do take chum salmon as well, particularly in the fall months, and coho. This is probably coho here, when coho are around, but coho are relatively small. So there's no question, really. I think that they're very dependent on Chinook. This is a figure from a paper that John and Graham and other colleagues did in 2009, and it was very game-changing in a way, this one, because it established for the first time that killer whales, resident killer whales at least, are up against a food ceiling, at least in some years. They've reached carrying capacity. You know, we kind of take that for granted now, but before that, we didn't have a clue. We knew that resident killer whale numbers, northern residents, had been going up for years and years and years. Transits had been bouncing around. We didn't really know if they were anywhere close to being at carrying capacity. So we've all changed our thinking, and it's been, you know, I think that's one of the most important single developments really in the last 10 years in terms of understanding these populations. As has been mentioned before, I've been involved in a photogrammetry study for a number of years now, where we use a drone to take high-quality aerial images of killer whales, and then working with John and Holly, Dr. John Durbin and Holly Fehrenbach, and we're still collaborating very closely on the analysis. We're all too busy to spend 3 months a year in the field, so we split up our field efforts a bit. We'll still be comparing the northern and southern resident killer whale population body conditions every winter. On the left side of your screen here are a couple of southern residents and I want you to, this is J28 and calf, and I want you to pay attention to the size of that calf. It was born in 2015. On the other side, we have A75, a resident female, and her calf. Those calves are born in the same year. You can see a tremendous difference, not only in the body condition. Look at the southern resident side. You can see how skinny she is. We don't need to do any measurements to see that she's skinnier. We do very complex set of measurements to capture the shape reliably. But she's thin, and no question about it. Look at her caudal peduncle right beside the head. And then A75 on the other side is fat and has that rotund calf with her. And this is something that we've seen, this difference between northern residents and southern residents, something we've seen pretty consistently. We began the study in 2014. This is a report of an independent science panel that attended a scientific workshop on southern resident killer whale health a couple of years ago, March 2017 actually, this one. Francis Gullen, Craig Mack, and Michael Moore did this little report, and they looked at the evidence, the data that were presented to them at this meeting, and included a lot of the photogrammetry data, and agreed that with our assessment, there was a panel of vets, Marty was there at this meeting, the vets generally agreed with the biologists, very unusual, that the killer whales really, the southern residents really were in poor condition and growing slowly. And this group concluded, as we had surmised, that this consistently poor condition is likely caused by prey limitation, compounded by things like noise and disturbance and contaminants, and possibly contaminants at least. So the reason I'm doing this talk today is because, you know, as somebody who's been in the killer whale game for a while and being particularly interested in body condition and changes in body condition over time, I'm getting asked a lot, and I know some of other people here are too, about seal calls. You know, are seals a good way to save the southern resident killer whales? You know, seals eat Chinook. Surely if we kill a bunch of seals, we'll have more Chinook salmon, and southern residents will be better off. So I just thought, gosh, I'm tired of answering the question. So in my own way, so here I am, and I'll say it, try and get it out all at once. Of course, predator calls are always controversial, and there's a lot of emotion. We all have, you know, all of us in this room, I think most people generally have strong opinions about when and whether culls should ever be performed, and what the probability of success is. Do we cull wolves to save caribou? Well, there's very, very divided opinions about these things. So I thought it'd be helpful to do a little matrix, a little table of. There are many, many complicated ways, of course, in which predator-prey interactions can be very complicated, mediated through third parties, through additional prey, additional predators. Most predators are, even the specialist predators are usually not entirely specialists. These things are complicated. So when would we expect a cull to work? And when we expect them not to work? Culls do work sometimes in some cases. It's not correct to say that they never ever work. They fail when they benefit the prey's, or they can fail when they benefit the prey's competitors. You take a predator out, your prey species is expected to do better and suffer less mortality anyway. But if its competitors, if it's living in a competitive world, its competitors do better, it may not help it at all. They can fail, culls can fail when they benefit other predator species. So if you take one predator out, another one compensates by moving in, and you're no further ahead. They can fail when they harm the predator's predator, and this is kind of an important one. If you've got a medium-sized fish that's struggling, you take out its predator, a large fish. Sorry, if you take out a medium-sized predator, rather, fish species, say, to save a forage fish, a very small fish, that if there's a specialist predator for that species, it's going to decline. It doesn't have any prey anymore. You've killed them all, and so you have to become a serial culler. Valeria gave me that term earlier on. I thought it was a good one, because then you're responsible for managing the population. You can't step back, or it's difficult to step back. Culls don't work very well when prey are bottom-up regulated, when really it's not predators that are controlling the population size anyway. And this is very often the case. And so generally they don't work as well when the food web is complex. They do work when the opposite of most of these things, when a cull doesn't benefit the prey's competitors or doesn't benefit other predator species and don't harm the species predators and so on. And generally they're more likely to work, of course, when prey populations are limited by top-down forces, by predators in general. Excuse me. And so they work generally, if they work at all, they're much more likely to work when you have very specialist predators and simple food webs. And I think you have to also be mindful of the fact that culls can have very positive short-term effects, but not necessarily long-term effects. Things can stabilize, compensatory factors can take place. So this is just basic, sort of predator-prey theory 101. With seal culls help conserve Chinook populations and thereby benefit southern resident killer whales. So if we look at the same matrix, we can see, well, it kind of looks like on the failure side, a lot of the species that seals eat, and as you've seen today, a very small percentage of their diet is actually salmon, and even a smaller percent is Chinook salmon. Seals are taking a lot of forage fish of different species, and some of those, including herring, by the way, are competitors of Chinook smolts in particular when Chinook are young. So take out the seals, more competition for young fish. And when is the most critical period for salmon survival generally and salmon conservation? Early marine survival is key, right? So this is when fish come out of the rivers, the smolts come out of the rivers, they're hungry, they've got to eat, they don't have much time. And competition matters. These seal culls would benefit predator species, certainly like hake, for example, a big salmon smolt predator. This is something we were talking about 30 years ago, wasn't it, Graham? Nothing particularly new there. They would harm, seal culls would harm the predator's predator, in this case, big killer whales. Without a doubt, we've seen these big increases. Joan's talk was super helpful, I think, of the presence of big killer whales in the Baltic Sea ecosystem. And why are they there? Well, we saw Strawn's talk and maps there showing harbor seal distributions. To a great extent, they're almost certainly there because of harbor seals. Take out the harbor seals and big killer whales go away. And so this is when you become a serial culler. Are prey populations bottom-up or top-down limited? In the case of Chinook, it probably depends at different times in their life cycle. So I'd sort of put this one in the middle, I think. We could talk about it more if we had more time. And the food webs, these marine food webs are very complex, and seals are certainly generalist predators, as we've seen. So really, it's not looking great for culls, I'm afraid. Much as I love the idea of being able to go out and solve the problem by squeezing a trigger, because I'm Canadian, that's how we do things sometimes. But I genuinely don't think it would work. It would be an experiment that would be extremely distracting. Right now, we have a government that's motivated to try and conserve southern resident killer whales, spending money for once. It's starting to do the right things. I think the fisheries closures, sport fishing closures that DFO brought in last year were courageous. I didn't expect that would ever go through. And constantly focusing on harbor seal culls and whether that's going to save is just wasting our time. And then what about big killer whales? Well, their most important prey species, as we've seen earlier, are seals, the single most important one. The population of big killer whales is not, big killer whales are still at risk. So they're still listed as threatened. They're recovering, but they're listed as threatened. So really, do we take the prey species of a threatened species and annihilate it? I don't know. I don't think that would pass the red face test. The use of the Salish Sea by transients has increased greatly, as I mentioned, and that's, as I said, probably in response to seals. This isn't really anything to do with biology, but even from an economic point of view, you've got a big whale watching industry that's spending a lot more time watching transient killer whales, or big killer whales, than it is watching residents now, as we've also seen. If I was a whale watch operator, I would not want to see a harbor seal call, for various reasons, including self-interest. And then really, I think it's very clear that big killer whales, this increase in big killer whales that we've seen over the years is really very likely to drive seal numbers lower over time. This is a photo of a transient killer whale carrying a harbor seal. What's been interesting with the photogrammetry study, by the way, is you get because of this different perspective, seeing the animals from the air. I love Sarah's photos of bowheads in the same way. It was very interesting. You see things a little differently. And one thing that we've seen is when transient killer whales are foraging around harbor seal haulouts, it's really quite common for one or more of the group to be carrying a seal in its mouth as they're looking for more. So we see them swimming around, looking under rocks, looking at, can't eat another seal right now, but maybe later. They're really effective seal predators, so there is a call going on. You know, even if you believe in calls, these guys are doing it for us. So did I miss anything? I think that's about all I have to say on this issue, but very happy to take questions. And boy, that was a lot faster than I expected. Thank you.
Do you have any questions? And we got a few.
Nope. All good? Great.
Lance, this is Indy here.
Hi, Indy, wherever you are in the lights.
About calling the seal population, what about if you, I won't want to say this, but I have to say it, close down the Marine Mammal Rescue Center, that way there won't be seals rescued. And
well, you know, it's interesting. Yes, should be. Yeah, I think we should close it down, Indy, Marty. Yeah, sorry. Yeah, yes, I guess I should have mentioned that I do work for the Oceanwise, ultimately. I work for the Coastal Ocean Research Institute, which is part of Oceanwise, which is based at the Vancouver Aquarium, and we do have a marine mammal rescue and rehab program. I don't think that the seals that we release there are really a drop in the bucket as far as the total population is concerned. I think it's a great humanitarian sort of exercise. I think it's great for developing and maintaining and training veterinary animal care staff. So if we have you know, over 300 transients now in British Columbia, let's say 150 of them a day are in BC at any given day, a bunch of the others are somewhere else, say that their diet's half harbor seals, that adds up to about 30,000 harbor seals a year that they're eating. And so we release, what, 120 or something, Marty? So we don't even feed them. We don't even feed them for a day. I think we need to augment our seal production and feed more transients. That's my take on it. But, yes.
It's for the online.
How much do the escapements from salmon farms influence the population of seals?
Well, that was a really interesting finding that was presented earlier by Chad of that Atlantic salmon in the diet of harbor seals. I can't answer that, but higher than I thought is probably the best answer. What do you think, Chad?
I thought it would be zero. Very interesting finding. The only source of Atlantic salmon. They're finding it.
And for the benefit of the camera, Chad agreed. Essentially. Larger than we thought.
Other questions? One I can see at the very back.
Oh.
One over there. Two more.
Okay. I was just wondering if you had any thoughts to whether there was validation in using like deterrent methods to maybe remove seals from certain areas that are important for smolts and things like that.
Yeah, that's a really good question. I do think there can be in certain cases. I mean, one thing that I skipped over in my chart, because in the interest of time, was, you know, that you can, the kinds of culls that I'm hearing people proposing a very broad scale culls of, you know, thousands of animals. These kind of surgical removals where you say, okay, here's a particular, you know, highly endangered population of Chinook salmon. We only have 5 coming back. We've degraded the environment so the fish don't have any refugia anymore as they come back. The puntledge would be a great case of that. In those cases, there may be times when you just have to say, okay, we've got to do something about these seals for a while and remove them or haze them or cull them, you know, do something. So I wouldn't say I'm religious that these things could and should never be done. But as a broad scale, will that save the southern residents? No, it might save, in these very extreme and unusual cases, a specific run of salmon and give it a chance to recover.
Just with a couple things. First, how likely is the cull to actually take place? And the second part is, if there is a cull, we all reacted when we saw the bullet hole in the sea line. I think there's going to be a lot of animals that are, that they won't be killed right away, and a lot of painful deaths.
You know, it's a good question. I don't have any more validity. My opinion has no more validity on those than anybody else in the room, I think. But you asked me, so my personal opinion is I think it's really unlikely that the culls will actually take place. This is supernatural BC. You know, it would be a tourist disaster. It would be a very unusual, you know, controversial measure that I just can't see happening. And so my major concern is just that. I testified, as Dave Bain is somewhere in the audience, as did Dave a few weeks ago, to the Standing Committee of the House on Fisheries and Oceans on southern resident killer whale conservation, and half the questions were about seal culls. So it's at a time when we're making some real progress in coming up with solutions, and you've seen a bunch of the talks here about this. We're going back 50 years into and spending time discussing something that we're probably never going to do, and wouldn't work anyway. So that's my main concern, I guess.
Just wondering, given how it seems like a small proportion of the seal's diet is actually the salmon, and how the heron are also apparently taking some of the younger fish. Has anybody considered possibly protecting some of those particular sections of streams where the young fish are traveling through from access to herons? I'm not asking for like a cull on herons either, but protection of some of the habitat, especially in low water seasons, to make it more of them to get through.
That's a good question. Again, it's not my area of specialization at all, but I do know that there are proposals and some funding, at least one funded project, to try to increase the complexity of. I'm sure this is going on riparian habitats as well. I just don't know much about that. But in estuaries and near estuary areas, when the smolt come out of the river. I mean, the only thing that ever can keep a predator-prey system stable is when the prey have refugia, places to hide. They just never work otherwise. So if you increase the complexity, if you replant coastal vegetation, take away hard shorelines where the fish have no place to hide, then you can do a lot to increase that early marine life history survival period. So there is work being done in that area.
Thank you very much, Lance.
Yeah, you're welcome.
What's that? Oh, mine should be in there.
Okay, it's right there. Yeah.
If 20 years ago somebody had said to me, at the 26th annual BC Marine Mammal Symposium, Lance will speak about seals and you will speak about killer whales, you're crazy. And here we are multitasking. And I get the same questions that Lance gets. And we're working from similar databases and addressing a very wide and diverse community of people. May talked about some of the research we're doing in terms of trying to assess the
abundance and distribution of Chinook salmon to compare southerns to northerns. And in that process, we held, I think it was a half dozen workshops. We met with whale watching company operators to give us a sense of how they understood the behavior of the whales, where they moved, how they traveled. We met with sport fishing guides. We had small workshops. We arrived with these laminated maps, and we gave them colored markers to show us the movement of the fish. It totally changed our experimental design. But we also got a sense of the differences between the sport fishing guides' perceptions of where whales are finding fish, and then finding differences in terms of where the whale watching companies were telling us. And it's getting into the deep water versus shallow and the restrictions that some of the sport fishing industry has in terms of where they can set their gear. But it had a big effect on us. But during one of those meetings, one of the guys said to me, "How do we get here?" And it just like this whole firestorm has taken over, and there's all these management regulations that are coming in. Closed fishing, restrictions on numbers, now the potential to restrict all whale watching, certainly coming perhaps from the United States. So that's what I want to address, and it pushed me to do a little bit of research. But before that, I just want to talk a little bit about numbers and things, because what I find is I think if I ask everybody in this room, and I bet if you ask your friends outside of this room, they can all tell you how many killer whales are there. They'll say there are just 74. Or if they didn't pick up the latest newspaper, they may say they're just 75 or just 76. But they're all very much in tune. And people are quite horrified by this. And yet when you ask them, well, like, how many do you think there should be? And maybe some of you tried that, but you'll get answers of, oh, I don't know, 500, 1,000. And then someone will finally say, well, like, how many were there? And it's true that not that many people have seen the data. Now, the people working on killer whales, they've seen the data, and they've known it for a long time, but most other people haven't. This is data that the Center for Whale Research put together, and the early source starts from 1960, and it has a reconstruction of animals that were removed for the aquarium industry. But what you can see in here is that, you know, since in this time, the population has experienced 4 declines. Now, the numbers do hide the fact that the effective population size in terms of numbers of mature animals and breeders, in terms of sex ratios, they're hidden by this. And the future is very bleak for this population. The question then comes up, you know, what does recovery look like? And I can't tell you how many meetings I've been to where we're going to put in management actions because we want them to recover. And everything's about having them recover. And so the question is, well, what do you want them to recover to? And so right now we've got 74. And without showing the data, you say to somebody, would you like them back to how many were there in 1960? Before there was a threat from tankers and all the noise and everything else, they go, yeah, yeah. And you show them, well, you know, 78. So what are we working for? The fishing restrictions that have been put in place in BC, they'll never be lifted. If whale watching is closed in the moratorium that's proposed by the governors of Washington and Oregon, it'll never be lifted. These will all be here forever because there's no criteria for recovery. What are we working for? And I think this is something that needs to be thought about. We just can't say, or those in charge of the regulation just can't say we want them to recover. What does that mean? Is to get them back to the 78 animals. So I think it's a question of coming up with criteria. It's important that people understand why are they endangered in the first place. And it is due to the simple fact that the population is so small. They have always been endangered. They will always be endangered. They're never coming off the list. So clearly we can't work towards recovery in the sense of having them go to threaten and then not at risk. They're always going to be endangered. So that's not helpful, where it is for species that are much more abundant to turn things around. And so I think that, and it probably should come from the community of people that specialize in killer whales, to really propose some criteria, because without that, there's no hope of getting buy-in from any of the groups that are being regulated. Everybody needs to work together for a common goal to achieve something, but saying we want them to recover, recovery is never going to happen because it's such a vague concept. particularly with many of the people saying that have never seen the numbers. So do you want them back to the 80 whales that were present in 1979, the all-time high of 98? Because it appears that they haven't numbered more than 100 for over a century. Do you want them at the long-term average of 83? Or do you want to keep them above 80? I don't know what the right answer is, but I think a combination of working with people that do the modeling and probability analysis and other things, I think we could come up with some criteria that would be very useful. Maybe it's we want to focus on reproductive females. Do we need 15, 20, or 25? We should look at that going back into the past to see what has sustained it to this point. Or maybe we just want to keep them all looking fat and healthy. Whatever it is, we need that, and without that, then I really worry about the regulations because they're being put in place and I don't think they can ever come off unless someone is to push a lawsuit or something else, which is a common way in the US. You do use litigation to change management actions. And I think if we come up with criteria, you'll find buy-in and people all work to a common goal. And I just want to make two other points. One is, and I made this point in the video, that I see the southern residents as being this outlier. Something's really different. And yet the narrative we have in British Columbia is there's something wrong with our salmon in BC. And yes, the Chinook and Coho are not as abundant. They're in poor shape. Some of the Chinook populations will be declared endangered. Things are coming. But at the same time, if you look at the northern residents, and these are really the true BC whales, they're doing great. They've been increasing. There's over 300. And so, well, the public is told that there's no salmon left to eat, maybe not quite that blunt that way, but always in the context of the southern residents. We have to ask the question, well, how come the northerns can make a go of it if there really isn't enough fish for the southerns? And that brings me then to looking at the range of the southern resident killer whales. And this is one thing that has really puzzled me. The discussion is framed within a in my backyard problem. This is a made in BC problem, and we tend not to think about the fact that they've got the biggest range of all the resident populations, at least in terms of the northern residents. And while it's maybe unfair to link in Haida Gwaii, but I think we have to focus on further south, particularly Oregon and California. And by some accounts, over 50% of all the Chinook in North America came from Oregon and California. That's no longer the case. The Sacramento coming down way down here for the south, that probably was one of the most productive salmon-bearing rivers. And it had 4 runs of Chinook. There were spring, summer, fall, and winter Chinook. Huge populations that came in to spawn in the wintertime, coming in fat. And yet, in our discussion, nobody's looking. We're somehow trying to save what they require in the summertime, which, yes, is important, but is the food problem happening in the summer, or is it when they're not here and they're coming back in bad shape? And I think that attention needs to be given to the full habitat and start asking questions about the Columbia River, start asking about the Sacramento River. What happened to the fish? Well, some of it we know is turned into irrigation. It can account for some of the strawberries we eat and many other things. But it's not part of the discussion. We're just focused on in our backyard, and I think we have to look bigger and think bigger about it. And here we've got the second part here, which is there is overlap between the northerns and southerns, not so much in the Salish Sea, but one has to ask the question, why can the northerns do so well and they're overlapping in a range used by the southerns? And is there potential there for competition to be occurring? So I would just like to broaden, and before I get into that, the concern about is there enough salmon for killer whales? And I was on this scientific panel. I think there were 8 of us on this panel. And we asked this question, and we had 2 years of workshops, so from 2010 to 2012. And we looked into this long before it became such a huge controversy. And the conclusion was that we felt there was enough salmon in this region for the southern resident killer whales. Fast forward to this spring, we released a workshop report and about the availability of prey. And we looked into, and we had, it was done at the request of DFO and also National Marine Fisheries Service. And we had both government scientists here as well as independent scientists and academics from Chinook and killer whales. And in this, we considered 3 management actions. We did not recommend closing fishing. We did recommend looking at experimentally restricting the movement of vessels to ensure that the killer whales can get access to the fish. So I was at a meeting Thursday, and it was at the Sport Fishing Institute, and there somebody raised the question, so why did Canada close fishing restricted when the US didn't? And someone said just, well, maybe because they read these 2 reports, which is based on science and data. I don't know why it was ignored in Canada, but I would encourage you to read these reports if you want to understand salmon and know more about it. And the thing is that, and I've learned so much about Chinook, to me, spring, summer, or spring Chinook, they were just all synonyms for king salmon. Well, they're not. The biology is so complex and so different, and I know that I had not fully appreciated it until I got myself involved in this process. So, why are they in trouble? And I would just like to broaden the discussion and get people to look also, not just within our backyard, but out beyond. Let's look seriously at the lack of Chinook in Oregon and California to support the southern residents. And let's also do some thinking about, is there competition? If the southerns were to disappear, I would predict that the northerns would move in. And I think we need to be looking at that too, and perhaps even directing some research to look at interactions between the 2 groups to understand that. So how do we get here? To answer that question, I thought it was a good question when it was asked, and I thought, well, maybe one way was to just approach some media articles. And so what I did is, with the UBC, I forget which department did this for me, it wasn't IT, but one of the other ones, and I just asked them if they could do a search for all media articles that use the word southern resident killer whale in it. And I just wanted to see what the change was over time. And here's what you see. So it starts from 1992, out to, and I did this in April of 2018, and I will update it at the end of this year to do the full year. But you see it's been this exponential rise in media interest. In terms of the articles, there's been just over 2,000 articles, 50% in newspapers, and the #1 reporting newspaper is the Times Colonist in Victoria. They love the southern resident killer whales. Vancouver Sun is second in the Canadian press, 60% written in the past 4 years, 50% in BC, only 10% in the US, although I bet I'm going to find that after this year, there's a lot more US articles. 10% positive, 90% split between neutral and negative. The other thing I want to know was, what were the most frequently used words? And so there I look at the lead, that very first sentence of every newspaper article that tells you the whole story, the who, what, where, when, why. And so we did words, and we did these word doodles. And on here you can see that there's no difference between the years up until 2015, other than endangered came up when COSEWIC listed them. But before that, the keywords were baby and orca and new. And so not much change, but everything changed in 2016. And this diagram was no longer round and nice, it was square and angry. And if you can read on there, you're going to see words like trans and mountain, pipeline, protection, noise, government approval. And so what happened here is they became the poster child for the anti-pipeline campaigns. Endangered species and a threat of being put to extinction because of noise or ship strikes, and surprisingly very little discussion about the risk of oil spills. Coming then into the next 2 years, other groups have also seen the wisdom of attaching every cause to killer whales. Whether or not you want to blow up the Snake River Dam, whether or not you want sewage treatment in Victoria, whether it's you want to shut down fishing, everything's being linked, or you want to cull seals. just link it to southern resident killer whales. So that's really how we got here, and then the whole world is sort of in a tizzy, and that's where we are. I do want to also, because I too have got a soft spot for seals. This culling of seals, somebody did ask the question, how real is this? And I want to tell everybody here, this is very real. There is a group called the Pacific Balanced Pinniped Society, and it's a coalition of different individuals. And they have submitted a proposal, is my understanding, to DFO requesting to cull 50% of all the pinnipeds in British Columbia. It's based on a couple of arguments. The number one is some modeling work that's actually done through UBC, is modeling work led by Carl Walters, and it's linking in data used from DFO and seal trends and information in terms of Chinook as well, suggesting that the models predict that if seals were removed, there would be more Chinook salmon. The proposal would be to see this done as a licensed hunt, and with the meat, and most of the hunters would be First Nations. They're being approached, and many of them are joining in on this proposal. Many of them are very concerned that the seals and sea lions are destroying all the fish. There's nothing left for them to eat. I've heard these statements, and they do believe these sincerely. It was on the national news last night, and again, you know, statements, one I recalled was one of the fishermen seining up herring and referring to the pigs in the trough. It's very real. It is being considered, and it's got a life. The BC, I think, certainly among the First Nations, as well as from some individuals involved with sport fishing, proposal is to sell the meat to China. It would not be done as a traditional hunt in the sense of feeding people, which I don't think anybody would have an issue with. But the reality is that people, it's not the best tasting meat, having tasted it. But there is a belief that you could sell it all to China. So Lance touched on many of the reasons that we need to think this through, and I just want to bring it back a little bit more here about the transients and with a little bit more information. And my feeling is, as Lance stated to you, I agree with him, that culling seals will likely harm the transient killer whales. When I was at this meeting, and I gave a talk to individuals attending this annual meeting, I showed some of this data, and previous to this, week before, I was at the Vancouver Club, and I was invited. It was an event hosted by the Pacific Salmon Foundation, and Brian Riddell and I were sitting in 2 armchairs, and we had a conversation for an hour in front of a very small audience. It was filmed, and next thing you know, over 10,000 people have watched this. And people have found it quite interesting. I've received so many emails. But I made a statement in there that, and I haven't actually seen the tape yet, but people sort of wrote to me about this, that I made a comment, something to the effect that transients are feeding on seals in the Saley Sea on a daily basis. And I received some emails basically like, what are you talking about? And these were coming from individuals who have spent tens of thousands of hours fishing. And their comment was basically, I fished all this time, I've hardly ever seen a killer whale, I've never seen one eat a seal. And basically saying that what I said was not right. And of course, this was an armchair discussion, there was no data to be shown, but I've heard stories here. Joan, for example, I've heard her stories. I've heard from many of the whale watching operators. John Ford has filled my ears with this. I remember too in the past that I hardly ever saw killer whales out here, and now transients. So I wrote back to the guy and said, you know, it's funny. So you've spent tens of thousands of hours, I hardly see a killer whale. I've only spent a few hundred hours. I see killer whales every time, but I've never seen a Chinook salmon. And I basically said to them, you know, I think you're going to the wrong spots, and I'm probably going to the wrong ones too. But they had a hard time accepting that. So I was pushed to produce some data. And I recall some of the numbers from Joan in past years. but there is data, and it's coming from largely data that Jane Cogan has compiled. And she's done an amazing job. So I spoke with her, I've spoken with Ken Balcom, and I'm going to show you some of the data in case anybody has any doubts. So this is more than just impressions. This is real data. So this is from 2017, the full year. It's from the Central Salish Sea and Puget Sound. And what they did was to compile information. This is like the perfect example of citizen science. Data coming in from the whale watching boats, from the sightings networks, but it's all confirmed IDs of animals. And what was noted is that, counter to perhaps some people's perceptions outside of this room, they were observed on over 280 days in 2017. That's virtually every day. Some days are over 45. I think the highest number was 62 on one day. And this really caught me. Over 225 unique individuals. So most of these, there's probably fewer than 20 that were from the California transients. They're almost all from the West Coast transients, which number probably just over 350. And so you're getting somewhere between 60 to 70% of the entire population is feeding in the Salish Sea. And in chatting again with Jane and Ken, they suspect that probably every single transient whale comes here at some point in its life. And most noteworthy too is, as Jonah pointed out, there's several new calves, and also there's some new individuals that have not been documented to be here before. Okay, those are just numbers. Let me just show you the real data here. So Jane compiled this, the number of days with transient sightings in 2017, starting from January out to December, and here's the data. So April to October, this every day. And of course, the reason why few were seen in on those small craft warning days, oops, I just said it. There aren't people out looking. But I think that if we did have the ability to search every single day, this whole thing would be full green. The other interesting thing is just like, where were they? Are there hotspots? We always talk about that in biology and ecology, hotspots and where they go. Well, here's the map showing you the confirmed sightings in 2017. It's almost like they're randomly distributed. And it kind of makes sense when you realize that, their mode of operandi is not to ever overfish. It's to go, strike, and move on. But you also see that this is only showing you data here from the central part, south. And I think if we could fill in the northern part, it would be peppered green again. Seals have redistributed, probably because of predation pressure from killer whales. And here's another really fascinating data set, again from the same one. And this is the number of individual animals seen starting in April out to September, and with the highest mark on there being 70 animals per day. And here's what the data looks like. So you can see not just different variability in terms of numbers coming across, but also some days where you've got over 60 animals. And so once we start doing the math in terms of the numbers of seals being removed, I think we can explain why harbor seals have been stable for the past 20 years. So as I'm wrapping up here, counter to what's being said in the media and to politicians and others, our seals are not at an imbalance. The seal numbers are balanced. The killer whales are doing that. Removing them, I believe, is going to cause the transients to decrease. We can probably model that as well, and then you'll need a recovery plan to help save them when you know what the cause is already. The other thing is my sense is, in looking ahead, that this is going to go a bit further yet, and it will come in the media. And if it ever does come out, I showed the individuals there, particularly those that have got companies that are interested in not only catching fish, and having clients that come out, but also celebrating this incredible place we have. As much as people may not like to have a seal take a fish off their line, they do still enjoy seeing wildlife, and particularly seeing killer whales. So I said, here's the headline that I see coming for your future if this goes ahead. It'll be something like this: Killer whales starving as BC slaughters seals to feed China. Just look at the optics behind this. Doesn't make any sense. BC promotes, all its tourism literature has a killer whale on it. And yes, people don't know the difference between a resident and a transient perhaps, but they sure will. Nobody around the world knew what a Chinook salmon was until it was linked to southern killer whales. Nobody cares much about seals, but they all will care once we talk about transient killer whales. Thank you very much. So I'm happy to turn this into a bit of a discussion. I know there's lots of people here with lots of expertise on the situation. I'm also happy just to get a beer.
Dr. Trice, when you talked about seals, were you just talking about harbor seals or all seals?
So I was referring to harbor seals. And if you look, so we have about 40,000 here in the Salish Sea, and the province-wide about 100,000. And their numbers seem to be stable overall and have been. Although it may well be that the transients are now causing a decline in harbor seals. It's certainly not sustainable. The numbers of transients has been going up. And so I think that the cull that some of the groups would like to see, it's already happening. But it's happening in a supernatural BC way. And as I think it should be as well. So the sea lions, though, they are also now forming a bigger part of diets, I think, of the transients. They just have to be. We're seeing them still rising exponentially, but, and we're also seeing new breeding sites being established for stellar sea lions. But they haven't hit K yet. They're not at carrying capacity. The one thing that was so shocking with the harbor seals was we saw them like going to infinity and beyond, and then they just stopped. And that was like totally unexpected. And so we may well see the same thing happen with sea lions. There's some indication that coming out of California, the sea lions we have here from California are just the males. The females aren't coming here, but in the last 4 or 5 years, their numbers have been kind of jagged and appear to be stable, perhaps, although there's also been the blob, El Niños, that are affecting things. But there's something that may be stable, and our stellar sea lions are not yet. They are still increasing. Anything else?
We did have an online question that I could just quickly insert here. It's more of a statement connected to a question. A member of an NGO in Washington just says the growth, and that's in reply to the question, how many seals, how many killer whales we should have in the population. And she just says, it should exceed 200 members to reach historical levels. And she's referring to a paper from 1972 by Palo, who's estimating 225 to 300 whales for our waters. And the question connected to is, basically, we have the numbers. What are your thoughts on that, if you could?
So I'm not familiar with that paper, and I will go look for it. I do question sometimes people's best guesses about how many were here. Certainly at that time, there would have been very poor understanding of the distinction between the different types or ecotypes of whales, and there wasn't that much dedicated research perhaps even to come up with those estimates. So my guess is they were best guesses. And with a background in modeling, I'm very familiar with best guesses. It's like, how many do you think? That seems reasonable. So I think it's worthwhile to go back and look. But I know from what I've heard about some of the genetic analysis in terms of trying to estimate possible previous populations, it would appear that they've not, at least for 100 years. But I would have thought that had we still had the Sacramento River producing Chinooks, still if the Columbia was, we may well have a population of 200 or 300. But I think what we're seeing is a population that has been at carrying capacity since 1960. And it just reflects the fact that salmon runs have been poor overall. But it's a good question and something that needs to be looked into.
So we've heard a few of you talk about culling the seals would probably lead to decline in the transients. And heard Lance talk about how they feed probably on estimate around 30,000 seals per year. So has no one actually done the predictive models to indicate that this would be the case, seeing as you have the evidence, the population trends that show to the media that...
There have been, I remember Peter Lysiak presenting some numbers where he calculated the numbers of pinnipeds that would be consumed by transients. And he did it and basically showed that it takes a very few number of whales that can explain the missing animals, because not every animal that's born lives and adds to the population. So that math was done. The part that's not been done is to look at what's the consequence if you reduce the size of the seal population. And that's looking at it in a different way to make a projection. So some people have said, you know, actually, if we reduce the seal population, they're going to become more productive, they're going to produce more, pregnancy rates go up, so there's actually going to be more food for them. Well, having worked in northern fur seals on the Pribilof Islands, that was the argument made that almost destroyed the entire population. It was faulty thinking in the model. So it's one thing if a population of seals at carrying capacity because it is food limited, and you reduce it, then you expect then to release it so it does have more pups. I'm not hearing from Marty or others that they're getting all these emaciated seals that are because the food has been overeaten. They all appear to be healthy, which suggests to me that they're at carrying capacity because of predators. So reduce that, you're not going to get more. They're already pumping out lots of pups. They're a healthy population, and they're kept healthy, largely I think because of the transient killer whales.
Andrew, I'm a little troubled by the, and I've seen you deliver this a few times now, the discussion about the trends in the numbers of killer whales, of southern resident killer whales over the last few years, over the last 40 years. I don't see why 1960 is a magic baseline. There are papers. I did one. The Palo one is another one. The reconstructions of salmon, as you said at the end, suggest that the population was much higher. And I mean, I think, and John Ford used to make this exactly the same case that you did. He said, you know, we have to be careful talking about them declining. But John did it differently. John said, we have to be careful about what time period we're talking about when we talk about a decline. And he always talked about a much longer time period. You know, you agreed that the 74 animal, you know, population size right now is in dire straits, and demography is part of that. So I mean, this is a great conversation to have over beer between colleagues like us. I don't think that's a great thing to put in front of the public because it really confuses them. Scientists can't even agree on whether the population is declining. You know, so I would counsel you not to do that. It's up to you, of course, but I don't think it's helpful. Secondly, I think this case that you make that when regulations come into place, they never come off again, is wrong. And I think it's very inflammatory. I think the public look at that and go, God, if I'm a sports fisherman, every time there's a rule, I'm stuck with it for life. Because you're right, it may not come off because the population has recovered. I was at a meeting last week where there was, within DFO, where there was a lot of discussion about these things. And those regulations will come off if they're not effective. And effectiveness, it doesn't have to be measured by the recovery of the population. It can be easily measured by, in other ways, by, is it having the desired consequence? If you put sport fish closures on an area that you think is an important southern resident killer whale foraging area, and the southern resident killer whales never go there, the regulation comes off.
So maybe
they'll come off.
Let me just do a couple of questions.
There's lots of other things. I have to do the first part of the talk.
So the reason I say that I don't see them coming off is because they're all being linked to not being effective. They're being linked to recovery, but that's not. Well, I've heard this. Well, I was just at meetings this week where I heard some comments made about we want them to recover, and so I think it's still coming down. And effectiveness means to get to that point of seeing the desired response, which is recovery. But what does that mean? It's a very vague concept. But the other point, I just lost my thought on that. Yeah, it's almost beer time. No, I know the other point I want to make on that is one of the things we did in our workshop report is we were all very adamant that if you put in a management action, you need to put in a research program to monitor if it has any effect. That was not done. And so, yes, it was closed. And we're not going to know if it actually resulted in more fish or not. There's no study done.
And that's my biggest disappointment, is if we put in action, we have to learn from it. We just can't go to bed at night, sleep quiet and think, yeah, we did the right thing. I'm sure it's working. We should, and we can collect data to evaluate it. And I agree, if that was being done, then I'm on board with you and saying we could show that it made no difference, so why are we doing it? But that's not been done. And the last point I just make in terms of earlier comment is that I see myself as a professor at a university. We're in the business of education. We're in the business of talking to students, training students. We're also in the business of talking to stakeholders and talking to everybody that's in this room. And yes, we could well do, for example, a symposium that only the purebred researchers get to talk or speak together about it. But we're streaming this. And I think that we have a responsibility to share our knowledge, raise questions, challenge conventional wisdoms, but be open-minded in the process. And if some of the comments I made today stimulate people to think, wait a minute, I've got a problem, well, let's sit down and talk about it. Because I think it's through this dialogue that we're going to find the solutions. They're going to help southern resident killer whales and going to help transient killer whales too. And that may be, oops.
There's been a lot of focus on the predators as, you know, at one end of the spectrum. So whether it's sport fishermen or whether it's seals. But what about the other end of things, which is the prey availability and habitat enhancement? You touched on it briefly in terms of what's happening in the U.S. and the loss of prey down there. But, you know, do you think that there's enough being done about prey availability here?
So I don't think there's enough being done on either side of the border to really address this question. And when we say the word prey availability, it's a loaded term. And we try not to use that word because it's confused with abundance and accessibility. And these are two separate things. We want to make sure that the abundance is high enough, but also that the fish that are there are accessible. And so it may well be that in our reports that we did that the abundance is sufficient, but the whales can't access them because they're losing opportunity to get to them. And both are testable hypotheses and data, and certainly the data that May Sato and I are working on is focused really on that abundance part, but we're not looking at the accessibility. And some studies have been done in the past, but I think they can be better focused. And it requires working collaboratively with the stakeholders as well to get their collaboration and cooperation, to collect the data to understand whether or not the mental models we have about how we think that system works is right or not.
Coming from across the border, this is clearly a binational issue. Mm-hmm. And so I'm curious how much collaboration is going on, if you know, not only between researchers, but also between governments.
I think my impression is that on one level there is a lot of cooperation. Certainly when we ran the workshop, we had everybody coming together, and I felt it's a very constructive group of people. I think all looking to find solutions. At the same time, though, once we go home, it's almost like there's that line, and there's not the same flow that you would expect. So on one level, yes, there's cooperation, but at the end of the day, people work within their own institutions, and those are often delineated by borders. So it's kind of a yes-no, and probably at the end of the day, more can be done. But I don't quite know what the path forward is on that, other than there's still a lot of conversations between the key players.
So my data looked back at 3 years to 2016 because, anyway, I wasn't really looking at this in 2015. For those of you with a longer memory, 2015 was an awesome year for Chinook salmon. There were a lot of babies born, and when we talk about foraging areas for the southern resident killer whales, what I noticed is that the only people that are really making observations of southern resident killer whales around the Fraser River and the banks and down to Point Roberts, whale watchers. Where are you researchers? Because those whales on a good Chinook year, when the Chinook are running, come up here and they'll stay for 2 or 3 days. They're probably foraging at night because they're resting during the day. So, you know, if the salmon are there, the whales are doing their thing, and this is one area where I feel like it's really been overlooked as far as research goes, to know what they're doing, and this has to be one of their prime foraging areas.
Mm-hmm.
There's very little actually seems to be known about it.
Right, and that's a good point. It's, you know, it's something just within BC, the Canadian government has spent a huge amount of money over the past year and a half investing in killer whale research. And a lot of money is being spent. You heard a little bit from May's talk, and you saw a little bit in the video, in terms of a piece of that. Lance has got a program. You heard touches of that today. There's a program over at UVic. DFO has a huge program as well, which was not presented today. We actually have to get together ourselves. We need our own workshop just to compare notes, because we're all, at this point, sadly, kind of working individually. And I think we do need to get together. And part of that is just, well, we just finished a busy field season. We're all pushed for time. And gosh darn, it's the annual BC Marine Mammal Symposium. And now it's Christmas coming. But we do have to cut out time. And I think it's time for us to sit down and have some of the conversations, like for Lance and I, to really nail it down with others too. And hopefully come up with, you know, speaking from the same page more often than not. But at the same time, I think that having these sorts of discussions is very healthy. None of us has the answers, but collectively I think we can find the right answers and the solutions. So a question back there, and I'm just conscious that we're hitting 5, and one more up there. Go ahead.
Hi, you've mentioned some trends dating back to the 1960s, with the all-time high in, I think, 98 you mentioned. I'm just wondering if there's any kind of management initiatives or limitations that have been known to influence the population.
So I don't think I quite understood. If there's any management
Limitations or initiatives that have actually influenced the population trends?
The only one was the decision in the 60s to remove whales for the aquarium industry. Other than that, it's been pretty much hands-off. They've done their own thing. And, you know, I'd say on the biology side, I don't recall any biologists ringing the alarm bells. There's a real problem. Not that some people weren't really concerned about them, particularly over the past 7-8 years. But it is now front and center. And I know it's taking up a lot more of my bandwidth. It's taking a lot more of the bandwidth of practically every stakeholder in BC that works on the ocean as well. So we're getting management in there, but again, it's there's so much being done. We still need to sit down and compare notes. But I think like next year, we should have even more data. May is going to show us Johnson Strait, summer, winter. We've also put in for a very big grant to collaborate with others with the Pacific Salmon Foundation to start catching and tracking salmon that killer whales depend on. Do more fine-scale tracking just using hydrophones and arrays. And if this goes forward, it's going to be a huge boon to really figuring this thing out. So there's a huge momentum underway, and I think next year you're going to hear a lot more research, and more than just here's what we are doing, but here's what we found. And these are the questions we now have. Done? I am going to wrap it up at this point. First, I just want to thank you. We've never had this many people stay to the very end of the day. It's just like amazing. With 300 people that registered this year, it took a big team to put this together. And number one, I need to thank Pamela Rosenbaum, who handles most of the email and registrations. And the other 3 that I'm really indebted to is Marcus, Christine, and Hunter. And Rob as well, who always has his back to you. But collectively, these 4 individuals have brought us to a whole new level in terms of getting the technology to work. And again, allowing us to talk to a much bigger audience than when we started this with only 30 people 26 years ago. The Marine Mammal Research students and staff have just done an absolutely awesome job today. They helped out with name tags and opening doors and running all around and doing everything that it requires to make this successful. And I'm very thankful to that whole team. And so we've got Aaron, Beth, David, Joanna, May, Ria, Sarah, Selena, and Zach. And finally, I want to acknowledge our sponsors as well. As you notice, it hasn't cost you a penny. And I've been very fortunate to be able to go to the Pacific Wildlife Foundation and say, would you mind contributing some cash? The Pacific Whale Watching Association too has been just phenomenal. And I've really appreciated that, and it's this collective spirit of community that helps make this so successful. And I really appreciate just how well the speakers did today. You all stayed within your time limit. That was awesome, and we had 37 talks. Thank you all for coming. And the next one, it is on your agenda. Please mark your calendars as November 23rd. And that's like 3 weeks before the big biennial conference in Spain that I know many of the researchers will want to go to. So if you're watching online, you're going to go to Spain, you better be here first. We want to hear it first before you tell the people in Spain. Thanks, everybody. Thank you for watching online. We hope to see you here next year. You can leave the blinds down.
Pardon me?